Hello and welcome to over 8 hours of TypeScript tutorials and instruction. This video is made up of 17 tutorials that build upon each other much like the chapters of a book. Throughout the lessons in this video, I will mention links being available in the description below. I've compiled all of these links into one GitHub resource that you will find in the description. Hi, I'm Dave Gray, and I'm the creator of these TypeScript tutorials. You can subscribe to my YouTube channel for more tutorials like this one. You can also follow me on Twitter, and if you're feeling generous, you can even buy me a cup of coffee. Let's get started learning TypeScript with Chapter 1. What is TypeScript? We're on the TypeScriptLang.org webpage, and that is the official website for TypeScript. And you can see they say TypeScript is JavaScript with syntax for types. They go on to say TypeScript is a strongly typed programming language that builds on JavaScript, giving you better tooling at any scale. We'll talk more about strongly typed programming languages and how TypeScript builds on JavaScript. But what they really sum up nicely here is TypeScript gives you better tooling because TypeScript is a developer's tool and it helps you write better JavaScript. Now, TypeScript is created by Microsoft. And just a little bit of a detail here, the person that created C# at Microsoft is also the person that created TypeScript. Both TypeScript and C# were created by Anders Hellsberg. And I'm going to put a link to this article in the description because in the article there is a link to a video, and that video has Kent C. Dodds interviewing Anders Hellsberg. So if you're interested in learning a little bit more about who created TypeScript and C#, you could watch that video. And then I want to draw your attention to the Stack Overflow Developer Survey. They do a survey every year, and we're under the most popular technologies, and we're looking at scripting languages here, or programming languages in this category. And you can see JavaScript is at the top, as it has been for the last decade. But in the 5th position is TypeScript. Now, TypeScript compiles to JavaScript. If you're not familiar with compiled languages, you'll be learning more about that soon as we learn more about TypeScript. But this is very interesting because essentially TypeScript is JavaScript, but you're using TypeScript to help you write better JavaScript. Now, as you begin this TypeScript for Beginners course, I should point out that a prerequisite for learning TypeScript should be already knowing the JavaScript fundamentals. Now, I have a JavaScript for Beginners course, and I'll link to that in the description as well. TypeScript is a superset of the JavaScript language, and that means it extends JavaScript. And that makes learning the fundamentals of JavaScript before TypeScript very important. As mentioned, TypeScript is from Microsoft, and so is Visual Studio Code, which is the code editor that is very popular right now, and I use it all the time. And TypeScript is integrated into Visual Studio Code very nicely. So that's the editor we're going to use in this series as well. So if you don't have Visual Studio Code, you want to come to this site, which is code.visualstudio.com, and I'll make sure to link to that in the description as well. And you can download Visual Studio Code for whatever platform you have. You can see I'm on Windows, but it's also available for Mac and Linux. After that, you'll also need npm, and you get that by installing Node.js. That doesn't mean we're going to necessarily write any Node.js, although we could, but what you really need is Node Package Manager, and that npm installs with Node. So just get the LTS version here, which is recommended for most users, once again, for whatever platform you're on, and it should auto-recognize, as it recognizes that I'm on Windows. Download and install that as well. After you've done both of those things, go ahead and open up Visual Studio Code to an empty folder. I've got Visual Studio Code open, and I am in an empty folder. I named Lesson 1. You can name your folder whatever you would like. From there, I'm going to open a new terminal window. You can do that from the terminal menu, or you can press Control and the backtick. Either way, we get a terminal window open here. And now I'm going to use npm, and so I'll type npm and I for install. After that, I want to type TypeScript and also -G for global. And then press enter, and it shouldn't take too long to go ahead and install TypeScript globally. So now it will be available. So let's go ahead and create some files, and then we'll come back to our terminal window. So here in the file tree, I'm going to click for a new file and create an index.html. Inside of the index.html, go ahead and type an exclamation mark, which is an IMID abbreviation, and press Tab, and I get the outline of a new HTML document. Here inside this document, I'm going to go ahead and add a style tag, and then just add a body style. I'm going to make the background color black, just because it will help save my eyes a little bit if we have to look at the web page instead of a full white web page. So there we have the style, just an empty document right now. Now let's create a TypeScript file, and I'm going to name it main.ts for TypeScript. Inside this TypeScript file, let's just define a username. So I'll say let username, and I'll set this equal to my name. Then I'll say console.log, and we'll just log that username variable. Once we save this, you can see we're writing JavaScript in the TypeScript file, which is fine. Back here in the terminal window, let's go ahead and type the TypeScript command, which is tsc, and then we name the TypeScript file, so main.ts, and then we could name our destination, which would be main.js. But really, if they have the same name, we don't even need to provide that name. So I'm just going to say tsc space main.ts and press enter. And let's see what happens. We're going to compile a JavaScript file from our TypeScript file. Let's look at this JavaScript file. Now that it's open, you can see it says we have a problem here. We didn't have that until we opened this file, so I'll cover that in just a second. But first, let's notice that it uses var instead of let, as we did inside of our TypeScript file. That's because TypeScript can compile JavaScript to be compatible with older browsers. And that's something we'll get into more as we cover the config file for our TypeScript. But right now, it's just worth noting that this is using var and not let. As far as the error goes, if we mouse over here to use IntelliSense, it says cannot redeclare block scoped variable. It only is giving us that error because we have both of these files open, and this same username variable is defined inside of both files. So if we close the JavaScript file, that error goes away and everything's fine. So let's go ahead and link to our JavaScript file now inside of the HTML. So I'm going to type script and choose the one that has source. There we go. And then I'll just say main.js. I'm also going to put defer here just because I usually do. That means load the DOM before you go ahead and load the JavaScript. And so now with that in place, I'm going to click the Go Live button here to run the index page with live server, and notice it's just an empty black page because we set the background to black. So I'll go ahead and open up DevTools again with Control Shift and the letter I, and it logged the username to the console. It's valid JavaScript, and it was compiled from our TypeScript. Now, just so we can continue to see the console while we work in Visual Studio Code, I'm going to click the three dots here and choose to put the console below the web page, so that's where the dock is considered to be. And now you can see I just had it all the way to the top. So pretty much we just see all console in the browser. I'm going to drag this over here to the right and pull our code to the left. Now I'm going to go ahead and choose the main.ts file and press Ctrl-B to hide the file tree, just so we can see everything clearly over here. Now, if we were to make a change here, right now, every time we would make a change and need to recompile our JavaScript file, we would have to once again run our TypeScript.main.ts command in the console window there, in the terminal window. So if I make a change here and say the username is now John, and I save, we're not going to see that over here, even though our page has live reload, because we didn't recompile the JavaScript. Now, we could once again run that command. Well, there we go. I need to go ahead and type it again now. So tsc, and then we could type main.ts, and we could, of course, continue that same pattern. But the other thing we could do is just type tsc, the file name, and -w for watch. So it will continue to watch our main.ts file for any changes. So let me go ahead and do that and press enter. And now you can see live reload took effect because we recompiled. And so now John is over here. So now I'll just change this back to Dave, and save the file once again, and it recompiles, and we see Dave over here. And this is great if we're just working with one file, but it's not typically how I would structure a project. So I'm going to pull this back to full screen, go ahead and press Control-C to exit TypeScript from the terminal window. I'll show the file tree again, and right now you can see we have no folders here. Typically when I would create a project, I might have a source folder, and if you're familiar with React or another library, you might be used to seeing this already. And then I would also have a build folder, and it shouldn't be in the source folder though, so I'm going to get away from that, collapse that, and now just create, no, it still did it because it was highlighted. There we go, I'll highlight that. Now I can create a build folder at the same level as the source. Now the build folder is where we would have our compiled code. So typically we would have our index HTML inside of the build folder, then we might have a CSS folder inside of the build folder, and a JavaScript folder inside of the build folder, and so on. And we would have our raw code, maybe our TypeScript, inside of the source directory. So that would make more sense for a larger scaled project. So how can we get TypeScript to know all of our TypeScript files are in the source directory and then compile them and put them not only in the build directory, but also maybe in a JS folder inside of the build directory? Right now, of course, it holds nothing. Let's go ahead and put the index.html file in there. And then here, we'll go ahead and delete the JS file. And this main TS file, let's put it inside of the source directory. Now, say we would keep all of our TypeScript files here, we would keep all of our HTML here inside of build, but then we would also have a nested directory named JS that would also be inside of build. So let's open a terminal window once again, and we can do this with a TypeScript config file. So now I'm going to type tsc and then dash init, actually 2 dashes, pardon me there. So this would be init for initialize. I'll press enter. And now we have a tsconfig.json file. I'm going to close the terminal window just so we can see everything a little bit better. And what we want to find first in here is the root directory. So there are many, many settings, but here's the root directory. So we can go ahead and uncomment that. And let's set this instead of // which was the default, and that's where our tsconfig is. It's not inside of the source or the build, it's out here, and that would be the root // Let's go ahead and set this to / source, because that's where our TypeScript files are going to be. Now we'll save the config file, but there's more that we want to find too. We also want to find the out directory. So I'll go ahead and do Control F, just so it will help me find, and I'll type out dir, and here's the out directory. So now we'll uncomment the out directory, and we want that to be in the build directory and then inside of a JS directory as well. So that's where the JavaScript will now be compiled. Okay, with those changes in place, let's open up the terminal once again, and let's type tsc-w. We do not have to specify any one file at this point. It will just look for all the files in that directory. So it's just telling TypeScript to go ahead and start watching where we specified the root directory was. I'll press enter, starts watching. Notice it created our JS directory because it didn't already exist, and then it created the main JS file for us. After that, let's go ahead and create another TypeScript file over here just to show that it's watching all files, and I'll call this test.ts. And now it already created it, even though we don't have any code in there, but it does have useStrict at the top, as you expect to have in every JavaScript file compiled by TypeScript. But if we go ahead and add something here, like let test equal 1, 2, and we save that file, now if we look in our test file, it's already over here in the test file. Now notice, now that we have a TypeScript config file, it went ahead and used let to initialize this variable, just like in the main.js file, it used let here and not var. So let's go back to this TypeScript config and we can look at why. As I scroll up, we find the target setting and it says ES 2016. And that's why we're now using that let keyword, because that's part of ES 2016. But we could roll this back if we wanted to an older version of JavaScript to be compatible with older browsers. So let's say we used ES 5, and let's save this. Now it will recompile those files. So let's look at our test.js. Now it uses var. If we look at the main.js, we also see var here. So it immediately recompiles based on those changes. Now I want to use ES 2016, so I'm going to undo that change and resave the config file. Once again, we go back and look, and now it's using the let keyword once again. Now it's also worth noting that if I delete my test.ts file, it doesn't automatically delete the compiled file. So just remember that if you decide to eliminate a file from your TypeScript, you'll also need to do that from your JavaScript. But here's another setting that we need to adjust, because we have told TypeScript to look inside of this source directory and only compile those files to our JavaScript. But what if we put a TypeScript file back in the root directory here? So I'm just going to say root.ts. And look, it compiled it too, and it put it in the root. We don't want that to happen. We want to ignore any TypeScript files that are not in the source directory. So let's go ahead and delete these files. And then let's go back to the config file, and we'll scroll all the way to the bottom of the config file. And once we're at the very bottom, I'm going to put a comma right here. And then we'll come down a line, and I'm going to put the word include, and then a colon, and then a bracket here, just like I'm creating an array. And I'm going to name the source directory and save this. Now, I've saved that, and now I'll once again create a root.ts file outside of this source directory. Notice it didn't automatically compile to a JavaScript file at this point. So now TypeScript is ignoring any TypeScript file that's not inside of that source directory. I'm going to go ahead and close the terminal, and now let's go ahead and delete that root.ts file that we no longer need again. And let's go back to our main.ts file, and let's write some more code here. Let's start by defining some variables. I'll just say let a equal 12. Then I'll say let b equal 6, but we'll make it a string. And then we'll let c equal 2. And let's just go with those three for now. Now I want to save this, and it should compile right away again to the main.js file. And there we have our three variables we just created. But we need to remember to go into our index.html and adjust for our current file structure. Earlier, we just linked to main.js when we had that in the root directory. So let's go ahead and specify the JS directory where we can now find our main.js file. Save that as well. So we're going to have to stop our port because we had started live server in a separate location before. So now that we have made that change, let's go ahead and click go live now that we're on the HTML file. Once again, it will start our page up. We have a blank page here. I'll close the previous one that we had, but now we can open the dev tools once again, and we have live reload enabled. We have Dave here, that's fine. And it's Dave on the reload without that live reload enabled. That only shows the first time. Let's go back to Visual Studio Code now, and we'll close this out and drag this over to the left so we can see our console as well. We're interested in the main.ts file. Control B to hide that file tree so we can see everything. Now that we have these, let's look at some operations that would normally be okay in JavaScript. We have all number data except B is a string. But what if we had A divided by B? And if we save that, that's valid JavaScript. JavaScript doesn't mind the data coercion between the 12 and the 6. Notice we just divided the number 12 by the string 6. And JavaScript uses dynamic types, and therefore it coerced the data to the type that it wanted, and that was the number 2 as the result. That doesn't happen in strongly typed languages or when you're being strict with data types. And you can see here, TypeScript doesn't like this, even though as we look in our JavaScript file it has no problem. We have a red squiggly here from TypeScript. When we mouse over, it says the right-hand side of an arithmetic operation must be of type any, number, big int, or an enum type. And you can see that TypeScript has defined b as a string above. It inferred the type. We didn't tell it. And by infer, the word infer means to figure out. So it figured out what type it was without us telling TypeScript the data type of our variable b. Now let's go ahead and do another console log. And we'll say c times b. And if we save, we once again get a number in the console, number 12. Let me make the console just a little bigger too. There we go. Now you can really see it. But over here on the left, our underscore, or our little red squiggly, once again is TypeScript saying, hey, this isn't quite right. This could be better. Something isn't all good with TypeScript. However, TypeScript does not get in the way of JavaScript, of your previous JavaScript even. So you could take your old JavaScript files and put them into TypeScript files. It will still compile. However, you will get lots of warnings from the compiler because it will see things it does not like. And that will help you fix those errors and make that code better. So what could we do here to make this better? Well, we can explicitly tell TypeScript what these are, or we could just look at the error and go, oh, we made a mistake. This should have been a number. And kind of when we explicitly do that, it makes us think about it more often as well. So we could have, for example, some valid TypeScript code would be to say let a, and then specify this as a number type before we say equals 12. And then with let b, we could say it's a string type. And then with let c, we could once again say it's a number type. But that would tell us that we probably shouldn't be taking a string divided by or multiplied by a number. So to fix these, for TypeScript to like us better, we might want to change this to a number type as well. And then, of course, remove the quotes and just say it's a 6. Now when we save, we see no errors here from the TypeScript compiler, no warnings that it doesn't like what we're doing, and our JavaScript is still valid. So the big takeaway here is that valid JavaScript is valid TypeScript, but that doesn't mean that the compiler has to like it. And we want to pay attention to the TypeScript compiler to help us write better code. Okay, I'm going to drag this back over to full screen, and then let's look one more time at our tsconfig file. And there's a setting in here. I'll press Control F to try to find this setting, and we'll say on emit, there we go, emit on air. And what I really want is no emit on air. So I'll scroll this over and we'll go ahead and uncomment that. So we have no emit on air is true. So if you don't like the normal default behavior of TypeScript, where it goes ahead and lets things that the compiler does not like turn into JavaScript, if it lets it go ahead and compile it, actually. But if you don't like that and you want it to not compile, if there are any TypeScript errors, then you want this setting. And so what I'm going to do is delete the JavaScript file. And now we should have an error, so it's not going to create another JavaScript file. Well, we removed the error actually. So let's go ahead and make an error once again. I'll switch this back to a string, and then we'll say this is the number 6, and we save. And now if I drag this over, well, we're not finding the main.js file at all because it didn't recreate it. However, we could go back now and comment this out so it will compile even when there's an error, and we save, and now it creates the main.js file once again, even though there is an error in our TypeScript file. And a final note on that no emit on error, let me open up a terminal window again, and I will stop TypeScript for now. If you wanted to leave that out of your config file, but you still wanted to run it occasionally, you can do that in the terminal window by typing tsc _ no emit on error. And then, of course, we'll use the watch flag as well. Now, this would override whatever is in the config file. So we just added the flag to our TSC command in the terminal. And now, if there's an error, it's not going to emit the file. And we'll be able to see that once again by deleting the main.js. And it does not recreate it at all. So we have an error over here now. But if we go ahead and stop this, and then start the terminal or start TypeScript in the terminal once again with just TSC and our watch flag, now it will start watching and it will go ahead and make the main.js file again because we left out that no emit on error flag. So that is an option if you do not want to let TypeScript compile your JavaScript if there are any TypeScript errors. Okay, we've learned how to add some explicit types to our data in TypeScript today and lots about the config file and setting TypeScript up, but there is much more to cover and I'm looking forward to continuing in the next video. Let's start today by covering some terminology. That is the words that you will likely hear or read and what those words mean as you learn about TypeScript. Strongly typed languages demand the specification of data types, and that's what we do in TypeScript. TypeScript is a strongly typed language where we specify the types of data that we are using, and that helps to self-document, hint, and enforce our code. Loosely typed languages do not require type specification. And you've experienced this already with JavaScript. JavaScript is a loosely typed language, which you may also see referred to as a weakly typed languages. Those terms are synonymous. This relates to static typing and dynamic typing. However, statically typed and dynamically typed is not the same thing as strongly typed and loosely typed. With that consideration, you should know that a programming language that is strongly typed can be either statically or dynamically typed. TypeScript is a statically typed language, and that means types are checked at compile time. In contrast, JavaScript is a dynamically typed language, and types are checked at runtime. Just a few of the TypeScript benefits include self-documenting code, catching errors during development instead of while running an application, and it's great for teams. Our starter code today is the code we finished Lesson 1 with. I'm just in a different folder now named Lesson 2. I'm going to select all of the code in our main TS with Control-A, and then just press backspace to get rid of that code and go ahead and save an empty file so we can start over. I'm also going to open up the terminal, and if you remember from Lesson 1, we can start TypeScript with TSC. Then I'm going to give it the watch flag, which is a -W, and so it will take any TypeScript file that we create in our source directory and then compile that to a JavaScript file that we have inside of our build directory and then inside of a JS folder. So I'll press enter here, and we set all of that up in Lesson 1 in our tsconfig.json file. So if you haven't watched that, of course, go back to Lesson 1 and you will learn how to set all of that up. Now I'm going to go ahead and close the terminal window for now. And let's talk about some more terminology. I wanted to start out the lesson with that short little presentation on terminology because it can get confusing as we talk about these things. We're also going to be talking about how TypeScript infers what type of data we're working with. So let's quickly look at that. I'll type a variable here called my name, and I'll just set that equal to Dave. And now this is where TypeScript infers. This looks just like JavaScript. It doesn't look any different. But if I mouse over to get some IntelliSense hints here, I see let my name, and then it says string. TypeScript has inferred what type of data I am creating here with the string because I created a string like I would in JavaScript. Now, this is implicit, so that's another term. So besides inferring, meaning I have implicitly shown that I'm using a string. So that means it just wasn't strictly stated. So being explicit means I'm going to absolutely state that this is a string. Now I can do that in TypeScript by putting a colon and then putting what type of data I have before the equal sign. So now I have explicitly said that this is a string. TypeScript no longer has to infer any type of meaning either because I said it's a string, so it's no longer inferring. It already knows it's a string because we absolutely and explicitly declared that it is a string. So what does TypeScript do with this new information that, yes, it's definitely a string? And whether we infer or, of course, implicitly declare here or explicitly declare it, TypeScript would be the one to infer. But even if I do not explicitly state, TypeScript is going to infer that data type. And now if I try to set my name equal to a number 42, you can see the compiler does not like that at all. We get our red squiggly here saying, hey, you're doing something wrong. This is supposed to be a string. So when I mouse over, we get some more help from TypeScript. And it says type number is not assignable to type string. So this would normally be a completely legal operation in JavaScript, where we could use the let keyword to declare a variable and then reassign a different value that is a different data type, but not with TypeScript. This is something TypeScript does not like you to do. So at this point, we know we need to assign a string here and only a string type. So we could go ahead and once again declare that this is a string. Likewise, we don't have to assign a value at all. We can just say, here's a variable that I am going to assign string data to, even though I don't do it immediately. And so now my name equals 42 still doesn't work. This would need to be a string. So my name would equal Dave, and now TypeScript is happy. Now, it's worth noting that this does not prevent us changing the value, as that is totally permissible. We could change my name to John, and it's still okay because John is still a string. So it doesn't prevent you from assigning another value, say as if we were to use the const keyword here instead of let. Of course, that would not allow reassignment. However, using let is completely okay in JavaScript, and we can reassign another string type, but it has to be a string type because that's what we said we're using. And I'll get rid of this line that says Dave right here. I'll go back to what we originally did, which was assigning the value right away, but it does not have to be done this way as we demonstrated. So let's go ahead and create some other types here as well. So I'll say let meaning, if I could spell meaning, of life, and we'll make that a number. And then we'll say let is loading, like we were to have an is loading state, and we'll say that's a Boolean type. Now notice we haven't assigned any values there yet. So underneath, I'll say the meaning of life equals 42, and then is loading is going to be equal to true. And those are all okay, but is loading, of course, couldn't be a number type because it's definitely a Boolean type. So it needs to be true or false. Likewise, meaning of life couldn't be a string. So if we were to say code, that's no good because it has to be a number. Now there's one more basic type we should cover here. So I'm going to create another variable and I'll call this album. And instead of assigning a specific value here, I'm just going to say any. This is a type, the any type. Now, in some ways, this will just simply defeat TypeScript because it allows any type of value. So for album, if I wanted to say album is equal to, let's say Van Halen, that's fine. It's a string, but we could also use a number like 1984. And TypeScript is fine with this value being a number. We could even say true. And it's fine with that because this is the any data type. And when we mouse over with IntelliSense, you can see let album up here. I mouse over, it says let album is the any type. That means it can be any data type. And you can see how that essentially defeats JavaScript. I said JavaScript, TypeScript, but at the same time, that doesn't mean it's bad because there are some times you may need to use the any type. And there could be a time, say, that you're not sure what type of data you will be receiving, so that may be one instance. But just keep this in the back of your mind for now, that the any type does exist. And while you do not want to use it all the time because you would be defeating the purpose of TypeScript, there may be some specific times where you would need to use that any type. Okay, now let's create a function. I'm going to call this function sum. and it's going to receive two parameters, A and B. And then inside of the function, we're just going to return A plus B, which would be the sum of the parameters. You and I would look at this and assume this is a function that adds two numbers together. And I might even typically name these parameters num1 and num2 to indicate that they were numbers. However, that's not what is happening here with TypeScript. And you can see the little squiggly lines under A and B. So let's see what information we get from the IntelliSense about these function parameters. As I mouse over A, it says parameter A implicitly has the any type. So when TypeScript can't figure out exactly what data type you may want there, it's going to assign the any type. If we mouse over B, we're going to get that same message. Parameter B implicitly as the any type, because we can use the plus symbol in JavaScript as concatenation. So we could pass in a string and a number, and it would be a completely legal JavaScript operation. So TypeScript just isn't sure what we want to do here. But we could say that A is definitely a number, and let's go ahead and give that space there. And then we could say B is also a number, and let's see what TypeScript does. It seems to be happy now, no red squiggly lines. So let's mouse over the function sum and see what it says. It says it receives two parameters, A and B, that are both numbers, and it also says, as you see at the far right, it's going to return a number. So TypeScript can infer what a function is going to return based on what it knows about the function, and it knows it is receiving two number parameters, and it returns the sum of those numbers. So let's change this up, and let's say B is supposed to be a string. So now we have a number and a string, which is still completely legal in JavaScript and TypeScript. We'll just mouse over sum once again, and now we can see a difference. It says sum receives a number and a string, and it's going to definitely return a string. TypeScript can once again infer that what will be returned when you add a number and a string together is a string data type. So there's one more type we need to cover, and let's go ahead and do that. And instead of the any type up here now, I'm going to make this a union type, and I'm going to say album can be a string, or it can be a number. This is a union type, and we could of course say or again and put another type and so on, but this lets TypeScript know that this variable is going to hold a string or a number, and either one is okay. This is called a union type. So now you can see album is still good when it has 1984, but once again we could say that it is called Van Halen, and TypeScript is still good with the value of album. No red squiggly line from the compiler now. But if we said album is true, then we once again have a problem. So it can only be a string or a number. So let's give it the 5150 album name from Van Halen. Once again, TypeScript is just fine. So let's switch this back to any just so we have it in the course here. And besides that, underneath, I'll define a couple of new data types that could possibly be string or numbers. Let's say we have a post ID, and we're going to say that could be a string or a number. Let's say we were working with an API that returns the post IDs as strings, and we're going to work with them as numbers, and we just set it up this way with a union type. And of course, I'm just making up a fake reason to do this right now, just something off the top of my head. But this is something you could have a union type for, a post ID. Also, you could have, say, a is active value, and this might be a number, or it might be a Boolean type. That's because sometimes Boolean, true and false, is referred to with a 0 for false and a 1 for true, but you might want to handle it with a number or the words true and false as Boolean. And so this is something you might assign a union type for. Again, I'm just kind of making that up as I go, but I think those are reasonable instances where you may want to assign the union type, where it could be two different data types. Or remember, a union type can be more than just two different data types. So we could also come over here and say string, and this would still be completely legitimate TypeScript also for a union type. I'm going to remove that now, but just know that it is not limited to only two data types when you create a union type. And I'm going to use one more example that is not necessarily a basic data type, but it's just something that's good to know about TypeScript and how it can help you when you're taking an existing project and converting it to TypeScript. So I'm going to say let RE, which is going to stand for regular expression, but I'm not going to assign that, or I'm not going to declare what type it is. I'm just going to assign it a regular expression here. So I'm going to say /w plus, and then make that global. So this is a regular expression that would select basically all words. And now we don't know what to assign this. So if I'm converting an existing project and I'm unsure what data type is a regex, we could mouse over and use the IntelliSense, and you can see TypeScript infers, and it says it's a regex type. So let's go ahead and give that here. Regular expression is what that stands for. So that is the accurate type. TypeScript actually tells you what you can put. And using inference, when TypeScript infers, that is okay too. But as we learn, I think it's good to go ahead and assign the different data types as well. So the basic types we've covered today: string, number, Boolean, and any, as well as union types. And we've even seen a regular expression type. And we have seen what a function might also return in addition to what it receives as parameters. And overall, how IntelliSense can really help us and how it continues to help other developers that are working with your code. Now, in the next tutorial, we'll be covering objects, arrays, tuples, and enums. Our starter code today is the code from lesson 2. As we now begin lesson 3, I'm not really going to use this code though, so I'm just going to select all with Control A and press backspace to remove that code. We can Control S to save the file as well. After that, let's go ahead and open the terminal window with Control and the backtick. And let's once again start TypeScript with TSC and then the watch flag, which is -W. We configured all of that in the tsconfig file back in lesson 1. So I'll press enter. Now we'll begin watching all of the TypeScript files that we create inside of the source folder, and it will convert them or compile them to JavaScript and put them in the JS folder here that we have inside of the build directory. So now let's go back to our main TS file. I'll close the terminal window, but TypeScript will continue to run. And we're going to start with arrays. Now let me define 3 different arrays like we normally would in JavaScript. So I'll say let string array. I'm going to set this equal to an array that contains 3 strings. One, let's say hey, and we'll put Dave in here. So that's the first array. After that, let's create a second one. I'll say let guitars. I'm going to set this equal to an array, and I'll put in a strat, which is short for Stratocaster, if you know about guitars. The next one is a Les Paul. And then let's just put in one called a 5150 to reference Eddie Van Halen's guitar. Notice that is a number data type. Now a third array, and we'll say let, and we'll just call this mixed data. Let's set this equal to an array that has EVH in here. Let's once again put in a number like 1984, and let's put in some Boolean data, true. Now let's see what TypeScript thinks about these. And when I say think, I mean infer, as TypeScript figures out what data type these arrays are. So as I mouse over the string array, we get some IntelliSense help, and you can see the string array is an array of type string. So TypeScript expects all of the data that goes into this array to always be string data. Now let's look at the second array. As I mouse over guitars, we get IntelliSense that says, okay, this array can have string and number data. And if you remember from lesson 2 in this series, it's a union type, and that's what we see there. And when you use a union type with an array, you have to put that in parentheses. So we see the string and number inside of parentheses there. Now let's look at the mixed data type. And as I mouse over, IntelliSense helps us again, And we see this is also a union type, and it says the data here can be string, number, or Boolean. So let's see what we can do with these arrays. Let's first look at our string array. So we'll have string R here, and let's set the first element equal to a number, and let's see what TypeScript thinks. No, it doesn't like that. We get the red squiggly lines once again. It's complaining. So let's see what the message is that TypeScript has for us, and it says type number is not assignable to type string. So TypeScript knows we're only going to have strings inside of this array. So if I go ahead and set this equal to the name John, TypeScript has no problem. As you might guess, any other data type would cause a problem here. Now, besides setting a specific element like that, what if we said string array and we push something onto the array? So I'll push 42. Nope, we have a complaint here. And when I mouse over again, once again, type number is not assignable to type string. So we're not limited to the 3 elements we have here. TypeScript does not put a limit on the length of the array or even what order the type of data is in when we have these union types. So I'll go ahead and add another string here. I'll just say hey again, and you can see there's no problem. But now let's go ahead and do something for the guitars array. So I'll say guitars, and I'm going to set, let's say, the first element again, which is in position 0, and let's set this equal to 1984. Notice there's no problem, even though we had string data in the first position of the array to begin with. So as long as it is string data or number data, or these types, TypeScript has no problem with us switching those around. So we could have a number or a string here in the first position. It's not locked into being only a string in position 1 and position 2, for example. Now, likewise, we can add more data onto the array at the beginning or the end, for example. So let's say guitars, and I'll say unshift, and let's add Jim to the beginning. TypeScript has no problem with that either, because this, again, is string data. If we tried to add something like true, then we have an issue because Boolean data, or the Boolean type, could not be assigned because this only accepts strings or numbers. So we'll switch this back to Jim. Now, if we look at this last type of mixed data, it accepts all 3 types. So since I've used the keyword let, and we can reassign these arrays, let's see, string array, if we tried to set it equal to the guitars array, we again have a problem because the string array is only type string, and type string number, this union type, is not assignable to this string array. But we could switch these around, and let's see here, guitars could be equal to our string array because it definitely accepts that string data type as well as a number data type. So it just didn't work the other way around. So as you might guess, mixed data could be set equal to guitars, but we couldn't do this the other way. So we couldn't go ahead and take our guitars array and set it equal to the mixed data array because it only accepts strings and numbers, and we've also got Boolean type in the mixed data. So that won't work. So just to highlight how the reassignment works, it will work one way when the mixed data accepts the string and the number of guitars, but you can't reverse that and have guitars accept string, number, and Boolean because it's limited to the strings and number types. Now let's define an empty array. So I'll just say let test equal to and set it to an array. Now let's see what TypeScript infers here. It is the any type. So TypeScript thinks any type of data could go inside of that array because we have not explicitly stated that it can only be string type or any union type of the different types of data. So TypeScript just infers any. Let's go ahead and assign an empty array now with a given type. So now let's say let bands, and here we'll say this is going to be a string data array or a string type array. So our array can only hold string data, and we'll just set this equal to an empty array here. So now if we want to create an empty array like we did with our test array here, but we want to define the type of data that's going to go in that array, we can do that in advance by, of course, applying the annotation right here saying this is only a string array. And then after we do that, we can push data in here. So we could say Van Halen, and it's fine. Of course, if we tried to make that a different type of data, such as Boolean, that's not going to work. So let's go back to Van Halen, and that is fine. Now, as I mentioned earlier, the length of the array or the order of the types in the array does not matter to TypeScript. It just knows what types belong in the array. However, if you want to be more strict and define something that is locked in to a type in a specific element position and a specific length of an array, what you really want to create is called a tuple. So I'll note that here, tuple. And now we can create a tuple. So I'll say let my tuple, and I'm going to set this equal to an array that has a string to begin with, and then a number, and then Boolean. Now we could just stop right there, and we have defined the tuple type, but let's go ahead and set it equal to something. So I'll set it equal to an array that has Dave, and it has a number, and then it has Boolean data. So this, again, is a tuple, and as we mouse over, we can see IntelliSense here says this has string, number, and Boolean in those specific positions, and it also has a specific length. So this is more strict than an array. And likewise, let's create an array now where we can say let mixed, and we'll set this equal to an array that has John, let's put the number 1, and false. So as we look at this data, it looks the same. We've got a string, we've got a number, and we have Boolean. When I mouse over, though, it says this is a union type with string, number, and Boolean, and it's an array. If I mouse over the tuple, you can see it's a tuple with string, number, and Boolean, although we just see the word tuple because I called it my tuple. Now, let's see what happens if we set mixed equal to my tuple. There's no problem because mixed is a type of array with union type here that accepts string, number, and Boolean, and that's what the tuple has. However, let's take my tuple and set it equal to mixed. Now we have a problem. So why is that? It looks the same, right? Well, as we mouse over and see the IntelliSense message from TypeScript, you can see it says it's not assignable to type string, number, Boolean because the target requires 3 elements, but it is possible that the source, which is mixed, may have fewer elements. That's because mixed is not required to have 3 elements in the array. That's what it has right now, but it's not required to. So TypeScript understands that it's a possibility that mixed may not have 3 elements, and so you can't assign that to a tuple that requires 3 elements. So in addition, let's try to add something to an element that doesn't exist in the tuple, and we can see a problem there also. We tried to add something to essentially the 4th position because it starts at 0, and we can see type 42 is not assignable to type undefined because that 4th position, that 4th element, is not defined. And really the only place we could assign a number is going to be the 2nd position. So here in the 3rd position, it says type number is not assignable to type Boolean. And of course, we've already got the number 42 in our tuple, but it's only going to accept it once again if we put it in that 2nd position. Okay, let's move on to objects. So I'll put a note here and say objects. I'm going to scroll up for just a little more room. And now when we assign an object with TypeScript, we could just say let my object, and then we can say it's a type object. And that's fine. That's an easy way to assign the object type. But what else is an object? If we stop and think about the fundamentals we know from vanilla JavaScript, an array is also a type of object. So if we were to reassign my object, we could reassign it to an array and TypeScript will not complain. And we can verify this with a console log and say type of, and now let's put my object here. Let's save this. I'm going to drag Visual Studio Code to the left of the screen. Then I need to go to our index.html and click Go Live here. it should launch this, and then I am going to press Control, Shift, and I to open the dev tools. We can see live reload is enabled, and we console logged the type of, which is object. So if I refresh that, it'll get rid of that live reload enabled. Let's go back to our TypeScript file, and I'll press Control B to hide that file tree so we can see our console here to the right and all of our code to the left. So once again, my object is now an empty array, but that was reassignable because it is still a type object in JavaScript. If I scroll back up, we had an array named bands here, so I will come back down and say my object is equal to bands, and once again, TypeScript has no problem. We can also say my object is equal to an object just by using those empty curly braces, and that's also a way to say object, just like we use the word object here. So now let's create an example object. So I'll say const example object, and I'm going to set this equal to an object with curly braces, and let's give some properties here. So I'll just say prop1, and I'll use my name Dave, prop2, and let's use some Boolean data true. Now this is an object. Let's see what TypeScript infers about this object. Example object is an object that has prop1 and prop2. Prop1 must be a string, and prop2 must be Boolean. So if I scroll up here a little bit and take another line and say example object dot prop2 is equal to 42, that's no good because of course we have Boolean data there. If I said false, that's fine. So it is already locked in to that Boolean data. Prop1 likewise is locked into string data. So John is fine, but any number data or Boolean data is not going to work there. So we'd have to go back to a string like John. But what if we want to annotate the types like we have when we have created variables, when we annotate types here, or with arrays, anything like that? This is annotation, where we say this is a string array here before we assign the empty array, for example. So to annotate a type in an object, instead of using inference, as we have here, you can see we didn't specifically say anything other than this is an object, and then it inferred the data types inside that were string and Boolean, the property types. So let's go ahead and use something now called a type. So we can say type, and then I'm going to say guitarist, and from there we say equals, and then it looks like an object. I'm going to have a name, and here I'll say string, and then I'll have active, and I'll say Boolean, and then I'm going to have, let's say, albums, and let's make this a union type that has string or number types, and let's make it an array. So a string or number can be in the array for albums. So we just created this type called guitarist. Now, when we go ahead and create an object, so I'll say let EVH, I can just say this is a type guitarist. And from there, I can go ahead and set it equal to an object, and I can give the data I want. So here, name, I could say Eddie, and then after that, active, I'll say false, then albums, and this accepts string or number type data. So I'll have an array, and I could say 1984, 5150. Then I could also use a string and say OU812. So now I have three different properties here, and we're using two different types with this union type inside of the array. And this is fine, but this is convenient because we have defined the types for our object in advance. So we can just say let EVH and then say this is type guitarist, and it instantly knows what all of the property types will be inside. So when I mouse over this, you can see it just says it is the guitarist type. But now if I come up to the guitarist here and I mouse over, we can see it expects a name property with string, an active property with Boolean, and an albums property that has an array, which is a union type for string and number. So if I, for example, were to omit the active here, now we have an issue. TypeScript gives us a complaint saying, hey, active is missing from your object. You need to go ahead and add that if it's going to be a guitarist type. So I'm going to highlight our guitarist type here with EVH, which is Eddie Van Halen, if you're a fan of rock music, classic rock music. And I'm going to create a second one here. I'll call it JP, and I'll give him the name of Jimmy. Get the caps right. There we go. Jimmy. Active, we'll make him true. And for the data here, different individual albums, we've got 1. Let's give a string here for 2 and another string for 4, for example. Okay, so now we have 2 guitarists, and I had JP in caps. Let me put that in lowercase. There we go. So now, since I used the keyword let, and they're both guitarists, and they both have the same properties, we could set EVH equal to JP, and there's no issue with that. However, if we, of course, removed our active here from JP, and we didn't say JP was a type guitarist at all, then we would have an issue, wouldn't we? Because it's not a type guitarist, and it doesn't have the active property either. So you can see that's required. So let me go ahead and use Control-Z, and I'll just put all of that back. And then TypeScript is good because one equals the other. They're both the guitarist types. Okay, let's also note with the type that we have here, we can't add another property. So I'll say EVH and then dot years or something like that and equals to 40. That's not going to work because we can't just add another property. It doesn't exist on the guitarist type that was predefined. So that's worth noting as well. Let's also look at how we can make a property optional. So inside of our guitarist type, instead of these individual guitarists that we've created, you would want to go back to the type, and let's say we want to make the active property optional. So we put a question mark before the colon. And so now when I mouse over and we look at the IntelliSense, you can see the property active is Boolean or undefined. It became a union type, and it can be either of those types, either Boolean or undefined. If I delete that question mark, and I once again mouse over, you can see it's only Boolean. So I'll put the question mark back, and now that active is optional, I can delete active from our guitarist Jimmy, and I didn't mean to select all that, I just meant to do Control-S. There we go. And now there's still no problem. So a guitarist can exist without an active property because it's optional. With that optional property, can we still set EVH equal to JP? Yes, we can. They are still both the guitarist types. So now I'm going to scroll up, but let's look at how this might apply to a function. So let's say we have a function named greetGuitarist. And then that function is going to accept a guitarist. So first, let's give a title for the object. So I'll just say guitarist, but notice it's not the type above with the G, it is a lowercase guitarist. And then we're going to pass the guitarist in. So see how we didn't have to specify the full object there with all of the different properties and types? Otherwise, we would have to do that. And you could see that where the object is right here, and you would start giving all the properties and types inside of the object, and we would just call it guitarist inside of the function. But now, instead of doing that, we can just say guitarist right here. And then for the rest of the function, let's go ahead and finish it out here with the arrow, the curly brace. Inside of the function, I'm going to say return, and we'll use a template literal. So hello, and then we'll reference the guitarist object, and we'll reference the name property, and just give an exclamation mark there. So a very simple function, and then down below we can call that function. So I'll say console log, so we see it in the console to the right, and greet guitarist, and I'm going to pass in our JP object. Okay, I'll save, and we'll see what we get to the right. We get hello Jimmy. Now I'm going to show you something slightly confusing, and that is not only can we use a type like we did for our guitarist type, there it is, which is what we've been using, we can also use what is called an interface, and it essentially does the same thing, especially here when you're starting with TypeScript. there's no point in getting confused about when to use a type versus an interface. And I typed inferface because I've been saying infer so much. It's interface with a T. There we go. So interface, and then guitarist, no equal sign like we had with the type before. And now this works the same way. I'll save this code and everything is still going to work. So the natural question would be, when do I use an interface versus when do I use a type? Well, when you're first starting out, it's really preference is the way I've heard it described as well, because I don't want to confuse you about when to use each. We'll get into more of that as we get into more complex areas. However, I usually use an interface when I'm defining something I would think of like a class. And of course, you might have methods on a class as well. But notice how this works just the same. So we have defined our object. Instead of using a type, we have now used an interface, and it is still working in the code the same way. Okay, jumping back to how we made active optional right here, let's go ahead and remove that question mark, but let's make the name optional for just a moment. Now, if we make name optional in the guitarist, this could create a problem. Of course, we've got to put active back here as well. So I'll put that back inside of our guitarist for JP. But if name is optional, TypeScript knows that even though both of these objects do have values for name, when we look at this function definition, it doesn't really realize that. Now, it could just make it undefined if the object didn't have a name. And so TypeScript is not complaining here. It would just provide undefined data, but you can't call a method on undefined. So if we were to say to uppercase, TypeScript is not going to like that unless we make that optional as well. So if I remove that option, now TypeScript tells us we have a problem. So let's mouse over and see what the problem is. Object is possibly undefined. So just with auto completion there, you saw one way to fix that would be make that to uppercase optional. Only if this property had a value would we call to uppercase. But we could also check to see if it exists, and that would also help us eliminate this error too. So here we could use what is called narrowing, and here we would say if guitarist.name, and then we would return our hello with the guitarist name and the to uppercase. And then let's go ahead and have another return, because without a return here, let's see what it says now. The function itself is either going to return a string or undefined at this point. You can see the function as a return type that is a union type there. So let's go ahead and just say return hello, and that would be if we did not have a guitarist name, because here it would return. So we don't really need an else. So I'll save that. And now you can see the guitarist has a name, so we returned hello Jimmy in the uppercase. But if a name didn't exist, it would just return hello. And TypeScript realizes that in advance. And that's one way it helps you eliminate errors here at development time, at compile time, rather than, of course, when the application is running, as you would in JavaScript. So if I delete the name here from Jimmy, our JP, and now we go ahead and save because we made the name optional, we just get the hello return that we put here on line 59. And now let's look at enums, since we have covered objects. So I will note that as well. And these are enums. I want to put in a quote from the TypeScript documentation here first, and I'm going to press Alt-Z to wrap that code down so we can see all of it. And it says, unlike most TypeScript features, enums are not a type-level addition to JavaScript, but it's something that TypeScript actually adds to the language and runtime here. So this is another feature, but it's not like most of the others that are simply type-level additions. So it's something you haven't seen before in your normal vanilla JavaScript for sure. So I'm going to say enum, and I'll create one here named grade. And now with that, I'm going to provide a U, which would be unsatisfactory in college level courses, a D, and then we'll have a C, a B, and an A. So this is our enum. So let's go ahead and log the value of u and see what we get. So we'll say console log, and then we can refer to this as grade.u, much like we would an object. Let's see what we get in the console when I save. We get 0. So these are enumerated, and they start at position 0, so it's going to be, there you see grade.u equals 0 just when I mouse over, even with the IntelliSense. So it's going to be 0 through 4. If I mouse over the A here, you can see grade.a equals 4. So if we want to change those values up, you could set the u equal to 1 to begin with, and everything else will adapt. So now this is a 1 in the console, but look when I mouse over B, and grade.b is 4, and the A is 5. So just by starting out with 1, the enum went ahead and advanced all of these by 1. So it starts at 1 and it keeps them in order 1 through 5 instead of 0 through 4. We have now covered arrays, tuples, objects, and enums, and there is much, much more to come. Today's starter code is our code from lesson 3, and we're going to use just a little bit of this code. So I'm going to scroll down to about line 38, and you can see I have the interfaced guitarist highlighted that we created in lesson 3. I'm going to use Control X to cut that out, and then Control A to select the rest of the code and just press backspace to delete it. Now I'll paste this interface back in. And if you remember from the previous lesson, before we created this interface, we used the keyword type. And then, of course, we had to have an equal sign over here as well to represent this object. What we're creating is called a type alias, but this can apply to more than just objects. So I'm going to comment that up here. Type aliases is what we're going to discuss. And let's create another type alias. So I'll say type, and then I'm going to say string or number. And we can set this equal to a union type that is string or number. And now, instead of having to type out the union type, string or number, if we were using this in several places in our application, we could just use this string or number type. Likewise, we could add more to the union type, or we could just define another type if we want to. So let's do another one here, and let's say type string or number array. And let's go ahead and set this equal to what we see in the guitarist below. So now we have string or number, and it's also an array. And now that we've done that, we can actually use this type inside of our guitarist object that we created. So we're using a type alias inside of another type alias, and this works as well. Or let's say we have a type that is a user ID, and it could be a string or number as well, and we've already defined the string or number type alias above, so we could just set this equal to string or number, and this would also work because now type user ID is going to be a string or number union, just like the string or number type that we assigned above. So essentially, we are representing our TypeScript types with a different name, and that is what is called an alias. So we are creating type aliases for our TypeScript types. Now, again, if you have the question in your mind about why is a type different than an interface, we cannot do this with an interface. So here I'll say post ID and try to set this equal to string or number, and that just won't work. So interfaces, think about those more as objects or classes, if you will, and types you can think of as an alias for any type of TypeScript type that we might assign. Now let's look at literal types. I'll comment that right here, a literal type or types, and I'll assign, say, let my name, and I'm going to assign it my actual name instead of saying string, number, or Boolean, for example, or a union type of any of those. And now when I mouse over, let's look at the IntelliSense, and it says, let my name, or my name is type Dave. Now that's different than what we've seen before. So that is a specific assignment. It's a literal assignment. So if I try to set my name equal to John, TypeScript does not like that. So instead of setting my name equal to John, I can only set it equal to my name, which is Dave. But we might want to have a variable that would be a little bit more useful than that. So let's say let username, and then we'll use a union type here with literal assignments. So we could say Dave or John or Amy, for example. Now, any of those values would be valid for username. So we could set username, and then we could set it equal to, and notice we get IntelliSense to help us out now, built into TypeScript as well. So it could be Amy, Dave, or John here inside of Visual Studio Code. So we'll just assign Amy, and that is a valid value. But any other name in there, say Rachel, nope, it doesn't like that. So it can only be Dave, John, or Amy. So once again, when I type the single quote, we get IntelliSense help, and I'll assign Amy. So a literal type with only one value is much like saying const my name equals Dave, because that would not be reassignable. And in this example, the only possible value is my name, which is Dave, for the my name variable. However, these can be very useful when you use the union type, because now more than one value can be assigned, and you might have a variable where only certain values are expected. And you could do this with numbers as well. So literal types can be very useful, as well as keeping your code dry, because you might assign this once to username and then use username in your code, and you'll know it only expects these three values without specifying these every time. And really, you could go back to the aliases and say they could also keep your code dry, because you're creating a type instead of possibly a somewhat long type definition with a union or something like that. This is fairly short, but instead of typing this every time, of course, you now have the type alias you can refer to. So a benefit of both literal types and type aliases could be keeping your code just a little drier. And of course, dry means don't repeat yourself. It's that acronym DRY. Now let's look at functions. So I'm going to return, and I'll put functions here. This is a bit of a review because we looked at a function called sum in previous lessons, and this will be a review of that. I'll just call it add instead, but basically the same thing, where we could have two variables, a and b, and then we'll have an arrow function here for this example. Then I'm just going to return a plus b. Now we've already learned that TypeScript can infer what these are, but you can see TypeScript does not like what we have here. We've got a line underneath. Parameter A implicitly has any type, and we'll see the same for B. So we have not put those types in explicitly, and TypeScript would really like us to do that. So let's go ahead and say both of these need to be number types, and we could provide a space there as well. And here I'll put number also, and we don't need a space there after the type. So just formatting a little. So A and B are number type. But notice when I mouse over the function name, add, it also says it returns a number. So it is still inferring what this function would return. So we can supply that information as well by putting a colon right after the parentheses and putting the type of data that the function will return. Now, one thing we have not looked at is a function that does not have a return. So let's create that, and I'll call this log message. And this is going to accept a message, and we'll assign the any type, because we could be sending any type of data here that we want to log. And then afterwards, well, I'm not going to say what type it is. We'll let it infer, and then we'll go ahead and assign it after. So we're just going to console log whatever message we send in, and it can be any data type. Now let's mouse over log message, and we can see the return type is void because it does not have a return. So if we were to assign that, we would do it in the same way. We just say void, and this void type is for functions that do not return anything. So this is a side effect. Any function that would have a side effect that would not have an explicit return should be a void type of return data, which essentially means there's no return at all. So let's use our log message, and we'll call that, and we could pass in hello, and TypeScript is fine with that. I'm going to do Shift, Alt, and the down arrow to copy it a couple of times. We could also pass in our add function. Say we're going to add 2 and 3, and our add function is fine with that because those are two numbers passed in. Let's once again do our add function. Now let's pass in the string A and 3, and I'll get rid of that extra single quote there. And it does not like that at all. I need the extra parentheses there too. So now we've got log message twice. Oh, and I've got double and single quotes. So no wonder it didn't like all of that. Here, now we just have the error I expected, which is saying that the argument type string is not assignable to the parameter type of number. And we're getting that because that's our add function. So we're passing in data that will not work with that. So if we change this back to numbers like above, it would be fine. I just wanted to show that example to show that it still works inside, even when we're calling a function inside or passing this in to another function. I'm going to go ahead and save this data. Then I'm going to do Control backtick to open up a terminal window. Type tsc-w so it starts watching our TypeScript files and creates the JavaScript files. We have learned how to set that up back in lesson 1. Now that TypeScript is running, let's go ahead and drag this over to the left. I've got an empty browser here to the right. I need to go into the build folder, click my index.html, click go live to launch live server. So we run our code, and now we should get this black background instead of the somewhat charcoal background I had in the other tab. And I'm going to Control Shift and I to open up DevTools just so we can see our console log statements. I'll also do, I'll select the main TS file that we're working in and then Control B to hide the file tree so we can see our code here on the right. But now we see our log messages. Besides the live reload enabled from live server, we get hello and the number 5. Okay, I used arrow functions both for the add function and the log message function, but you do not have to use arrow functions. So I'm going to scroll up and create another function, and we'll call this one subtract. So I'll say let subtract. It's going to equal a function. I'm going to use the function keyword, and then I'll give C as a parameter, and it's also a number, and D, which is also a number. And this is also going to return a number. We could have curly braces here. I'll press Alt-Z to wrap the code down just so we don't miss anything. Now we need to return C minus D. Now that we've completed the function, TypeScript is happy, no error marks here. And just note that this is wrapping down a line since I have the browser open on the right now. And this is the return type here, the number as well, just following the parentheses, just like we had above for add. We're just taking up a little bit more room because we have a larger word here for subtract and we have the word function. So this function also works just like add does, except we're using the keyword function. We're not creating an arrow function. We're using the curly brace here just after the number type, but it works in the same way. And notice both of these functions actually have the same type signature here. They both accept 2 number parameters and they return a number. So this is where it could be useful to use a type, especially if I know I'm going to create more math functions. Now, actually, I would want to create the type above both of these if I were to use it in these functions, but I'm going to create it below and then just use it for another math function. So I'll say type, and then I want to say math function. And then after that, I'm going to say it equals a function with a parameter that is a number. Need to type number correctly, and a second parameter that is also a number, and then it's going to return a number. So there is our definition for our math function type. And now if we were to create another math function, such as multiply, we could use this type. So I'll just say let multiply, and just right away I'll say this is a math function type. And then let's set this equal to a function, and it has C and D as parameters. And then I'm going to use the curly brace, and inside of the function I'm going to return C times D. And now TypeScript says this is okay. So let's mouse over multiply, and you can see the type it is assigned is math function, which is an alias for this type definition that we put up here that has 2 number parameters and returns a number. So now it should know our function is going to return a number, and it expects the first and the second parameters to also be numbers. So it infers that actually because we assigned this type alias to multiply. So it expects math function to match. So now I'll do one more log message, and we'll call our multiply function, and I'll say 2 times 2. And when we save, we should get 4 in the console, and we do. I'll make the console just a little bigger there so we can really see that text too. Now, when it comes to functions, I like to use the type aliases more than I do an interface, but I do feel obligated to show that an interface is also an option with a function signature, just like a type alias is. So I'm going to copy this down with Shift Alt and the down arrow once again. I'll just comment out the type above for a moment. And now I'll set this instead of a type to an interface. But we once again have to change some things for an interface to work. So we need to remove the equal sign and put a curly brace to start. And then I'm going to bring this down onto another line. And then I'll put a curly brace to end. But notice TypeScript still doesn't like the arrow here. We need to remove this arrow function, and we need to put in a colon right there. So this is an interface for math function. And when I save, TypeScript compiles, and we still get the same result here in the console. So this also works. But typically when I think of interfaces, I'm thinking more about classes and being able to extend those, which we'll learn about in the future. And then when I'm thinking of functions and other basic types, I'm thinking of type aliases. So what I'm going to do is uncomment this type and then comment out the interface, but leave it in there for you just so you can see both examples in the source code for this lesson. We're not quite finished with functions yet because I want to cover optional parameters and default values as well. So let's first look at optional parameters for our functions. So I'm going to define one more function. I'll call it add all, and I'll set this equal to a function that receives a number parameter and a second number parameter and a third number parameter. This is an arrow function as well. And then after that, we're going to say return A plus, need the plus, B plus C. So that would add all three of those. Now we didn't say what the return type was. That should also be a number here as well. There is our add all function. Now that's fine when we require all three of those, but we can say a parameter is optional by putting a question mark before the colon. And now we have a problem here in TypeScript. TypeScript put a little red line under our C, and if I mouse over, it says this is possibly undefined. Look at the type of the C parameter. It's not just number, although we said it was. It's number or possibly undefined because it's optional. So for TypeScript to be okay with this, we have to put in what is called a type guard. And a type guard narrows down the type of value assigned to the variable. So what we'll say here is if type of, and then we can say C is not equal to undefined, then we're going to return A plus B plus C. So I just need to put that inside. But TypeScript probably still won't be happy with the function because that's not the only possible result. And notice here we have a red line under number. It says the function lacks an ending return statement, and the return type does not include undefined. So it's not good if we just leave it like that. So essentially we need an else, but instead of an else, I'm just going to put a return here as well, because if it's not this, it's going to return the other, and I'll just say return A plus B. And let's see if TypeScript is now happy. And yes, it is. So if type C is not equal to undefined, it's going to return the sum of all three parameters. Otherwise, if type C is undefined, it's just going to return the sum of A and B. Now, I believe I mentioned it, but remember that if you have an optional parameter, it needs to be the last in the list. Your required parameters do need to come first. So now I'm going to copy this down. I'll just highlight all of this and do Shift Alt and the down arrow, and then I'll change the name of the function, and I'll just call it sum all, which means essentially the same thing. And here we currently have the same signature, number, and a third optional number. Well, let's change that to where this number is not optional, but really it still kind of is, because we're going to assign a default value now. So if we don't supply C, it will be equal to 2 if it is not explicitly supplied when the function is called. So C should never be undefined at this point. So we could go ahead and remove the if statement, and now we should be able to just put plus C once again, And TypeScript is okay with this function. So let's log some of these out with our log message function, and I'm going to say add all, and I'll put 2 and 3 and 2, so we should get 7 there. And I'll copy this down and add all again, and I will not supply the ending parameter for C, and there we should get 5 because the type of C will be undefined, so it should just add A and B. Now, for the last one, we'll do the sum all, and I'll once again pass in 2 and 3, but we should once again get the value that we get for the first add all, which should be 7, because C should be equal to 2. So now I'll save all 3 of these, and yes, we got 7, and then 5, and then 7 once again. Now, unlike the rule we had for optional parameters, and I should put default param value here, C is the last in the line as far as the parameters here, but we could give A a default parameter. So I'll give this an equals 2 as well. And then if we were to call this and omit A, we would have to explicitly pass undefined in, because otherwise it would be assigned A. So I know that's a little bit confusing, but what we would have to do here, and I should make that a different number. Let's make it something obvious like 10. So instead of the sum all we have at the end with 2 and 3, I would have to explicitly say undefined, and that would be okay. Otherwise, if we do this, TypeScript doesn't like it because 3 is being assigned to A. It's the first thing in. So if you want it to skip over A, you have to give it a value there. So we'll say undefined and 3, and this would be rather obvious now that it should be 15. And that is because we have a 10 as a default value, and then we passed in the number 3, so that's 13. And then even though we didn't pass in C, it also has a default value of 2, so that all adds up to 15. Now, if you remember our math function above that we defined with an alias, type math function, and this is the function signature, we cannot do that with default values. So that is one thing that cannot be achieved with an alias type or also the interface math function here. Default values will not work when we define a function signature like this. Okay, I'm going to scroll up for a little more room as we're not quite finished with functions yet. We need to talk about REST parameters. And they look very much like the spread operator, but it's when we pass them in as parameters to a function. So I'm going to define another function called total. And this is going to be equal to a function that accepts a number for the first parameter. No, you know what? I'll leave out the first parameter at first, and I'll just say it's going to receive nums. And notice I'm using a REST operator there for nums, and then it is number, and it should be an array. So that represents an array full of numbers. We don't even know how many numbers, but that's what we have. And then this function is going to return a number. And then inside the function, I'm going to return, and then I'm going to use the nums array that is passed in. I'm going to call reduce on the array because it's a good function for totaling up an array of numbers. And now, inside of reduce, we'll have the previous value and the current value represented. And then we just arrow over and say previous plus current. And now that we've done that, our function is complete. So let's look at what happens when we use log message and then we call total. And we're going to have 1, 2, 3, and 4 all passed in. Now again, notice I'm not putting an array here, but this is represented as an array here because we used the REST operator. So when I save, we get the total of 10 over here, which 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. That is correct. So the reason this is called REST, if you're not familiar with it, it kind of means the rest of the parameters. So this should always come at the end as well. So if I were to represent this with another parameter first, like I almost did in the beginning, I could say A is a number, it's required, and then however many other numbers I want to pass in. So I could just pass in 2 values, say 1 and 2, and save. And now, of course, we get 2 over here at the bottom. And that's because I didn't use the a parameter. Notice it is still a little lighter here. So let's now say a plus whatever we reduce from this rest params, which is the array, and I save. Now we get 3. So it took whatever I passed in the beginning for a, and then however many numbers remain, and it represents those as an array. So now we could say 1, 2, 3, and save, and yes, we get 6. Or if we changed 1 to a 10, then we're going to get 10 plus however many other numbers there are. So once again, to emphasize this, the rest operator here for the rest of the parameters should come at the end. All of your other required ones should come at the beginning, and this represents the rest, which will be represented as an array inside of your function, but not when you pass the parameters in. You might also be wondering why I didn't assign the specific types to previous. And if we mouse over, you can see previous is a number. We mouse over current, it's also a number. And if we mouse over reduce, we're going to get a bigger definition, but you can see it returns a number as specified right there. Well, we're already declaring what is being passed in and what will be returned from total. So TypeScript can easily infer that these should be numbers because we've already specified that above. Okay, now that we have learned more about functions, it's a good time to cover the never type, which is a basic type, but you don't see it that often, and there are a few instances where you may need it, but if you were not aware of it, it would definitely surprise you. So let's go ahead and create a function. And I'll call this function create error. And then inside of this, I'm going to say error message, and it's going to be a string. And I'm not going to define the type here. I'll just let TypeScript infer it, because we're going to throw a new error, and we'll just pass in our error message. So now if I mouse over create error, we can see it returns the never type. And this is essentially for functions that explicitly throw errors. So if we were to explicitly put the type here, we could with never, and it should look the same when we mouse over, and it sure does. Now, it will also be a never type or a never return type from a function if that function has an infinite or endless loop inside. So I'll just say const infinite. I'll set this equal to a function that doesn't even accept any parameters. Here I'll say let I, and it's a number, we'll assign 1. Then I'm going to say while true. Inside the loop, I'll just say I plus plus. And now, if I were to mouse over infinite and look at the return type, it's never, because this is an endless loop. We wouldn't want this. So overall, if you're having TypeScript help you, and you look at what is being inferred and you see never, make sure you want to throw an error. If not, you probably have a problem like an endless loop inside of your function. So how could we solve this? Well, let's go ahead and put in if I is greater than 100, then we'll just use a break. So now let's see what the return type is for infinite. Now it's void. There is no explicit return, but that is much better than the never type where we would have created an endless loop. So I'm not going to comment out this if statement because I do not want to leave an endless loop in your code. However, just remember that that's what this is about right here. So it's currently, as I'm going to leave it, the return type is void. But if this were not here and you had an endless loop, it would be a never type. So when could this never type actually be useful? Well, let's look at how TypeScript thinks about things. So I'm going to say const and create number or string. And this is just going to be a function that identifies a number or a string. So inside of here, I'm going to have a parameter named value, and it's a union type that could be a number or a string when it's passed in. And we're going to return a string. And I'll make this an arrow function. Now we'll say if type of value is string, then we're going to return the word string. And then also we can say if type of value equals number, then let's just return the word number. And now you would think that would be it because we can only pass in a number or a string according to what we have assigned here. And we're always returning a string, but TypeScript still does not like what we have defined. So let's look at what's going on when I mouse over. It says the function lacks an ending return statement, and the return type does not include undefined. So how could we solve this? In normal JavaScript, just vanilla JavaScript, we might just have an empty return. But TypeScript is not like that either. When we mouse over, type undefined is not assignable to type string. This function needs to return a string as we have specified here. But what we can do is return our create error, and we just pass in a message like this should never happen, because it's essentially the never type. And now TypeScript seems okay. So when we mouse over, we've got a value number string and returning a string, and TypeScript is great with all that because here we're returning a never type. So essentially we've used type guards here to check the type of our value, whether it is a string or number, and we know this should never happen, but essentially TypeScript needs that explicit return yet with a possible error when we do not have, when we'll go ahead and remove this and look at the specific message it gave, when we do not have an explicit return and it's not handling a potential undefined. So I'll remove these comments and TypeScript should once again be happy. But now if we're using these type guards like type of value is number or type of value is string many times in our code, we might want to create a custom type guard for that. So I'm going to define it above, and I'll just say const is number, and I'll set this equal to a function that accepts a value, and I'm going to set it equal to any here. But we want a Boolean return type. And now inside of the function, I'm going to return type of, and we'll have value equals number, and I'm going to use a ternary statement here. So if that is true, we'll return true. Else, we'll return false, because that's what we need to return for this function. It's a Boolean type. So overall, we're looking at whatever value is passed in, and if it's type of number, true, anything else is false. So here, instead of our type of value equaling number, we could just say is number value and have the same result. So this created a custom type guard that we can use. So I'll quickly annotate these. This would be a use of the never type. And up above, we'll just call this a custom type guard. And now we have covered functions, literal types, type aliases, and of course the never type. Type assertion and typecasting are often used interchangeably on the web. Many resources choose just one term or the other and then stick with that as they reference the same concept. I searched on the web, and you can find sites like W3 Schools here that refer to this as TypeScript casting. Likewise, I searched the documentation, and while I'm not saying either one is right or wrong, as you will hear them and read about them used interchangeably on the web, the official documentation refers to this concept as type assertions. So that's what I'm going with today, but I put typecasting in the title as well because I know some refer to it that way, and you could possibly be searching Google or YouTube for typecasting just as easily as you could be searching for type assertions. So what are we referring to when we talk about type assertions? Well, it says right here, sometimes you will have information about the type of a value that TypeScript can't know about. And this comes into play when we work with the document object model, the DOM, so web page documents. And they give some examples of that here in the official docs. Another good description I read said something along the lines of assertion is simply telling the TypeScript compiler that you know more about the types, so it needs to listen to you because you have a little more detail than what TypeScript might infer or know about. And that, of course, becomes true when TypeScript doesn't know anything about the web page documents that you're working with. Our starter code today is the code from lesson 4, but we're not really going to use any of that, so I'm just going to select everything in this page and then press backspace to delete. Go ahead and save our main TS file where we'll look at some examples. And of course, we can start the compiler as well. And I do Control backtick to open a terminal window, type TSC and then -W for watch. Now, any TypeScript file we create in the source directory will be compiled to a JavaScript file that we have in the build directory. And we will create another file today, so that's coming up as well. But let's first start by just looking at some examples. And I'm going to create some aliases with the type keyword. So I'll put type, and then I'm just going to name this one and make the alias for a string type. And then type 2. And I'm going to assign that to a union of string and number types. And then type 3. And I'm going to set this equal to a literal type, so it can only have the one value of hello. Now that we have these three different types, let me go ahead and show one thing you can do with type assertion, and that is to convert to a more specific or less specific type than you start out with. So here I'll just say convert to more or less specific, just for a note in the source code. And we'll put let a, and we'll define this as the type 1. So that's going to be a string. And let's set it equal to a string of hello. So that is the string value, but it is still type string. When we hover over, we can see that that's what TypeScript knows. 1 is a string. After this, let's define b, and let's set b equal to a as 2. So what did I just do there? I assigned a type that was less specific because 2 is a string or number. And now we've put b equal to a, but a has the type of 2. Although it says a is a string here, we have changed the type to string or number. Now that is assignment to a less specific type. Likewise, we could say let c and set this equal to a as 3. Now that also works. We're being more specific here because a is equal to hello, and that is a literal here for type 3. It is the type hello, and we can do that because a was already equal to hello. So what we're doing there is assigning a type that is either less specific or more specific. And TypeScript does allow this with the as keyword. Now, besides the as keyword, we can also use angle brackets. And I'm sure you've seen examples with angle brackets if you have browsed any other TypeScript documentation. So here for the type 1, I could put it in angle brackets like this, and then I could give it an actual value. So D is going to have the value world, and it's a type string here that we dedicated with 1. Now I'm just going to copy this down with Shift Alt and the down arrow, and I'll change D to say the letter E, just the next one here. We don't have to have an alias here, so I could just put string in here, or I could put string or number as a union as well. Any of that works inside of these angle brackets also. You don't see me using the angle brackets that often, and that's because they cannot be used in TSX files that you would use in React, for example. So you cannot do this type of syntax that we see here with D and E in React. Okay, this is all fine, but you may be asking, when would I do something like this? Well, let's look at a more practical example where we can actually use assertions for narrowing. So I'll come down a couple of lines, scroll up here, and we'll start to define a function. And I'm going to call this function add or concat. So it can either add what we're going to give it, or it can concatenate, that is, combine what we're going to supply. So the first variable, the first parameter here, would be a number type. The second would be a number type. And the third is going to be a union of literals. So it could either specifically be the string add, or it could specifically be the string concat. After that, let's go ahead and say what type this function is going to return. It's going to return a number or a string, and I'm going to press Alt-Z to wrap this code down to the second line. And after that, we need to provide our arrow. Now, inside of the function, we're going to say if C equals the string add, get rid of that extra parentheses there. If C equals the string add, we're just going to return A plus B. And then otherwise, we're going to return an empty string plus A plus b, which that will coerce the numbers and make all of this a string that is returned instead. So the function can return number or string. That all looks good. But when we go to use the function, now an assertion can come in handy. So let's start out by saying let my val, and we expect this to be a string type. We're going to set it equal to our function add or concat, and of course this will return a value. We'll just pass in 2 and 2, and then we'll pass in the string concat. And now, what do we expect this to return? Currently, TypeScript does not like this because add or concat is a number or string, so it's a union type there. But my val is just string, so the type string number is not assignable to just the type string. So we can fix this with an assertion. We're going to tell TypeScript that we know this is going to return a string because we told it to. And now TypeScript has no problem with my val being a string because we have told TypeScript explicitly through our assertion that add or concat will return a string in this instance. Now that said, remember, we're telling TypeScript that we know better than it does. Essentially, when we do this, we are saying, hey, ignore the warning. We know we're returning a string. So let's look at another example here. I'm going to copy this down, and then I'll just rename a couple of things here. So instead of my val, I'll just call this next val, and it's going to be a number. So let's switch this to number. And now, of course, as a string won't work, but let's go ahead and put as number. You can see TypeScript has no problem with this, but we know there is a problem. So I'm just going to put in a note here, be careful, because TypeScript sees no problem here, but a string is returned. So just a note if you're going to download the source code or look at the examples, because this is something you can do with an assertion. You're telling TypeScript that you know better than it, but you're making a mistake. So mistakes can be made with assertions when you don't set them up correctly, because TypeScript is completely believing us now when we say add or concat is going to return a number. It's a possible value to return from the function, but we know when we pass in concat as an argument here that it is going to return a string like we showed above. Now TypeScript will still check assertions when it can. So I'm just going to take a value here like the number 10 and say as string. And you can see TypeScript does not like this. So let's mouse over and see what error we're going to get. I'll get rid of the IntelliSense. It says conversion of type number to string may be a mistake. So it checks you when it can, and that's a good thing as well. But just know that it can't always check like the example that I showed above. However, it gives us a hint here. If we really wanted to do this, if we intentionally wanted to make 10 as a string, it says convert the expression to unknown first. And an unknown type is something we haven't covered. Unknown is a lot like any, except you can't use unknown anywhere unless you're doing something like we're about to do here. And this has also been referred to in some documentation or articles I've read as forced casting or double casting, because we're going to use two assertions. So when you know you want to cast something specifically, you're essentially going to overrule TypeScript. And here we could say 10 as unknown. So unknown is a special type, and we can do that. And then we can say as string. It's not going to complain about that, and we have basically done completed two assertions in a row. So 10 as unknown and then 10 as string. And that again is called double casting or forced casting, simply referred to as two assertions in the documentation. And that's what we're doing as well. So I'm telling you about this as a beginner. I don't recommend this at all because it overrules TypeScript, kind of like the any type. You want to avoid that whenever possible, but occasionally it is useful to know how to use it. Okay, let's scroll up for some more room, and now let's talk about where assertions I think can be very useful, and that is with the document object model. the DOM, or when we're working with web pages is another way to say that. And so let me define a variable called image. And as you might guess, we would select an image from our document. So I'll say document.querySelector. And now I'm going to tell this query selector to select an image. And that's good. But of course, TypeScript doesn't know what document we're linking our JavaScript to. It doesn't know anything about the document. So let's see what TypeScript knows about this when we say we're selecting an image with query selector. It can infer that it is an HTML image type. So that's fairly specific. But then it could also just be null. So that's kind of interesting. So what if we had a different thing in our query selector, a different value? Let's say we had an ID, and we'll just call it my ID here. Let's see what TypeScript infers now. It is just an element. So it doesn't know anything about an element if it's just selecting by ID, because that could be applied to any HTML element. So TypeScript was able to infer just a little bit more when we told it specifically what type of element. So let's go back, and I'll put that image element back in here, and it has inferred that it is an HTML image element. Now let me copy this down, and I'll call this next one my image just to compare. And let's use a get element by ID. And now let's just give this the ID of image, for example. So it doesn't really matter what the ID is. We're just going to look at what TypeScript infers now for my image. It says HTML element. So it doesn't know that it's an image element, but of course we're using get element by ID. So at least it knows it's an element instead of, or it's an HTML element instead of what we had through query selector there in the other example. So we've had element, HTML element, and we've also specifically had HTML image element. So those are all possibilities. And again, we're going from element that is very much less specific to HTML element, which is a little more specific, to HTML image element, which is even more specific. Now, before we use any type of assertion here, let's go ahead and try to access one of the properties of the image that we defined above. So image, we know it would have a source property. TypeScript does not like what it sees here. So let's mouse over and see what we get. It says object is possibly null, and you can see the image we have defined is possibly an HTML image element, but TypeScript acknowledges that that may not be in the document at all. So we need to go ahead and tell TypeScript we know better than it. We created the web page. We know there is an image element in the web page. So now let's say as, and then we can use some completion here. So we could say HTML. We could just say element, as we see that pop up here. But then we could also say HTML element, and that's an option. But TypeScript even inferred that it was an image element if it wasn't null. So we can get that all through the IntelliSense completion. That really helps us find what those different elements that we're selecting are. And now notice TypeScript has no problem with us accessing the source property. So what about our my image that we defined? And I want to go ahead and select the source property on it. So now we have a couple of problems. We have my image is likely an HTML element, but it could also be null. And then, of course, you can't access the source property on the HTML element. It doesn't know specifically what type of element it is. So, for example, a paragraph element wouldn't have a source property. So we need to be more specific once again. One thing we can do to convince TypeScript that, hey, we know this is there, we can use a non-null assertion. And that is simply putting an exclamation mark at the end here. So we can say, this isn't null. We know it's not null. So just using an exclamation mark is called a non-null assertion. But we still have a problem. So let's mouse over the source and let's see what it does. Property source does not exist on type HTML element. So now we also need to say that this would be as an HTML image element. Now, if you stop and think about it, we can remove this now, and you don't need to use that non-null assertion when you say exactly what it is here. That is an option. And if we stop and think, if we remove this, TypeScript was able to infer our first variable, HTML image element, up above here. So image, and it knew it was either an image element or null. So all we'd really need to do is put our non-null assertion at the end of the first one, and now it has selected the correct element type. But again, if we use as after and select the correct element type ourselves, that's also telling TypeScript that it is not null, so you do not need to use the non-null assertion in combination with an as and the type. And just as a reminder of that bracket syntax as well, I'll copy this down. I'm going to delete the as here, and let's just switch this to next image or something different, but we could use the angle bracket notation here at the beginning as well. So I could just say this is an HTML image element and do it by putting that here. So you could also see it this way, but once again, remember, this way will not work in TSX files for React. Okay, I'm going to scroll up just to comment out the error that we have in the TypeScript file here. I'll go ahead and save. But now also in the starter code for this lesson, if you download the source code in the build directory, I've added a couple of things to the index.html for this lesson. So we've got just a little bit more CSS here inside of the style element that's in the head. And then this is named copyright on our index.html. So I didn't create a second HTML file, I just modified the index. And we're linking to a copyright.js file. Notice inside of this copyright.js file, I've got a simple paragraph here in the body, and it just says copyright. It gives the copyright HTML entity here. And then we have a span element that has the ID of year. There is no information inside of the span element right now. So right now we would just see the word copyright and the copyright symbol from the HTML entity, and it would not give the year. We want to insert the year here with JavaScript. This is one of the most basic things that you see on almost every web page on the web is a copyright symbol, usually in the footer or somewhere on the home page. And so I think it would be good to look at an example of how we could do this same basic code with TypeScript. So I wanted to go ahead and highlight that this is in the index.html, so we're going to be selecting this span element, of course. And now let's create another TypeScript file, and it needs to be named copyright.ts. So we'll create this new file. And the way we have our compiler set up, it should have already now compiled a copyright.js file, and you can see the use strict at the top, so that's good. We're ready to put our TypeScript in here. So what I'm going to do first is just take the original JavaScript code that I've used on other websites. It's just 4 lines of code, but you can see TypeScript doesn't necessarily like what we're doing. So we're going to refactor this code to apply some of what we've learned about type assertions. So here we go. We're defining year first, and you can see year is an HTML element or possibly null. And then this year is a number, and that's because we're taking a date object and we're applying the getFullYear method to get whatever year that it currently is. And then you can see we have issues. So if we mouse over year, it says, well, year is possibly null, so that won't work. And if we mouse over this year, it said argument of type number is not assignable to a parameter of type string. So we want to assign this date time parameter and put the year in, and we can't do that because it's the wrong type. And then here, year is once again possibly null, and we're assigning text content, so it once again doesn't like that number type. So I think this is a great time to pause the video, go ahead and work up your solution for this, and then I'll come back with a couple of different solutions. All right, I'm back. I hope you did good. We're going to look at a couple of solutions. I'm going to copy all of this code first, and then I'll just put in here first variation, and I'll paste it all again below, and then I'll highlight this code above and just use Control/ and comment it all out. Let's go ahead and change this variation. And when you're first starting with TypeScript, I think it's easy to look at what TypeScript infers because it wants to help you. And from there, you can start to type out your code. So if we look right now, it says year is an HTML element or null. So let's go with that. I'll put the colon here and I'll say this is an HTML element or null. And now below, we can just set year equal to that selector. And I forgot to change const to a let when I'm going to use some double assignment like that. So now we have let year and HTML element or null, and then year is equal to our document.getElementById. So now we've explicitly assigned what TypeScript was previously inferring. Let's do the same with this year, and this time I'll remember to change const to the keyword let, and we'll say this year needs to be a string. Now remember, TypeScript inferred it was a number, but we knew what mistake we were getting, what note we were getting from TypeScript when it didn't like assigning a number to a place we needed a string later in our code. So now I've made this a string, and now we can say this year is equal to newDate.getFullYear, but now it's still a number, right? That says number is not assignable to type string. So at the end of our chain here, we could just put the toString method, and now TypeScript is once again happy because this year is truly a string type. And now we've made all these changes, and TypeScript still isn't happy with our set attribute. So when I mouse over, it says, hey, you forgot object is possibly null. We have no way of knowing that an HTML element is going to be selected. Maybe you'll try to select it and it doesn't exist. So we need to put in a type guard here, for example. So we could just say if here, and then we could put all of this inside. And I said type guard, but we're basically just checking to see if it exists or not. And that works. Now TypeScript is happy. But there's some things about this variation that I'm not necessarily happy with. But this is legitimate code. This is something you could easily do when you're first learning TypeScript. So let's go ahead and look at a second variation where we apply just a little bit more of what we've learned, and we go ahead and use assertions. So I'm going to copy all of this down now with Shift, Alt, and the down arrow. And then after that, I'm going to comment out the first variation above. So Control and slash. Now I'm just going to name this second variation. This will use some type assertions. And of course, we've learned we don't need to do this on two separate lines as I did here, but you might do that when you're first learning. Let's go ahead and switch this back to a const for year. I'll delete this second line, or at least I'll move part of it up to the other line. Now let's modify what we've got here. So we're going to say document.getElementById, and we've got the ID of year for our span element in the document. And now we want the equal sign, of course, since we're not just assigning a type there. And now after this, we can use an assertion, and I'm just going to say as HTML span element. So now we've explicitly told TypeScript, hey, we know that span element is in our document. We know it has the ID year, and that's exactly what we're selecting. So now when I mouse over, year is an HTML span element. So we've explicitly said that by using a type assertion. Now let's go ahead and switch the keyword let back to a const here also for this year, but we're not going to do the double assignment. We'll just bring this back up to the same line. So yes, we do want this year to be a string type. So we can say that, and we're going to set it equal to the date, get year, and still call that toString method, and TypeScript is good with that as well. And now after that, we don't really need our if statement at all, because we have told TypeScript with our assertion that yes, we're definitely going to have a year. It is not null. When we mouse over, you can see it says HTML span element, but it doesn't have the union type with the possible null value. So we can just go ahead and remove that if statement, and TypeScript is good with what we have left. And so that is the final variation, just a practical application of some of the things we've learned so far. Our starter code today is the code from lesson 5. This is lesson 6. I'm just going to select all with Control A, hit backspace to delete all of the code we have in the main.ts file. I'll save that. I'd also like to highlight that we have the index.html file inside of the build directory, and I've changed this from the last tutorial because we had an example there. Now I've just got it back to looking for the main.js file that will be compiled and saved into the JS folder here, and it just is named example. So that previous code in the index.html is gone. Okay, we're talking about classes today, and we've got a lot to cover. So let's look at a basic class. I'll just say class, and we'll call it coder. And then inside of the class, properties and methods are called members. So I'll put a member for the class, and this is a property called name, and I'll say it's a string type. You can see that TypeScript doesn't like this. Let's see what's wrong when we mouse over. It says the property name has no initializer and is not definitely assigned in the constructor. So we do need a constructor. So I'll go ahead and start with a constructor here. And then we want to say this is name and it's a string, which is kind of redundant, isn't it? And then inside of there, we're going to have this dot name, and we'll set it equal to name. So when we look at this, we think, how could we make this simpler? And we'll talk about that in a second. But first, if we don't have the constructor, TypeScript didn't like what we had up here. So if I just remove that, because it appears to all be right here, I'll use Control X to cut it out. TypeScript still doesn't like this. Now when I mouse over, it says property name does not exist on typecoder. So even though it seems redundant, this is actually what we need. Now we will look at another way to do this in a moment, but I just wanted to give the basic structure here that you do need the property to exist in the class as a member, and then you also need to name it here in the constructor. Okay, now let's take this example a little further. So after our name, which is a string type, let's put in music as another property that is a member, and we'll say it's also string. And then let's put in age, and that will be a number. And finally, let's put in lang, and that will be a string, and that's abbreviation for language is what we're going to put there. Okay, after we've done that, we need to add all of these. You can see we have red squigglies for each of those, so we need to do the same here. So we'll say music is a string, and age is a number, and finally lang is once again a string. Now it might be easier to read if you had more of these if you just break them out onto separate lines, and we can do that. We put a comma after each one in the constructor parameters here, and then I'll put the parentheses on the following line. I'll go ahead and save just to get some formatting. You can see TypeScript still says we need to do more, and that's because we also need this dot name to equal name, which we have, but we need to do the same for the others. I'm going to do Shift Alt and the down arrow 3 times, and after I've done that, I can select name, Control D to select name twice, and change this to music. And I'll do the same for age, and finally, I'll do the same for lang. Well, I didn't select the second one here. Let me try that again. There we go. So this does seem very redundant, but here we do now have our structure. We have added all of these members to our class, and then the constructor accepts those as parameters because they could be passed in when we instantiate the class, and that's why they're here as parameters. And then we actually assign the values. Now for me, I really like to keep things dry. I don't like all of this redundancy. And fortunately, there is a way to avoid this. Now we can add what are called visibility modifiers. I've also heard these referred to as data modifiers or even access modifiers, but the official docs say visibility modifiers or visibility members. So let's go ahead and put that here. By default, all of these properties, and if we had any methods, would be public. But right now, we don't have to say that, but we can explicitly say they are public. So I could put public in front of name, but you can see now it doesn't like what we have. Now it says it's a duplicate, and that means we can just remove the one up here. Now TypeScript's happy again. So if we go ahead and add these visibility modifiers to each of these in the constructor params, then we don't need these up here. So let's look at what else is available to us. We could have music, and besides public, we also have the option to make this read only. You know what I think I'm going to do? Of course, I need to remove this up here. I'll just remove all 3 so I don't have to keep going back. I think I'm going to go ahead and make music public, but then I'll make this actually public and read only because you can do both. So that means once the name is assigned, it cannot be changed. And then of course, this is explicitly public as well. When we talk about the music type, let's make age private. And that means it can only be accessed in the class. And we'll look at an example of that as well. And then let's make the language protected. And that is our last option there. So we're looking at all of these different modifiers onto our data, but this makes it a little less repetitive. Our code is a little more dry. So even if you just use the default of public, you won't have to type it twice if you do it this way. Now, before I go further with these modifiers, I do want to show one way to avoid those errors. It would be very unusual, but say you were adding a property that you did not want to instantiate right away. Maybe a third-party library or something like that is handling some of this for you. Either way, I just want to show an example of how you could do this. So I'm going to say, let's just say second language, second lang, and we could say string. And then you're going to, of course, see this red squiggly, and it's going to say it has no initializer. But we can add an assertion here, and this means that we are asserting that we know what we're doing, and we're just not going to initialize this right away. So you can add this if necessary. Again, beginners, I recommend staying away from this, but it could come up sometime in the future, and it would be a nice thing to remember. Okay, I'm going to save our class, and then underneath this, we can instantiate it. So I'll just say const, and I'll say Dave will be an instance of our coder object. Set this equal to a new coder, and inside I'm going to pass in the name argument, and then we need a music argument, let's say rock, and then we need an age argument, and I'm going to say 42, not that it's my age, but hello Douglas Adams, if you're familiar with his books. And now we can add our final param, and this would be, say, TypeScript. But what if we want to make this optional? Well, we can do that because constructors are a lot like passing params to functions. So instead of providing TypeScript here, let's make the last one, language, optional by adding a default value here. So we can just say this is TypeScript. And now you can see TypeScript is fine with me creating a new instance of coder named Dave without providing that fourth parameter. And now remember, age is private. First, name and music are both public, even though name is read-only, and lang is protected. Now, what's the difference between private and protected? Well, it can be accessed, or I should say lang can be accessed inside of the class, but it could also be accessed inside of derived classes. If we were to extend this to a subclass, we could still access lang, but we could not access age because it's private and can only be accessed inside of this class. So I'm going to scroll up and add a method here, and I'll make the method public, and I'll just say get age. Remember, age is private. Inside the method, we'll just say return, and we'll give a template literal here that says hello, and now let's say this.age, which should retrieve the age. This is fine because we're inside of the class. So even though age is private, we can access this value inside of the class, and we can just call the getAge method to, of course, return that value. However, let's look at what TypeScript knows about our class, and we can say, let's do console.log. I'll say dave.getAge, and it should be fine with that, and it is. But what if I had console log, and now I say Dave, and I just try to access the property, the member of the class, age? It doesn't like that. It says age is private and only accessible within the class coder. So we can't do it that way. Likewise, I'll copy this down with Shift, Alt, and the down arrow, and let's try to access lang. And again, TypeScript says no. I mouse over, and you can see property lang is protected and is only accessible within the class coder and its subclasses. So while we can access a method that accesses the age value inside of the class, we can't access those properties directly outside of the class. I'm going to go ahead and save our TypeScript file and then press Control and the back tick to open up a terminal window. Type TSC and -W for watch so it compiles. And I've got a couple of errors, of course, that we put in there on purpose, but we have compiled that now. So let's go to our index.html, and I'm going to use live server to launch that. And you can see it launched here on the left. I'll drag Visual Studio Code over to the left window as well. back to our main TS file, and then Control B to hide the file tree. I'll click on the browser and I'm going to press Control Shift and the letter I to open up DevTools, and we have the console here. So I'm just going to drag this up and we can see, of course, ignore the live reload enabled, or I can just clear this out and I can refresh the page and we get hello, I'm 42, which is get age. And then we get 42 in TypeScript. So remember, we're going ahead and compiling this, and even though TypeScript, the compiler, doesn't like what we're doing, it is still legal JavaScript, so TypeScript lets the page go ahead and compile. And of course, we could change that in our settings so it would not compile if it didn't like anything, but it lets you gradually adjust your code and refactor your code to TypeScript. So it is working, and it shows the 42 in TypeScript, even though it doesn't like that here. I'm going to go ahead and comment out these 2 lines that TypeScript doesn't like, but I'll leave them in here just so you could uncomment them and see those in the source code if you download it from the course resources that are linked in the description. Okay, after that, let's go ahead and extend a class. So I'm going to create another class. I'll call this class WebDev, and I'll say extends coder. And then inside of this class, we should have a constructor. And then, of course, we'll have our curly braces as well. We need to pass several things into the constructor, but I'm going to add a new property also. So I'm going to say public and put computer, and this will be a string. I'll put a comma because underneath this, we need to add what we're bringing in as well from coder that we extended. And I'm just going to bring in name, age, and number. So I'm not going to bring in the language that has a default value already. And then when you extend a class like this, before you assign anything here, such as this.computer equals computer, which is what we would do, we need to put something in front of that. And if you're familiar with JavaScript classes, as you can see, TypeScript wants to help us. We must put in a call to super. So let's put in our super. And then it needs to receive everything that we are receiving from coder. So it will get name, music, and age. So again, remember, super here needs to come before we try to assign anything else like this.computer. So if I put that above, TypeScript is not happy. So I'm going to undo that and make sure that assignment is after the call to super. And now notice we did not bring in the lang member that we had above in coder, but we extended coder here, and lang has a default value of TypeScript. So let's go ahead and add a method here, and we'll say public and then get lang, and we'll return a template literal, and I'll say I write. Now let's put in this.lang, and let's see what happens when we call this after we instantiate a web dev. So I will come down below this and I'll say const, let's call this instance Sarah, put this equal to a new web dev, and the computer is first. So we'll say Sarah has a Mac, or Sarah's name is Sarah, and she listens to lo-fi, and put in an age of 25. And you can see TypeScript is now happy. We have passed in all the params that we needed to for the constructor. So now that we have done that, let's go ahead and say console.log and call sarah.getLang. And when we save, it should recompile. And yes, remember we commented out a couple of lines. So we have the get age up here. It says, hello, I'm 42. But below, we had Sarah get Lang, and it says, I write TypeScript. So notice how we didn't put any of those modifiers on name, music, or age here. So what about accessing those now? Will they be public by default? Let's find out. I'll type Sarah, and then let's try to access age. But TypeScript says no, age is still private, and it's only accessible within the class coder. So let's go ahead and try to access the protected property, because that can come down to subclasses, right? So our protected property was lang, if I remember right. Let me scroll up and look. Yes, protected lang in our coder constructor. So let's switch this to lang, because now we have a subclass. Whoa, it still doesn't like that, does it? We mouse over, it says property lang is protected and only accessible within the class coder and its subclasses. Note here, even though this is a subclass, we're not within the class. But this is a subclass here, our WebDev extends coder, and within the class, we could access the protected lang member, the property from the coder above that we extended to WebDev. I'm going to comment out the two things that TypeScript did not like again here, and let's move on to the next example. And I'll put a little bit of a line here in the code as well. Let's see if we can just leave that in. Yes, and that will just draw a dividing line, because now I want to talk about applying an interface to a class, or you could say implementing an interface to a class. So I'm going to create an interface named musician, and we have looked at interfaces before as we covered objects in this series. I'll give this interface several properties, a name, which is string, and then let's say instrument, which is also a string. And now let's give a method. We'll say play, that's going to receive an action, which is a string, and it's going to return a string. So a simple interface with two properties, one method. Now we can implement this to a class. So I'll scroll up a little bit more. And then after this, we'll say class, and we'll make this a guitarist. And we'll say implements with the keyword implements. And then we'll say musician. So we name the interface. Now inside of this, guitarist already has a red squiggly line, so we can see what it wants. It says it's missing the following properties from type musician: name, instrument, and play. It's going to need all of those. So I'll say name, and that will be string, and we'll have an instrument, which is a string. And now let's go ahead and provide the constructor. And I'm taking the long way on this one, but that's okay. We'll put inside of this, we need to say name, actually string, and we'll have instrument. That's a string, much more than that, and I would have broken those onto separate lines. After that, I'll say this dot name equals name, and this dot instrument equals instrument. Nice review there of everything. But guitarist still isn't happy because it still needs play. So we haven't put the method in yet. So let's do that. And we'll say play, and then we'll have our action, and it's going to be a string. And then we're going to return a string. So I'll say return and do a template literal. And this is going to be this dot name. So whatever name is passed in. And then we'll go ahead and say whatever action is passed in. And after that, we'll say the, and then we'll say this dot instrument. So this should return a sentence that reads something like Eddie strums the guitar, or something like that. So here we have our class that implemented our interface. And notice if we switch name to number, it's going to check against that interface. And it says property name in type guitarist is not assignable to the same property in the base type musician. So these do need to match up. So we'll say a string, and then it once again matches. So TypeScript implemented our interface, musician. It made sure all of the members of the class were there as expected, and it's even checking the types back to, of course, musician here that we defined in the interface. So we've got all of that. Let's go ahead and instantiate one of these guitarists. So we'll say const, and I'll say page. Let's do that one. You know who Page is. We'll say new guitarist, and here he is, Jimmy Page. If I could spell Jimmy correctly, and yes, he has a guitar for an instrument, which kind of makes sense. That's a kind of a duh moment, isn't it? After that, let's go ahead and say console.log, and then we'll say page.plays, and we're going to say strums for the action. And this is a good example because TypeScript caught my mistake. I said plays. I wanted to say Page plays the guitar, but play is the method, not plays. So if I remove that S, now it's accurate. I can save, and we get Jimmy strums the guitar over in our console. I'm going to scroll for some more room and once again put in a divider in the code because we are switching topics, although we're still talking about classes. I'm going to create a new class here and just call this peeps. Inside of the class, we're going to create a static member, which would be a property here. So we'll say static and this would be count, and count is a number. I'm going to set it equal to 0. And then I'm also going to create a static method that is also a member of the class. So I'll call this getCount, and it's going to return a number. And then we'll return, notice what I do here. I don't use the keyword this. I refer to the class itself, peeps.count. So what a static keyword does, it means that count does not apply to any instantiation of the class. It applies to the class directly itself. So we'll be keeping track of count in the class, not in any one instance of the class. And then getCount can be called directly on the class as well. And so that's why I'm accessing count directly on the class peeps here. Now let's go ahead and give a public property. So I'll say public, and we'll create an ID, and this will be a number type. And after that, we'll use a constructor, and we'll say public here as well, and we'll receive a name param, and this will be a string. And then inside of the constructor, we'll say this.name is equal to name. And then we're also going to say this.id that we used above is equal to ++ peeps.count. So what does the ++ do when you see it on the left versus the right? Well, it's going to make sure that our count increments first. So what we're going to have is an ID of 1 instead of an ID of 0 when the first instantiation of this class is created. And you'll see how this works. And this is just normal JavaScript here. We're not saying anything specific about TypeScript, but if I put the ++ over here, our first ID would be 0. So I'm putting the ++ way back over here on the left. So our first ID is 1. Okay, so now I'll scroll up and we'll instantiate peeps for a few people. So let's say const John, I'll set him equal to new peeps, and I'll pass in John. And then I'm just going to Shift Alt and the down arrow a couple of times. Select John here, Control D to select the second John, and of course make a Steve, and then do the same thing here, and let's make an Amy. So now we've got 3 instances of peeps, and we've created John, Steve, and Amy. So let's log some things to the console. First of all, let's console log our peeps count. And this should tell us how many times the class has been instantiated to create objects. So let's see what we get. We get 3. So we've created 3. If I remove Amy, just Control X and then Control S to save, we get 2. So we're incrementing our count on the class peeps for every object that is instantiated from it. That's kind of cool. What about the IDs? So let's go ahead and say console.log, and let's get the ID from Steve. So what is his ID? He's created second, and that's what we get. We get the 2. Of course, we had peeps count 3 at the bottom. We get 2. Let's get Amy's count. So console log, and we'll say, or I said count, let's get Amy's ID. Her ID is 3 because she was created third. And so you would expect John to have an ID of 1. Let's take a look. John.id and save. Yep, John's ID is 1. So the main thing to take away here with using the static keyword, of course, is that it applies directly to the class and not to any specific object that you instantiate with the class. Okay, one more example. I know we've covered a lot, but let's fit in something about getters and setters, because you might see this in React when you're used to working with the useState hook, for example, or you're just wanting to keep state in an object you instantiate. So let's go ahead and create something like that. Let's say class, and I'll say bands here. And then I'm going to set a private member, and I'll call it data state. This will be our state that we're keeping track of in bands, and it's going to be a array with string data. Okay, after that, I'll say constructor, and we're not going to pass anything in, but this.data state can get initialized as an empty array, and that's fine. After that, let's put some methods, and we can put public or private on any method too. So I'll say public, I'll say get, which is a keyword, and I'll say data, and then After that, I want to say this getter is going to return an array that has string data in it. And that's exactly what we're going to return because we're going to return our state, which is this dot data state. Now, if I just leave it as this, that makes this read-only because there is no setter. But get is a special keyword that we can use in JavaScript. Again, this isn't just TypeScript, but in JavaScript to get our data that we have inside of our state here that is private right here. So being read-only, I would want to initialize this with some more data here. But just to keep moving, let's go ahead and create our setter as well. And set is another special keyword that we're going to use. And we'll use data once again. Now I'll say value is an array full of strings. So that's what it should accept. Now let's think about what we want to do to check to make sure this data is correct inside of our setter. So I'm going to say this needs to be an array full of strings. And we can check that by saying if array.isArray, and then we can pass in the value. So that checks to make sure it's an array. How about checking to make sure every value is indeed a string inside? And I just gave the keyword there. We can say value.every, which is a method that you can call on an array, a higher order function, if you will. And then let's say for every element, we're going to check type of element, and we'll make sure it is equal to string. So this would be true or false is what every would return after it checks every element, and every element needs to match that in order for every to return true. So now that we have checked everything we need to, we can say this dot data state equals value, and then we can return. I'll look at this return in just a second to see what else it might do, but let's also say here else throw new error. And we can be specific here. We could say param is not an array of strings. Okay, coming back to this return, I put it on this line here, but what if we tried to just return right here to end this out? Now, TypeScript doesn't like that. Let's look at why. It says setters, specifically setters, cannot return a value. So I'm going to undo this. The empty return is okay, but setters cannot return a value. And let's see how TypeScript identifies this. So if I mouse over data, it says it's a setter. And we're going to set the bands.data, and it should be an array full of strings. And likewise, if I mouse over data up here, this is a getter, and it's bands.data, and it should return an array full of strings. So let's check some of this out by instantiating one. I'll say const, and here I'll say my bands. And I'll set this equal to a new bands. Now I'll say my bands.data. And here I'll put an array and we'll say Neil Young, some good classic rock maybe, Led Zeppelin. So I'll just say Led Zepp. And then underneath that, we'll say console.log, and I'm going to log my bands.data. That's how you use the getter right there, is just to say .data. So let's save and see what we get. We've got an array. It returned the data. Neil Young and Led Zepp is in the array. So after that, let's use the setter. So here I'll say my bands.data once again, and I'm going to set it equal to an array once again, and I'm going to spread in my bands.data that we already had because we used the setter right here. My bands.data equals uses the setter. So we've already got that in there. I want to add one more band. I'm going to add ZZ top. Okay, now that we've done that, let's just copy this line down again so we can use the getter to get that data once again. And when we save, now we've got an array with Neil Young, Led Zepp, and ZZ Top. So what about that error we put in there? We were checking some things to see if it received the correct data when we attempted to set it. So let's try to use that setter again. We'll say my bands.data equals Van Halen. Look, TypeScript knows. It says this is no good. String's not assignable to the type array that should have string data. That's not going to work. So let's go ahead and make it an array. And I can do that by putting the brackets around it. Now that would work. But what if we had the string Van Halen in and the second element was 5150? Once again, TypeScript says no go. Number is not assignable to type string. So everything is working there, but we didn't actually go ahead and save this to see if it would throw an error as well. So let's do that. We save. Yep, param is not an array of strings. So we coded our check up here correctly, and we're throwing our custom error right here because we didn't meet this criteria. Likewise, if we switch that back to just a string like Van Halen, it would also throw that error. We're starting today with a main.ts file that is empty, so if you have code from the last lesson, you can just select that all with Control-A and press backspace to delete it. After that, let's go ahead and open up a terminal with Control and the backtick. And if you already have TypeScript started, you'll want Control-C to stop that, because I'm going to start it right here with TSC and then -W for the watch flag. And this will take any of the code that we have in our main.ts file and compile a main.js file inside of our build directory over here. And then we have an index.html, and of course our code will compile inside of our JS folder. We set all of that up way back in the first lesson. So if you are starting here for any reason, go back to the beginning and follow this course through in order. Okay, I'm going to close the terminal window. Let's quickly go to the index.html file, and I've got the VS Code Live server extension. I'm going to click Go Live to go ahead and start the project, so we'll be able to look at it in the browser, and what we really want to do is look at the console. I'll close the index, and I will drag VS Code over here to the left, and then press Control-B to hide the file tree so we have more room for our code. On the right, I will select the browser and then press Control, Shift, and the letter I to open up DevTools, and I've got the console open here. If I reload, that live reload message goes away from our live server extension. And now we're ready to write some code. So today we're talking about index signatures, and I can just comment that here at the top. And index signatures are useful when you're creating an object, but you don't know the exact names of the object keys, but you do know the shape of the object, and you can declare the type of the keys and the types of the values. But there's another reason that they're also useful, and that's because TypeScript requires an index signature if you attempt to access an object property dynamically. And honestly, that second reason is how beginners usually discover the need for index signatures. I'm just going to paste in a basic interface here, and you can see I've named it transaction object, and I've got a pizza property, books, and job over here, and all of these types are numbers. This is how we've learned to create an interface that we would create objects from. So now let me do that, and I'll just say today's transactions, and we'll make this a transaction object, and then we'll go ahead and set that equal to an object that has a pizza, and we'll put that at -10. We'll have books. Let's put that at -5. And then let's have a job, and we'll put that at +50. And you can see TypeScript is fine with that. We've provided all the required properties that we have inside of the interface. But there could come a time where we wouldn't know what these names would be when we're going to create an interface in advance. And that's where an index signature can come in handy. But it can also be when we try to access any of those properties dynamically. And so I'll show you what I mean by dynamically. If we just try to access pizza from our today's transactions, use dot notation, and that's fine. That's how we would, of course, find something or access that property, I guess. I'll save, and we should see that over here in the console, yes. But let me go ahead and copy that down with Shift, Alt, and the down arrow. And we could also do that with bracket notation, and I could say, yes, I want the pizza property once again. I want that value, and I'll save, and I get -10 over here in the console again. But let me show you an example of dynamically accessing this, and this happens more often when we create a loop, but first I'll do it without a loop. I'll say let prop, and now we'll say this is going to be a string. Let's just set it equal to the pizza string, just like we used here inside of our second console log example. And so now prop is equal to pizza. And so now I'll say console.log one more time, and I'll say today's transactions, use a bracket again, and I'll pass in our prop. This is how we would access it dynamically. But look, TypeScript does not like this. And this is the error that beginners often see. It says element implicitly has an any type, And it says because expression of type string can't be used to index type, and then of course it gives our interface. And then it says no index signature with parameter of type string was found. That's because we haven't created an index signature and we're trying to access this dynamically. And I'm going to scroll up just a little bit and show you how this can apply to a loop as well. So I just pasted in an example here, and this is a function. So I called it today's net, and I'm taking all of the values here inside of our today's transaction because we're passing in a transaction object as transactions. This function should return a number over here, and you can see I start off with a total equal to 0. I'm going to return the total. But in the middle here, I loop through the object that is passed in, the transaction object, and normally in the for in loop that I'm using here, here's for, here's in, I've got transaction in transactions, I'm accessing each one of those transactions and then just totaling them up. However, this is what we would do in vanilla JavaScript, but in TypeScript, we once again get that same error that we saw above when we tried to dynamically access this value. So let's fix this by providing an index signature. Let's look at how we can do that. First of all, let's say we didn't know what any of these names were going to be. So I'm just going to comment this out. And then after we comment that out, we'll just create another interface with that same name. I'll say interface. This is transaction object. Now inside, the syntax looks almost like we're creating a property, but it starts with brackets. And then we can say index, or you may see examples that use the word key. Either would work. And after that, we'll say all of the keys in this object of the key value pairs are going to be strings. And after that, we can say all of the values are going to be numbers. And now this is an index signature, and it just declares that we know all of the keys will be strings and all of the values will be numbers. And yes, we could use union types over here, so we could say string and of course go on to say Boolean or have an array or any of those things. The keys, however, are usually strings, but they can be other things as well, but it cannot be Boolean, for example. So I'll put Boolean in here, and you can see TypeScript says, I don't like that. Let me get rid of the other IntelliSense. Here we go. It says an index signature parameter type must be a string, number, or symbol, or a template literal type. So there are options, but Boolean is definitely not one of those. So I'll just put string back here. Now, TypeScript should be good with everything we had below. Yes, you can see we can now access this dynamically, and our function, today's net, is also going to work as we loop through the object inside of the function here. So when I save this, we should see all of those results over here. So yes, we accessed pizza dynamically through the prop variable, and that's where we get the third minus 10. And our function, today's net, that I call below it when we pass in today's transactions, is a total of 35, and we can see that because we have 50 here and minus 10 and minus 5 when we passed in today's transactions. Let's also note that we could make this read only, and that would not allow any assignments to any property inside of the object that is created. So I'll save that, and now let's go below and try to assign something here. So I'll say today's transactions, and then I'll just use dot notation to get pizza. Let's try to assign 40. You can see TypeScript does not like that. It says index signature type only permits reading. So we can comment that out, but I'll leave it in the course resources inside of our source code here so you can access this and just see the difference. Also, let's look at one other example that could be a drawback because TypeScript can't see into the future. It doesn't know what property names you're going to have either. And that leaves something open that is not quite as safe. So we could say today's transactions. There we go. Press tab. And now let's try to access a property named Dave. And you can see TypeScript doesn't give us an error. This is going to return undefined because it doesn't exist on the object, but TypeScript has no problem with it because it has no way to know what names we would give the keys, because remember our interface up here just says it's going to be an index of string and it should return a number. So TypeScript really thinks this is going to return a number, but it's going to be undefined as we see over here in the console. So it's not entirely safe. This does open up the possibility for you to try to access a key on an object that does not exist. And so one more consideration, what if we knew we were going to have pizza, books, and job in our object, but we also wanted to provide an index signature, and of course we could possibly add more. Well, let's just copy this first. We'll copy the index signature. I'll comment out this transaction object at the top, and let me bring this one back, and at first TypeScript will have an issue. And then it won't when we add in the index signature right here. So this provides an index signature, and this would allow other properties to be added to an object that was created with this interface. However, this interface will also require pizza, books, and jobs. You can see if I come here and cut job out, TypeScript instantly gives us the red squiggly under today's transaction that says property job is missing. But I could add something else underneath like Dave and just say, hey. But it doesn't like that because we said everything needs to be a number, right? So if I mouse over this, it says string is not assignable to numbers. So maybe I should say 42, and now it's fine. But Dave is not required. The other three are because we have that in our interface. Let's scroll down and I'll provide another example below these. So here we'll scroll and give a little bit of a comment line to divide our examples. I'm going to create another interface. We'll call this interface student. And then inside of this, we'll have a name that would be a string, and I'll put a comma after that. Let's also have a GPA, and we'll call this number. And finally, let's do classes, and let's make this optional. If you remember how to make it optional, we start with a question mark first. And let's have this be an array of numbers. So now we have our student interface. And by the way, while I'm thinking of it, we can use commas here, semicolons, and I believe you won't have an error even if you remove the comma or semicolon. However, stay consistent in whatever your choice is. Okay, now we've got our interface. And now after that, I'm just going to create an object, and I'll paste that object in. You can see I'm creating a student object, all lowercase, from the student interface. And so we've got Doug here with a GPA of 3.5, and he's in two classes, the 100 level and the 200 level. So right now, this is a strict interface. So if I said console.log and tried to access student.test, which doesn't exist, you can see TypeScript says, that's no good, test doesn't exist on type student that we have above. But what if we provide an index signature? So once again, I'll put this in and I'll say key string. Now over here, we've got several different types. So if I just say string, TypeScript is still not going to like GPA or classes. We have to put in every value type. So we have number. TypeScript is still not happy with classes. So we put in an array of numbers. But let's look. TypeScript is still not happy with classes. Why? It says property classes of type number could also be undefined, and that's because this is optional here. So we also need to provide undefined when one of the properties is optional. Now notice a byproduct of providing this index signature on our interface student is TypeScript no longer has an issue with us trying to access test, because now TypeScript doesn't know maybe it will have test. So it goes ahead and lets us do this, where before, when we didn't have this index signature, TypeScript said, hey, this doesn't exist on student. So again, just the potential for a problem there if we try to access a property that doesn't exist. Okay, after that, let's go ahead and write some more code that will iterate through our student here in a loop, and we'll once again see what issue may occur. So let's say for const, and we'll say key in student. And now inside the loop, let's access this, and I'll use a template literal. And here I'll say for, well, not for, just the key itself. So we'll log the key, have a colon, and after that, we will log the student. And now normally here we would just use the key. And right now there is no problem with that. So if we save, we see name Doug, GPA 3.5, classes 100 and 200. But if I come up here and comment out our index signature, then we'll probably have a problem down here. Yes, we're going to see that same issue right here. So what I want to show is how you can iterate through an object you've created that does not have an index signature provided as we have here. So I'm going to leave this commented out, And now we're going to use the keyof keyword and an assertion. So when we access this, and we can do this right inside the brackets, we could say key as, and now you know we're going to use an assertion, say as keyof, and now we'll say student. We'll list the interface. And now notice TypeScript has no problem, even though we don't have a key up here. What keyof does is creates a union type, and the union type is the specific string literal. So it's a union type of name, GPA, and classes that keyof is creating, and it allows us to still loop through the object. And you can see we get the same result here in the console. I want to give one more example, just an alternate version of this, and I'll say object.keys, and I'll pass in the student. So now you know this makes an array of the keys in the student object. I'm going to map over those keys, and then inside the function, I'm going to log, and I'll just log the student object, but now we'll access this with brackets again. So once again, dynamically accessing the property values, and I want to say key as keyof as we did before. But now imagine that we don't know what the student object, what the type of it is. So the interface, we just have an object and we don't know exactly the type. So now we could say type of and list the object itself. Notice it's the lowercase student, not the uppercase student interface that we referenced here. And now TypeScript is good with that too, because now we're saying we don't know what the type of is, so we're just retrieving the type of by referencing the object itself. And this also works. So when I save, we'll see the difference in the console because I didn't use the same log of a template literal. So we just accessed those values. We got Doug 3.5 and our array that has 100 and 200. And now let's look at one more keyof example, and I'm going to do that with a function. So I'll say const log student key. This is going to be a function that has a student object passed into it, and it's going to be the type of student that we defined in the interface. And then we'll specify the key right here. And in the parameters of the object, we can just say keyof student. So we're defining what we're going to use as the key inside the function right here as we pass in the parameter. And then I'm just going to say a void return. So I guess I need to put that here and then have our arrow. And then inside the function, I'll just say console log. And now we can put a template literal, and I'll say student. And now I'll say key, and after that I'll put a colon, and now we'll say student, and with bracket notation we can access the key. And notice there's no problem doing this, and this is what we're used to from JavaScript already, because we've clearly defined key up here as the key of student. So once again, it defines this key as a string literal, and it's made up of the different names that are inside of student. So name, GPA, and classes right there. So once we save, we should see this. Well, I need to call the function first, I guess. We defined it here. So let's say log student, and now we can pass in our student object once I spell it correctly. And let's get the GPA property, and that's the one we're going to access. So now we can see student GPA is 3.5. We could change this to one of the other properties that we had. So we had name or classes. Let's go with name. So now we should have student name is Doug. So our function is working properly and TypeScript is happy with it. I'm going to scroll up to the top so we have a little more room, put in one more divider for our examples, save that. Now I'm going to create an interface, and I'll call this incomes. And from what we learned before, we can provide an index signature with a bracket. There we go. And I'll say key string, and then the values will be numbers. And this is what we've essentially learned before. And of course, you could have different data types over here or a union. And there are some other possibilities besides just a string over here. We could even have a union of string and number if we wanted to. And while TypeScript is good with all of that, I want to show another way, essentially the equivalent of providing this index signature here on the interface, but we're going to do it with a type. And I'll start by saying type, and I'll call this streams, and I'm just going to provide a string literal of a union type that has string literals. I'll say salary. After that, we'll also have a bonus. And after that, let's also have, well, Here we go. I got the correct pipe now. I'll say side hustle. So there's our union type for streams. Underneath that, I'll define another type, and this type we'll call incomes. So I'll need to comment out the one we have above because this is going to replace that. And here, we're going to use the utility type record. Now we'll use an angle bracket, and I'm going to pass in the union that I created above. So we could, of course, just copy this and paste it right in here to replace streams, but it just makes it longer. So it's easier to define another type and then put everything in we want and put it right here. And after streams, I'm going to say these are numbers and close the angle bracket. Now that syntax is definitely smaller, and it allows us to use string literals here as the different types that are expected. And that comes into play when if I comment this out, for example, and come back to our interface up above and put this back in, if I were to try to put a string literal in here and say salary, you can see we instantly have a problem with TypeScript, and it says it cannot be a literal type when we do it this way. So if we want to provide a literal type here, we can with the utility type record. So I'll go ahead and switch that back to what it had before, which was string, but then I'll also comment that out, and we'll come back to our type here. So this is a benefit. Now, there could also be some issues because we're not specifically stating, let's say we had another property up here like we did before. I'll tab it over to look right, but we had pizza and said this was a string, for example. And of course, since I commented it out, it's giving us a problem. We can't do that here. So if we had different property types, say in our stream, salary, bonus, and side hustle, and we were accepting numbers and strings over here, we're not saying salary is always a number and bonus is always a string when we do that. We're saying salary can be a number or a string, bonus can be a number or a string, and the same for side hustle. Here we were able to declare specifically that pizza was always a string. So a little bit of a drawback, but also a little bit of a benefit where we can use these string literal types in as the keys. So just below our record, I'm going to paste in an object here, and we'll call this monthly incomes. And you can see it's based on our incomes that we have defined here, the incomes type. Salary has 500, bonus has 100, and side hustle has 250. Now, what if we want to loop through these? Because I have said these were essentially equivalent. So when we provided an index signature like we did in the interface up here, we were able to loop through things with no problem, without an error. Can we still do that with the record utility type? Let's find out. So I'll say for const, let's call this revenue in monthly incomes. Now inside the loop, let's just log what we have. So I'll say console log, and I'll have monthly incomes, and we want to use bracket notation. And I put in revenue, and look, TypeScript has a problem with this, unlike when we use the index signature inside of an interface or a type in this manner. So now we need to, of course, use our assertion, even though we have defined everything using the record utility type. So here we would say as key of incomes. And now everything is good once again in TypeScript. So just know, if you use the record utility type instead of providing an index signature like this, you're still going to have to access key of. So when I save, we should now see 500, 100, and 250 over here in the console. Our starter code today is the code from lesson 7. I'm just going to select it all with Control A and press backspace as we will start fresh today. Save our main.ts file, then we can open up the terminal with Control and backtick and just type tsc-w to start TypeScript, and it will start watching our main.ts file and compile that to a JS file that's in our build directory. And if you haven't started your project, you can go into the build directory, choose the index.html file, and we've been using the live server extension to launch the project. So I'm going to click Go Live here and launch our project. Now we've got a new tab in the browser, and I can click in the browser to select it and press Control, Shift, and the letter I to open up the DevTools, and you see Live Reload enabled. We don't have anything because we've currently cleared out our main.ts file. So I'm going to press Control B to hide the file tree. I'm going to just drag this window to the left so we can see the console on the right and my TypeScript code here on the left. And today we're talking about generics. Why do we need them? What are generics? Well, the idea of TypeScript is to define strict types for a type-safe developer experience. And to do that, we're usually as detailed as possible. However, TypeScript does allow for generics because sometimes we simply don't know what types will be passed into a function, interface, type alias, class, all of the above. And generics allow us to provide a placeholder, a type variable, if you will. So let's look at a basic example, and I'll just create a function as we normally would, and I'm going to call this string echo, and then this function is going to receive an argument, and that argument's going to be a string, so we can define the type there. Oh, I missed the colon. Let's say argument string, and it's going to return a string as well, and then really it's just going to be the argument. We're not going to have it do anything, so it's just going to return what we pass in. Now, this function is fine, except notice it's dedicated to a string. It only works with the string type. But what if we wanted to write a more generic function? We could abstract the type out, so this would work with any function. So let's do that. Instead of string echo, let's just call this echo, and let's use what we called a type parameter, or a type variable, and I'll represent that with t. This looks a little strange, but you could really call it anything. However, most examples you see will use the letter t, probably for what type or TypeScript. After that, instead of string, we're going to put t here as well, and we're also going to say it returns the type t. And you can see this function also works, but what we have accomplished here is making it generic. And so now it doesn't only work with the string type, it works with any type we would pass into this function. So again, a basic example, this is the overall syntax here. So we're providing whatever that type variable is in front, and then we're using it in the parameter, and we're also using it here in the return type. Now, it doesn't have to be in the return type. It's just wherever we need it to be. So as you might guess, this could be useful with utility functions where we aren't sure what type we're going to pass in. Maybe we're going to check to see if it is a certain type. And that's what we'll do here. I'll create a function called isObject. I'll abbreviate that with obj, with obj there. And we'll set this equal to a function, and we'll put in our type variable placeholder. And we'll once again call the argument arg, and it will be of the type that we have a placeholder for. But this is going to return a Boolean, whether we have an object or not. And then inside the function here, we'll check several things. So I'm going to return and start with the parentheses. We'll say type of arg equals object. But we also know if it's an array, it will return type of object. So we want to say if it's not an array, it would be true. So to do that, I'll put the double ampersand and we'll say not, and then array dot is array, and we'll pass in our argument. And so if it is not an array there, and then we'll say one more double ampersand because null also returns type of object. So we want to make sure arg is not equal to null. So here we've got three different things we're checking for, but we're doing all of that in one line. It's going to return true or false, but we're not sure what type we're going to pass in here for arg. We could be passing in any type. So let's save this, and then I'm just going to paste over a few different things we can call to the console here. So I'll put this in underneath and save. And now look in the console. For the first, we pass in true, and we get false, because that's a Boolean type. We pass in a string for the second example, false. We pass in an array for the third example. We pass in an object for the fourth example, and we pass in null for the fifth example. So we can see our function's working as expected, and it accepts all these different types, and it returns our Boolean as we need it to. Okay, I'm going to scroll up, and let's look at another example of a utility function. And one good sign or indication that you need a generic is when your function has to do some logic, some thinking about what it needs to return. So we'll see that in this example. Let's say const is true, and I'm going to set this, of course, with that type variable placeholder there. once again, take an argument and have it be that same type. And then this is going to return an object, and we can specify that here. The shape of the object, I'll say arg_t once again, and it's also going to have an is property. It's going to be a Boolean in the return, and then this is an arrow function. And then inside the function, let's first just say return, and we're going to return an object that has an argument property, and we can just put a comma after that because it has the same name as the property, the variable does. And then we can also say is, and I'll use what is called the double bang operator there. This would take a 0 essentially, and then flip it back, and that makes it true or false instead of, say, a 0 or a 1. So you're just flipping it around twice, and it takes anything else, and it essentially returns a Boolean that way instead of the other data that it might have. So what we're going to do is take anything that's a string, a number, or a Boolean, and we're going to turn it into a true or false response here with that. But what about if we have an object or an array? So let's break this down for an array first. We'll say if we have an array, say is array, and we'll pass in the argument. And then let's also say double ampersand, and then we've already checked to see if we have an array. So by the time it makes it to this point, we don't have to worry about if there's a length property or not. But we are flipping this around once again to say, okay, if there is length, make this false. Otherwise, if there's not length, this would be true. And then we'll return our object, and it's going to have an arg once again, but the is value is going to be false here. So that is our check for an array. Now, what about if we have an object? So let's say if, and let's use our is_obj we created above and pass in that argument. Then let's double ampersand this again, because we're going to flip this around as well and make sure that there is something inside the object. In other words, normally an empty object or an empty array would be true, but we don't want that to be true in the case of our custom function here. So I'm going to say, once again, the exclamation mark and object.keys. Then I'm going to pass in arg, and look at what we get here. We get a red squiggly. But if you remember from our previous lesson on index signatures, we can handle this with an assertion using keyof. So I can say as keyof t, which was the type that we passed in above. That's what we have. If this is an object, we do at least. Then I can attach length there. And once again, well, it looks like I missed a parentheses there as well. So let me check that, or maybe I have an extra one. And now I'll put the return statement. Now, note, we could have put both of these if checks into one. It would have just been longer. But I can say arg here once again and is false. So yes, I realize I could have combined these and had a longer if statement with an or in between, but I chose to break it down into the array and then into the object. A little easier to describe as we went as well. So this is the full function. We can save that, and now let me go ahead and paste in some more console logs to check, and we'll see what we get when we put all of these through. Now we'll run, and you can see what we're getting over here in the console. We're checking all of these values, and it's easy to see in the console too because we're returning this object. So false is false, 0 is false, of course true is true, and 1 is true. A string is true, but an empty string is false. Null is false, undefined is false. Now let's look at these objects. We set it so an empty object is false, and then the next object had a property and a value in it, and that is true. And then we had an empty array, which we set to false in our custom function. And then we had an array with items in it, which was true, and then nan and -0 are false. And you can check other things as well. So a lot to check there. But as we break this down, the things to notice, we could pass in any of these types of data once again. And we even used our t, our variable type, or our type variable, I should say, not only here in the return value, but we also used it in the function as needed for the object.keys when we check the length. Okay, when you look at our isTrue function, you may think on this return value, we could have defined that earlier with an interface or a type, and that is true. So let's go ahead and copy this function down and scroll underneath all of our console logs. And let's redo this function with an interface as well. So above this, I'm going to create an interface. I'm going to call this bool check, as in a Boolean check. And this interface can also have a type variable. And then inside of the interface, I'll put value is equal to our type variable. I'm going to say is going to be a Boolean because that's what we were returning. Okay, we need to rename our function because it doesn't like the duplicate definition with const. So let's name this something like check bool value here. Now we'll have the same type variable placeholder here, and we'll have the same for our arg that is t here. But now we can shorten this signature up for the return value, and we can just pass in our bool check that we defined before, and it needs the t here. And I believe I didn't type it the same. Yes, I had a capital C above. So that should make a difference there. Yep. Bool check is fine. Now, what problems do we have in the function? Well, previously we're just using arg and then, of course, having the same value identified with the arg variable. Now we're using value up here. So we need to say value in front of arg, and we need to do that in every place that occurs. So we had it there as well. And finally, in this last return here, and TypeScript should be now happy with our function. And what we did was use a type placeholder, a generic, in the interface, and then we used the interface here as part of our function. Now let's scroll up again and let's look at another example where we can use an interface. So I'll create a new interface here. I'm going to call this hasID. And so the interface is just going to have one property, ID, and that's going to be a number. Very simple. After that, we'll create a function, and this is just an example function I'm going to call process user. And for this, I want to show how you can use the extends keyword. So not only will we have our type variable here for our generic, but we'll say extends hasID. What we're doing here is narrowing that generic type. So now the type will have to have an ID property. That will be required. So here we'll say this is going to be user, and it will be of type T. And this is going to return type T. And then inside the function, we would essentially process the user with logic here, I'll say. And then just for this example, I'll say return user. So TypeScript is happy. But you can see now, if we were to call process user, it's going to use this hasID interface. It's going to extend that to the type. So we've narrowed the type to now what we pass in as the user has to have an ID property. And we can look at examples of this, although our function doesn't really do anything. I'll say console.log, then I'll call process user. Now inside of process user, I'll create an object and I'll say ID is 1 and then name is Dave. TypeScript seems happy with that, no problem. But if I copy this down and I go ahead and just remove the ID from the second line, you can see now we have an indication there's an error. And once again, it identifies the problem. It's not assignable to the hasID type. So that's the kind of message we're going to get, of course. So that is ideal. We want TypeScript to help us know what we must pass in. Okay, I'm going to comment out our second line here just because it's the error, but you will know what that does if you uncomment it as you look at the course resources that are available in the link in the description for the video. Okay, a more complex example now with extends once again. So I'm going to say const, and this will be get users property. Let's set this equal to our placeholder here with t extends our hasID, but now we can use more than one. So here's another type variable for our generic. I'll say k, and here I'm going to say extends keyof t. So what this means is we are building k as a key of the first type that we pass in, the key of T. And so here I'm going to say users, and this is going to be T, but it's going to be an array full of that type. And then next I'll say key, and that will be K. And then this is going to return T, and we'll have K here, and then this will be the array. So we have the different values that are inside that we identify with the key that will be in the array. And here, this might be a little easier to see once we go ahead and log it out. And now inside this function, I'm going to say return. I'll just take the users.map, and now for each user, we're going to return the user and the key. Okay, so this is going to identify the values for that user. So we've abstracted quite a bit here. Let me break this down in a little simpler terms, and then we'll look at a console log, which will also help. But essentially, imagine T here as an object that has an ID, and this is going to be a user object. And then K is going to be the keys of T, of that user object. So here we're going to have an array of user objects, and we've identified the key as K. So to get those values, you see we have to use the key to identify which value from the user, and that's the type of array we're having here, because T is the user object, K is the key, and then we'll have an array full of those values identified. Okay, I've grabbed a couple of large objects for users and put them in an array that I'm going to paste in now, and I get this information from the JSON placeholder website. If you're curious, I've used it in several different tutorials in the past as well. So this is just a couple of users, and you can see there's lots of properties and even some nested objects here. And then here starts the second user. So we're all the way down here. Let's go ahead and call our function inside of a console log, and I'll say get users property. And now we'll pass in our users array for users. And then when I start the string, notice TypeScript is already trying to help us out. The IntelliSense is telling us what properties are on the user. Now these are the top level properties, none of the nested ones if there's a nested object. So let's get the email first, and let's go ahead and save this. And now we'll see here at the bottom of our log, we have an array returned with the two users' emails. So we can see those above. We find it. Here's the first one. And then here is the second one right here. So if we look back at our function, you can see we passed in an array of users, and our array just has two users. So that was represented here. So the T is the user object type. We have an array of that. And then we looked at those keys, and we were able to map through those keys essentially and through our users without using an assertion, because we used the K extends keyof right up here as we passed in our type variable. So a very cool use of generics here as we break that out. Now let's go ahead and get one more property. I will copy this down. Let's get rid of that email value here, and if I go ahead and maybe delete that and type a quote, yes, we once again get the help from our IntelliSense to say what do we want to get. So I'll choose username and save. Now we should get a second array. Here is the second array with Brett and Antoinette. Okay, that example was a little complex, but let's look at one more example before we're finished. And this is an example of using a generic in a class. And so let's go ahead and create a class, and I'm simply going to call this a state object. And this is going to have a type variable. So it is a generic, and inside of this we'll say private, and we'll just call this data, and this will be that same type that is specified in our generic above. Now let's use our constructor, and we'll have a value, and it will be that same type T, and we'll say this dot data equals value. Now below that, let's put a getter and a setter for our state. So I'll say get, and I'll have state, and this is going to return that same type T, and we'll say return this dot data. Now we'll also have a setter, and we'll set state. Value is going to be T that's passed in. Notice if we try to put void here, TypeScript won't like it. I could go ahead and do that, and then we'll see the message we get. It'll say a setter does not have a return type annotation. So we should not provide void here. We're just going to have a setter, and that's the way it likes it. We'll say this.data equals value. So we've got a very, very simple state object here using a getter and a setter. Now there's some things to observe about this. So let's go ahead and create one. Let's call it store, and let's set it equal to a new state object. And let's pass in John to start out with. Everything seems fine as we do that. So let's go ahead and console.log, and let's say store.state, and it should instantly use our getter when we do that. And now if we look in the console, we see John over here. But let's go ahead and now try to say store.state, use the setter, and set it, well, let's set it equal to Dave. And no problem. There's no problem. We didn't try to log that yet, but TypeScript has no problem with that. Notice these are both string types. If we try to say store.state equals 12, TypeScript doesn't like this. Let's look at the message we get. It says type number is not assignable to type string. So instantly, after we assigned John, TypeScript inferred that's the type of our state, and it's not going to accept another type. So let me remove John here to begin with, and we'll get a message here, and as we mouse over, it will say state object unknown, and the value is unknown. So it hasn't inferred that until we pass that in. But then after we pass it in, it does infer that, and when we mouse over our state object, now it says string and value string. Notice the brackets above by the state object here, that says string. So what we have done, what it is currently inferring, is if we specified the type right there, and you can do that. So if we create another state object, let me go ahead and comment this one out, and I can leave that there. We could do that, or I'll just leave this as an example of inference. But let's create another one, and I'll say my state. Set this equal to a new state object. And here we're going to say, well, before we pass anything in, we'll use the angle brackets. And I'm going to say this is going to accept string, number, and Boolean, and it's going to be an array. And then I'm going to pass in an array with the number 15 in it. And TypeScript is fine. So now we specified exactly what type we are using in our state. And now it's going to accept anything that's a string, number, or Boolean as long as we have it in an array. So we could go ahead and set that. I could say my state.state. We could set it equal to, well, let's have an array with Dave and the number 42 and true. And TypeScript is fine with that. So we could console.log, and we can say my state.state, and everything should be good. Once I hit save, we see our state array over here with Dave, 42, and true. Our starter code today is the code from lesson 8. This is lesson 9, so I'm just going to select all of the code in the main.ts file and press backspace. I selected all of that with Control A, by the way. Now I'll save with Control S, and we're ready to start the code for utility types, which is what we're discussing today. First, let's go ahead and start TypeScript if you haven't. So Control and the backtick to open a terminal window. TSC for TypeScript, and then -W for watch, and that will watch all of the files that we have in our source directory, and it will compile those to JavaScript in our build directory. Now, we've covered that in the first lesson, so if you're just jumping in here and you're not aware of that or how to set up the TS config file, you may want to go back to the beginning of this series and do the lessons in order. Okay, utility types, our topic for today. So I'll just put that up here at the top. Now, TypeScript offers many utility types that are helpful for common type transformations, and we're going to cover a lot of those today. The first type we'll look at is a partial. So I'll just notate that above here. I'm going to paste in an interface that we have. Notice this is called assignment. And it has a student ID and a title, both are strings, a grade, which is a number, and an optional verified, which is a Boolean. Now with that, let's create an update assignment function. So I'll say const update assignment. I'm going to set that equal to a function here that accepts a parameter called assign, and that will be an assignment. After that, we're going to say props to update, and we can specify these as a partial. So we don't want all the props, just the ones we're going to update. And this will be an assignment. And I'm going to press Control Z so this wraps down. We can see our partial with the assignment here. And now we can just specify some of the props. Well, we don't even have to specify. We're just essentially saying that we're not going to require all of the props from assignment. So just the ones we pass in. Now, this is going to return an assignment. And then after that, we need to go ahead and say what our function is going to do inside. So I'm going to return an object, and we'll just spread in the assignment that we pass in, and then we'll overwrite any of those props we want to update. So here we can spread in the props to update. So this allows us to not pass in all of the props, but declare that they are props of assignment. So let's go ahead and look at how this works. Just below, I'll go ahead and paste in a assignment that we create here first. So I've got assign one. Notice it's got a student ID, a title, and a grade. It does not have the optional verified, and that's okay. Now, when we call this function, and you can see I'm going to log the result, I'm passing in this assignment that we created, and then I'm overriding the grade property. So that is the props to update that we're passing in right there. So again, it's a partial of assignment. And then notice I'm creating an assign graded underneath that, which is an assignment, and I'm calling that same thing. So I'm just saving that in assign graded, which we're going to use here in just a little bit. So let me save this. Now this code should run, but if you haven't yet, what we need to do is go ahead and start our application. I'm using the live server extension to launch our page. So here, click anywhere inside of the index.html. You can click Go Live if you have the live server extension, and it launches here in Chrome. Now we just have a blank page, so I need to open DevTools with Control, Shift, and the letter I. And now we've got our console here. I'll clear that out and reload one time. And I'm going to switch the view to the bottom for the console. So now we see just a little different view, and we don't see that browser over to the left. It's just hidden up here above, which you can drag, but I'm just dragging it all the way up. So there is what we are logging, and that is that assignment object. So notice it returned the assignment object. I'll go ahead and close the HTML file, and I will drag Visual Studio Code to the left and press Control B to hide the file tree. So now we can see everything well. And what we're logging here is on line 22, we're calling update assignment and having it updated. Likewise, we could have just logged assign graded, where I am saving that as well, because we're calling it again with assign one and even the same grade value here as we update that prop. But this is using the partial utility type, allowing us to pass in an object that just has one property of assignment. Okay, now let's look at a couple more utility types. We're going to look at required, and if I could spell required, there we go, and read only. We'll look at both of these utility types. And to do this, I'm going to create another function, and I'm going to call it record assignment, as if we're going to record this information into the database. So here I'm going to say assign, and now we'll say required, and we'll pass in an assignment. So what this does is it requires all of the properties. Remember, we had that verified property up here that is optional. Well, now by putting required, the utility type here, with the assignment, that means verified and all of the other properties are now required. Okay, after this, we're going to say this is also going to return an assignment. And we'll just create a function here, and I'm not going to put in all the logic, but essentially we'll send to database, etc., whatever we would do with the data. And then we'll return the assignment that we have completed that task with. So that is our record assignment function, and now all of those properties are required. So let's create a verified assignment, and I'm going to call that assign verified here. And you can see now I'm using the read-only utility type, so we can't overwrite any of those properties either. So we've created that, And what we're setting it equal to is the assign graded, remember that one that I created up here in the first example, plus the property verified true, because it is also required. Otherwise, this wouldn't work for our record assignment function. Now, if I took assign verified and I tried to change the grade to 88, that won't work because assign verified has all read-only properties. So if we mouse over, we can see cannot assign to grade because it is a read-only property. So that won't work. So let's try to call record assignment, and if we just pass in assign graded, remember that was created above and it only had the 3 properties without having verified. We created it right here in the first example. That won't work either because it will say we're missing a property. Yep, it's a required assignment and verified is not there. So that also won't work. However, we could go ahead and put this in an object and spread it in. And then we could add our verified as well. So we could say verified and true. And let's go ahead and end that with a curly brace. And now record assignment is okay because it has all of the properties. Verified is no longer optional, so that must be passed in to our record assignment. Now let's look at what may be the most popular utility type of all, and that is the record type. It's very easy to use. Let's look at an example here where I create a hex color map and I use the record utility type, and I'm telling it that the keys will be strings and the values will also be strings. And that's what we have here, and I'm just using the hex colors that we use in HTML, red, green, and blue. And you can see we've got a string for the key and a string for the value of each. But you can also create string literal types. So let's look at an example of this, and I'll say type students. I'm going to set this equal to Sarah and Kelly, and this is a union type of string literals. And after I do that, I'm going to create another type, and this is letter grades. And so at least at university, we would have an A, a B, a C, also a D, and then instead of an F, we have U's. So U is unsatisfactory or failing. But there's our 5 different string literals for letter grades. So we've created our types, students and letter grades. So now if we create final grades, we could set this equal to a record, and the keys will be the students, and then the values will be the letter grades type. And if we set this equal, we can go ahead and create this, and we can give Sarah a B, and we could give Kelly a U, for example. And that works. That satisfies both of these because we have met the string literal type here for the values and for the keys as well. If we tried to provide a different value, say Z, TypeScript would not like that. So let's put it back to what it likes. And we can also do this with an interface. Let me scroll up and I'll create a simple interface below, and I'll call this grades. And now if we had assign 1 and said that is a number, and we have assign 2 and that is also a number, we can now apply this as we create grade data. So let me do that, and I'll say grade data, and that's going to be a record. And once again, I'll pass in the students, which was our string literal type, as the keys, and now I'll pass in grades as the possible values. Now inside of this, we'll say we have Sarah, and now this is an object as grades is our interface, and we'll say assign 1 had a score of 85, and assign 2 had a score of 93. Now let's put a comma after that, and we can put in Kelly as well because we have to have both students in. And now this needs to match, so I'll just say assign 1 is 76, and assign 2 a 15, which is why Kelly got that grade of U. So that's the record utility type, and you can see we went from a simple example where we specified just a string to where we used different string literal types here, and then we also used an interface. So it can be used in several ways as you create your record object. Now let's scroll for some room, and we'll look at a couple of useful types that go hand in hand, pick and omit. So as we look at this, let's start with a type, and we'll call it assign result. Let's set this equal to pick, and we'll pass in our assignment that we have created before. And now let's give a string literal here for the possible values. So we'll say, let me get a lowercase, there we go, student ID, and then let's also have a union type and say grade. And so what we have done is we have picked what we want to use from our assignment that we created way back up here at the top. If we look back at the assignment, we had student ID, title, grade, and verified. And now we're picking the properties that we want to use as we create this new type assign result, and we used student ID and grade. So let's create a score, and we'll say this is an assign result type that we have created now. We'll set this equal to a student ID. You can see I should accept the help instead of trying to type, so VS Code is helping me because it already knows what we've defined in the type. And then grade, and that is an 85, and now TypeScript is happy because we have provided both of the properties that we picked from assignment as we created score. And now, as you might guess, omit will do the opposite. So let's say type assign preview, and we'll set this equal to omit. We'll once again pass in the assignment. And now we'll say what properties we want to omit. So we want to omit the grade because we're previewing, we won't have a grade yet, and we want to omit verified as well. So now when we use this, we'll say const preview, and we'll say this is a type assign preview. And now let's set this equal to an object that will have the student ID, and we'll once again say K123 just to have a random value. And we need the title. And for the title, we can just say it's the final project. And TypeScript is going to be happy because we provided both things that were required once again, and we omitted the grade and the verified. So if we switch this, for example, to grade, TypeScript is not going to like that. It needs both of the properties that were not omitted. So now as we worked with pick and omit, if we scroll up, you can see we're applying those to an interface that we have. So I really want to highlight that because they could be confused with the next two types that we work with here. And as I enter those, they're called exclude and extract. But they're not going to work with an interface. They're going to work with string literal union types here as we apply these. So let's say type adjusted grade. We're going to set this equal to exclude. And now I'm going to pass in what we created for letter grades. And you can see TypeScript was even highlighting what those are. If you remember, that was a union type of 5 different string literals, A, B, C, D, and U. After that, I'm going to tell it to exclude the U string literal from that union type. And then let's say type high grades. And I said adjusted grade before, but this is high grades. We'll set this equal to extract. We'll pass in letter grades once again, and I'm going to extract the A and the B. Now this is a union type as well. We notice that we're passing in here. So high grades, if I mouse over it, it's going to say it's just A and B now, instead of everything that we had in letter grades, which was A, B, C, D, and U. Adjusted grade is going to be A, B, C, D because we excluded U. And now one more type to look at as we consider this is non-nullable. There we go. And I'm going to say type all possible grades. And here we'll call this a union type, and I'll have Dave and also have John. And then after John, I'm going to have the possibility of null and also the possibility of undefined. So Dave and John could receive grades, but also it might be possible that we would have a null or undefined. However, if I want to create a type that says names only, now I'm going to set that equal to non-nullable, and I'm going to pass in our all possible grades. And let's look at the difference. When I mouse over names only, it's only equal to the union of the string literals Dave and John. It has excluded both null and undefined from our all possible grades type. to now just create a type that has only the Dave and John string literal union. Our final few examples are going to be a little more complex, so I'm going to scroll up for some room. And this type example is going to be the return type. There we go. And so let's look at what could happen here. I'll say type new assign, and I'm going to create a new type here that is going to require a title, and it's going to be a string, and I'll say points, and that's going to be a number. So we create this ahead of time before we create a function. That's the typical way you have seen this set up throughout this series. And then we would, of course, provide the return type of a function. So I'll say const create new assign, and then this new assignment is going to receive a title that's going to be a string, and then it's also going to receive points. It's going to be a number. And then after that, we could say it's going to return a new assign, and then we'd go ahead and set up our function. And on the inside of the function, we'll say return, well, it's an object, and since the variable name title is going to match the property name, we could just say title and points. And now it's happy. We have this create new assign function, and we're passing in both a title and points, and we're getting a new assignment at the end. But the problem is, if we change this function, then we also need to change this type. So we've got a couple of things we have to work with to change. But what if we didn't have the new assign return value right there? We didn't say this was new assign. Let's just go ahead and comment this out and not have our new assign type yet. We could create this function, and then after we create the function, then we could say type new assign, and we can set it equal to return type, and now we'll say type of, and we'll pass in our create new assign function. And now let's look at what we get for our type new assign. It looks the same as if we had created it above, but now if we change create new assign, it's always going to update our return type new assign that we have here. And this is very useful, especially if you're working with functions that you didn't create. Say you bring in something from a library and then you update that library and it's changed the function and the return is different. Well, now the return type will automatically be updated too. So I'll just paste in a quick use of this function. We'll go ahead and create tsAssign, and then its assign type here, or it's going to return new assign, and it looks like I spelled new assign with a lowercase in there. I needed the uppercase, and TypeScript helped me find that mistake. So the return type, or the type of tsAssign, is going to be new assign, and then we're going to call create new assign, and everything looks good. So let me go ahead and save. And now we see we've got our title and points over here in our new assign object that was returned. And now the next utility type we're going to look at follows this same theme where we can derive a type from a function, and it's called parameters. So we're going to derive a type from the parameters of the function instead. So I'll say type assign params here. I'm just going to set this equal to parameters. And now I'll say type of once again, and I'll once again pass in our create new assign function. And now if I mouse over and we look at the params, it's a tuple, and it has the title, string, and points number. Now this tuple can be very useful. I'll mouse over once again just so we can see that value. Okay, underneath our type that we've just created with the parameters utility type, let's say const assign params, or assign args, because now we're calling it. So we pass in arguments when we define a function. We use parameters as placeholders for those arguments when I'm being specific. There we go. So assign params is the type as well. Now let's set this equal to, and we'll give some values here in a tuple. So I'll say generics, and then I'll say 100. Now that satisfies the parameters. If you remember from above, when we did that, we had the title and points. So here's our title and points, and they're in the assign args. So now when we call this function, say const ts assign to, and this will be a new assignment, and we'll set this equal to create new assign. Now we can just spread in the assign args that we just defined above. And this is going to call our function accurately. So if we say console.log and we say ts assign to, we should see that value. I'll save. And now we have title generics and points 100 once again for our second assignment. And now for the final utility type that I want to cover, it is a newer utility type in regards to the others we've covered. So in a more recent release of TypeScript, we now have the awaited utility type. And I'll just type here, it helps us with, if I can spell with, the return type of a promise. Now, we haven't worked with promises yet in this series, and this is a good time to show an example of a fetch function. So I'm going to fetch users. I'll just paste this in to start off with though. So let's break this down. We have an interface here called user, has an ID, name, username, and email. And now here is our fetch users function. And notice the return type is a promise, and it's going to have an array of users. Now I'm fetching data from the JSON placeholder website using thentables to then return that data or catch an error. And notice here we have the error, instance of error. So if we have an instance of error, we're going to go ahead and log what that is. Now you can set up a fetch function in different ways in TypeScript. I'm choosing to do it this way so we can catch the error here with the thentable, or we can return that data. And notice I'm setting that to data here, so TypeScript gets the return that it wants down here with the data. But this is returning a promise that has the user array right here. And of course, we're resolving that promise as well. So now to get this return type, if we were to use awaited, let's put type, and I'll call this fetch users return type. I'm going to set this equal to, let me first do it without awaited. So I'll just say return type, and now we would have type of fetch users, just like we saw in the return type example above. But look what happens when I mouse over fetch users return type. It says it's a promise, and then it has the array of users. And we don't really want the promise, we want the result, right? That should be the return type. So here I'm going to say awaited and wrap everything else that we just had. And now let's mouse over and look at our fetch users return type. And it's the type we want. It's our array of users. So now if we call this function, we could just say fetch users, and then I'll put, of course, the operators to call the function, and then have my then, and then we'll have our users data after that function. And I'm just going to console.log users here. And let's save and take a look. And now we have all of the users that we just requested from the JSON placeholder website. And we can accurately get that return type if we need it by using the awaited utility type. Today we're talking about Vite. It looks like you would pronounce the word Vite, but it is pronounced Vite, as in V-E-E-T. Today I'll show you how Vite can help you get any JavaScript, TypeScript, or React project started faster than ever. And Vite also easily works with several other libraries and frameworks. First, you're going to need Node.js. So let's go to nodejs.org. And if you don't have Node installed, you want to install the version that is recommended for most users. As of the making of this video, it's 18.12.1. The LTS stands for long-term support. And even if you do have Node and you just want to upgrade it, maybe you want to download and install that. So after the download, go ahead and install Node.js, and then open up VS Code to an empty folder. I have an empty folder open in VS Code, and I'm going to press Control and the back tick to open a terminal window. And inside this terminal window, I'm going to type node and then -v just to check which version of Node I have installed. And you can see I have the latest 18.12.1. Now that we've confirmed that we have Node, let's go ahead and use npm that comes with Node to create, and then Vite at latest is what you want to type in, and press enter. After we do that, I'm going to go ahead and click this arrow to take our terminal window to full screen here in VS Code. And you can see it's asking for a project name. I'm going to create a Vite Vite-TypeScript project. So that's exactly what I'll call this, Vite-TS-project. And this will create a new folder with this project name. I'll press enter, and you can see it gives me choices for a framework, including the top choice here would just be vanilla JavaScript. Now that's what my TypeScript will compile into, so I'm going to choose that. But if I wanted React, you can see it's in the list, as well as Preact, Lit, Svelte, and others. So I'll just press enter here on vanilla, and then it gives me the choice JavaScript or TypeScript. I'm going to choose TypeScript and press enter. And now you can see it is completed creating that folder with Vite-TS-project, and we're in the parent folder that I called Vite here. So inside of this, it is telling me what to do. It says CD and then choose that folder name. So Vite-TS-project. And now I'm inside of that, as you can see here for the terminal. And now I need to type npm, and you can either type install or just the letter I, which also means install. So I'll just type I. We'll let that install, and after it completes, which it's very fast, and then we'll say npm run dev, and this is going to start up our development server, ready to go. It says it's at localhost 5173. When I mouse over this, it says I can control plus click to go ahead and open it in a new tab. And now that's what I've done. And here is our minimal Vite app already using TypeScript, and it's got a counter in it, which works as well. So now let's explore the folder and see what we created. And that was very fast as far as creating all of that as well. We can close this, by the way, and the server will continue to run. So let's open this folder and see what we've got. We've already got our TS config for TypeScript if we're going to use TypeScript. And of course, we could change our configuration if we wanted to, but the defaults are pretty good for your normal TypeScript usage. And if you've been completing my TypeScript series, you can see it already added the includes source directory that we'd been adding to our TypeScript config file. And you could change those again if you want to. Our package.json already says we've got dev dependencies here of TypeScript and Vite. And you can see what we could choose to do to run our server, as we did before with npm run dev. That's why it's running right now. There's also a build command for when we would deploy. Say we sent this to GitHub, and then we would deploy it to Vercel or another host, and then we could just say where our file is, and it would build right there in our deployment. That's all great. So everything looks good there. Let's look at the minimal stuff here, and we're just pulling in our main.ts in the script that it lists here, and that's because we're in dev mode now, so it hasn't really built that yet. And then inside the source directory, we've got our main.ts file, we've got the counter.ts, and just the basic stuff for that basic page. But that got going very fast. And one thing I want to highlight here is we've also got a vite-env .d.ts. Now this is where we would set the types for environment variables, and Vite has some great documentation on the Vite site that I'll link to in the description that would show that. So we've created one project already. We'd be up and running and ready to write our TypeScript code for this project, but I want to create one more here before we finish. So I'm going to bring this back over, and I'm going to go ahead and open the terminal and press Control-C so we can stop our dev server. And from here, I'm going to CD and type 2 dots, which is going to take us back up to that parent directory. And that's what we see in our file tree over here is the parent directory and then this project. Let's create another project. So I'm going to once again type npm create Vite at latest. Press enter, and it should give us those choices again. I'll let this go back to full screen. What am I going to name this? Well, I'll just say Vite-React-TS-project. So I'm going to use React and TypeScript. I'll go down and choose React by pressing enter, choose TypeScript once again, and now it gives us similar directions. Notice it's already created that project folder for us as well. So I will cd and then Vite-React-TS-project, and then npm I, and then we should be able to type npm run dev, and this will go much faster than create React app if that's how you've been creating your React projects. Okay, npm run dev. This will get up and running, and I should be able to control click and launch this. And now we've got a Vite and React project Once again, a counter that's working, and we can explore those files if we want to. So I will drag this over. Let's look inside of this project, and we can see something more like we're used to for React now. So we'll open this up, and we'll see a main.tsx file. I can close that terminal window again. And then we have our app.tsx file here as well. And there's an assets directory as well. It has the React SVG in it right now. So just a little bit more exploring. Notice it's also got this Vite env.d.ts. Once again, we're using TypeScript now with React that we would see here. Still got that config file for TypeScript here as well. It's got our package.json, and there's also the Vite config that I didn't talk about before, but if we were going to use plugins, this is where we would put that in, and you can see this is using a plugin for React. So that was a very fast way to start a React project, and it's configured TypeScript for us already. We're going to have that type IntelliSense in here too. So let's go to the app.tsx, and we can see what we have here for our basic code. And if I mouse over count, it tells me count is a number. So we're getting that same assistance that we're used to, even if we're not in React when we're working with TypeScript. So it's great. It's ready to go with the IntelliSense already built in. Okay, quickly, I just want to highlight a couple of things in the docs. There is great documentation here for Vite. Let's go to the guide. And then in the guide, you would want to choose deploying a static site. And they already have this mapped out for several hosts, including Vercel, just GitHub Pages even, render.com, Netlify, I believe Firebase is in here. So I wanted to highlight that if you're ready to deploy your project, they make it fairly easy step by step as well. And then as I talked about env variables and modes, they describe all of that here, and it's a little bit different than you may be used to with other projects where you had process.env. Here you would have import.meta.env.mode. And where I talked about type below, well, I said .mode, that would be a built-in variable, but you would put your variable here if you created one. And it shows you how to do that as well here in the docs. Also, though, if you create an env file, if you end it in .local, it will be ignored by Git because you already have a git ignore file that is created for you in those projects as well. So just a couple of things to highlight. I am not an early adopter of new things. I like to wait until they are fleshed out a little bit and are working well within the community. I believe Vite is. I know it's been around for a while, and I just had not experimented with it that much. But now that I've used it, I don't think I'm going back. I think it will be my new choice to launch projects, and it just does such a great job and configures them pretty much like I would want to use them right from the start. The project we will be building today is great for TypeScript beginners, and we'll be focusing on fundamentals. I'll also structure this project with smaller goals. So if you already know TypeScript or you've been completing my TypeScript tutorial series, you can use each section as a code challenge and then compare to the solution that I provide. We'll be building a simple list application like you see here. And of course, you can add an item to the list. You can check items off of the list, you can delete an item, or you can clear the entire list. So let's get started. The first thing you're going to need is Node.js. So if you do not have Node.js installed on your system, download the recommended for most users version that you see right here. Currently, as of the making of this video, that's 18.12.1. After you install that, go ahead and open up VS Code to an empty folder. I have VS Code open. My folder is not completely empty because it contains my TypeScript series. And this is actually going to be lesson 11 when we create this, because lesson 10 did not have a folder with code. It was just an introduction to Vite, which we're going to use today. So now that we have installed Node, let's press Control and the backtick to open a terminal window. And just to verify, type node-v and you can see what version of Node that you have installed. After that, we're going to use Vite to set up our project, and Node comes with npm, which stands for Node Package Manager, and that's why we needed to install Node, and we're going to use npm now, so I'll type npm create Vite, which is VITE, at latest, and press enter. I'm also going to click the arrow over here to take the terminal to the full window now. And we need a project name. You could name it whatever you want to, list project, TypeScript project. I'm going to name this lesson 11 just to fit in with my TypeScript series as you see the other folders over here in the file tree. After that, I'll press enter, and we're going to choose vanilla today because our TypeScript will compile to vanilla JavaScript. After we press enter there, we can choose JavaScript or TypeScript. Let's arrow down and choose TypeScript. And now we're ready to go ahead and complete the commands that it shows us right here. Right now we have the lesson 11 folder, so we need to type cd, which will put us into that directory, change directory essentially, lesson 11, press enter, and now you can see from what we have here that we're now in that lesson 11 folder in the terminal. After that, we need to type npm, and we could just type I, which stands for install, and press enter. And after that, it will quickly set up our project for us. And we can go ahead and type npm run dev, and it will start our project. And you can see our project is now at localhost and port 5173. I mouse over, it will say Control plus click to follow that. So I'll do that. I'll press Control and click. And we've now opened our project in the browser. I'm going to drag the browser to the right of the screen, and on the left we have VS Code, and once I click that it will take up the entire window again, which is fine for now. I'll go ahead and close the terminal window, and I'm going to open that lesson 11 folder that I created. So I'm going to choose open folder and then go into my TypeScript series, choose lesson 11 and open that folder just so we're right inside of the folder that we'll be working in for our project. And you can see Vite has provided basically everything we need. We have a tsconfig file already that is configured the way we will use it today. We have the package.json file that has our scripts. You could rename your project here if you want to. Vite names this exactly what you named the project when you fired it up with Vite in the first place. After that, we have the index.html file here, and there's a getignore file. Inside of the source directory, we have the counter that runs on that startup page when Vite creates a project, so we can delete that counter ts file. We have a style.css file as well as our main.ts file, and we're going to create a folder in here named CSS. And then let's just move this style.css into that CSS directory. After that, we can delete the SVG for TypeScript. We'll go ahead and keep the vite-env.d.ts file. We won't really use it today, but it's a good habit to always keep that in there. If you need it, that's where you would put the types for different environment variables that you might create. After that, inside of the public directory, there is another Vite SVG, and we can delete that as well. Our focus today will be the TypeScript that we write, so I want to just highlight the index.html file right now, and I'm going to provide the HTML for the project. So Control-A to select all of that, and Control-V will paste it in. You can see I have commented out some list items here. They are examples of what we will generate with our TypeScript. However, they're commented out for now, but we can see those if you want to reference those when we're talking about creating these dynamically. And all of this code, the HTML, the CSS, will be available in the course resources for lesson 11. So if you follow that link in the description of the video, you will find all of this where you could just copy the code and paste it in. It is some basic HTML for that list. So I will save this in place, and I'm also going to change out all of that style.css content. So Control-A to select that, and I'll just paste it in here as well. So we have the styles for our list. So this will let us focus on the TypeScript today, but again, if you want that starter code, you can get that from the resources linked to in the description for this video. Now in the main TS file, note we're importing the CSS, and that's how Vite does this. So what we're going to do now is just provide that extra directory, CSS /, so we have import./css/style.css. Besides that, we're not going to use any of this default code that we have in the main TS, so we can delete all of that as well and Control-S to save. We will start today by creating a data model for the list items, so that will be inside of the source directory as well. I'm going to create another directory here. I'm going to name this directory model. Inside of this model directory, I'll create a new file, and it's going to be named list item with capital L and capital I .ts. Now inside of this, I'll help you get started before I issue the challenge. We're going to create an interface. So I'll say export interface, and this will be an item. An item should have an ID, which would be a string. We'll have an item, which is the description, and that is a string. And then it will have a checked status, which is a Boolean. So now that we have this interface, we're going to create a class. I'll Control S to save what we have here. And for the class, we'll say export default, because this will be the default export from this file, and class, and then list item. And now let's implement our item that we created above. Now, here's the challenge. We need to create this class with an ID, an item, and checked. However, the ID, item, and checked refer to the getters and setters. When you actually have the state of this class, it will be with an underscore like this for each one of these. So you'd have an underscore ID, underscore item, and underscore checked. They will be passed into the constructor as private. And so go ahead and set that up if you can. This is where we'll pause, and I'll let you go forward with the challenge, and then I'll come back and provide my solution. Okay, I'm back, and I hope you did well, but let's check this out. And it's a little tricky, but I think after you see it the first time, you will understand how it works. So we have our constructor, and here we're going to pass in these different parameters. So I'll say private, and here's the underscore ID, and this would be a string, and I'm going to give it a default value of an empty string. After that, I'll have private, and then underscore item, and it's also going to be a string, and I'll give it a default value of an empty string. Then I'm going to have private underscore checked, and this is a Boolean, and then I'm going to give it a default value of false. Now after that, we need the curly braces, but we do not have to have any assignment here because we have provided these inside of the constructor. So since we have provided these here, we do not have to have the assignments inside of the curly brace. Although if you do, it's not illegal syntax. It just doubles it up when it is compiled to JavaScript. So you actually have two assignments. That's kind of weird, and it's just a little different than JavaScript. But that's how it looks. Now that we have that, we still need to implement our interface with all of the getters and setters. So I'll come down here and create a get ID. Now, TypeScript is smart enough to know we're referring to a getter and setter when we say ID. So we didn't have to have this indicated as a method up here because it is a getter. After that, we'll have this is a string, and this is going to return this dot underscore ID. Now that we've done that, notice our squiggly went away from the underscore ID here in the constructor as well. So that is our getter for ID. Now let's create the setter. So we'll use the set keyword, and we'll have ID, and then inside of this it will receive an ID, which is a string, and then we'll say this dot underscore ID equals ID. And we can save, and I really don't need that semicolon there. So now we have a getter and a setter for ID. So if you were confused up to this point, this is a good place to stop, and you can go ahead and implement the getter and setter for both item and checked. Okay, I'm back, and we're going to quickly implement the getter and setter for both item and checked. I'll select both of these and then do Shift Alt and the down arrow so it copies them down, and then we can just change ID, which I will highlight here. I'm going to press Control D to select the next one, and the next one, and the next one, and of course the last two as well. Now this is item, so I will change all of this to item. Let's see if it's correct. We're going to get the item, which is a string, and we're going to return this dot underscore item. Here we're going to set the item, and it receives the item, and then this dot underscore item is equal to item. So yes, that is correct. Let's do that again. I'll just highlight both of these, Shift Alt and the down arrow, and now we need to change item to checked. So I'm going to select that one, and then Control D to select all of the other occurrences, and switch this word to checked. And we should be good, but let's make sure. It looks like something is not right. And that's correct, because checked is not a string, it's a Boolean. So we need to switch where we indicated it was a string in both of these. So I'll switch that to Boolean, and now everything looks good. So congratulations, you have completed the first challenge in this project, and that is to create a model for our list item. So we can save this, and now we're ready to move on to the next challenge, and we'll create another model for our full list. So here inside of the model directory, we'll create another file. I'm going to name this full list with a capital F and a capital L .ts. To start this file, we need to import our list item that we have created before. So we'll say from, that is /list item. After that, I'll create another interface. And much like the last one, this is going to refer to a getter for our list, but then it's also going to have methods for the list. So inside of this interface, we'll see a list, which now we can refer to as a list item that we imported, but it's going to be an array of list items. After that, this will have a load method, and the void will be the return. It doesn't really return anything. It's just going to load that list. And then we'll also be able to save the list, and that will be a void as well. We'll clear the list, and you might see the pattern here. It's a void, which often happens when you're working with the DOM. You're doing something to the document object model, and you're not really returning something from the function. After that, we're going to have an add item method. When we would add a new item, it will receive an item object, and this will be a list item that it receives. And this function will also return void. And then we'll remove item. I said remote item. It will be remove item. And this will receive an ID for which item to remove. So that will be a string. And it will also return void. So those are the methods as well as the one getter that are defined here with the interface. So I'll save this. And now let's create this class. So we'll have export default class full list, which implements our list. Now inside of this class, we're going to have a constructor that's going to receive a list, which will also be private. So that should remind you of the list item that we created. Other than that, the list will have a getter, and then we'll have all of these different methods for loading, saving, clearing, adding an item, and removing an item from the list. If you're up to the full challenge, this is a great place to pause and go ahead and create the class or the parts of it that you know how to, and then we'll come back and compare to my solution. Okay, I'm back. Let's begin creating this class, and you compare your work to my solution. I'm going to have a constructor, and then this constructor is going to receive a private underscore list. Remember the underscores from when we created our list item. And this list is going to be an array of list items. And we're going to have a default value of an empty array. After that, we need to once again put the curly braces, but we do not need to put anything inside of them. Now, besides this, I'm going to put private in front of the constructor because I'm going to create a singleton, and that means there will only be one instance of this class created, and we'll keep referring to that instance because we'll only have one list in our application. So to do that, I put private in front of the constructor. Then I'm going to say static, and then I'm going to call this the instance, and it will be a full list, and we need to refer to the class name when this is static. So we'll have full list, and this is going to equal a new full list. So we're instantiating this right here, and we'll always be able to refer to that as the instance of our class. Now, I know I didn't mention that before, so if you didn't have that in your solution, it's okay. It's just something that we can do because we know we're only going to have one list for our application. Okay, underneath this, let's go ahead and create the getter for the list. So we'll say get list, and now we'll put the operators, and after that, this will be an array of list items. And then we'll say inside of this getter, we'll just have return this dot underscore list. Now, if we refer back to our interface, we can see we need to create load, save, clear list, add item, and remove item methods for our class. So I'm going to skip to save, and we'll go down the list and come back to load because it's the largest method. It has a little more logic in it. So let's make the easier ones first. So we'll start off with the save method, and it returns void. And then inside of the save method, we'll say local storage, which is where we're going to save our list so it persists even if we refresh the page. We'll say set item. Let's just call this my list. And then we'll say JSON.stringify, and we'll stringify this _list. And that will save the list to our local storage. So then we can later on load it with our load method when we come back and create that. Next, let's create the clear list method. And this is also going to return void. And then we'll say this _list is equal to an empty array. So that will clear out the list. And then we'll call another method, this.save. So we'll make sure we're writing over anything we have in local storage as well, so the old list items don't reload, because we wanted to clear those. Now I'm going to scroll up for a little more room, and underneath clear list, let's create our add item method, which is going to receive an item object, which will be a list item as we've imported above, so we can use that. And then we'll say this _list.push, and we'll push in the item object that we receive. And after that, we'll just say this.save once again, so we have saved our list with the new item added. After that, let's create the remove item. So once again, spell remove item correctly. It will receive an ID, which is a string, and it will return void as well. And then inside of our remove item method, we'll say this _list equals this _list.filter, and we'll filter the items in the list. And then we'll have an item.id, and we'll keep everything that does not equal the ID that we receive in this method. And then we'll call this .save once again. So after we have removed that item, we'll save the list. Let's now scroll back up, and we'll create our load method here right above the save method. So we'll start off with load, and after that, it will return void. Now we have several steps to take inside of this method. So I'll start it here at the top. First, let's start by defining our stored list, and this will be a union type of either string, or it could possibly be null. We'll set that equal to local storage.get item, and remember we named our list my list in the local storage. So that's what we need to retrieve. Now let's put in a type guard. So we'll say if type of stored list is not equal to string, which is what we expect to get from the local storage, because remember we stringify it right here. If that is the case, then we're just going to return, because we do not want to go any further if it's not what we expected. Otherwise, let's define a parsed list, because we are going to parse it. Now this needs its own type defined right here. And this is because, remember, we're using the underscores, and that's what will be saved. If we go back to our list item and look at our interface here, it doesn't have the underscores here, so we couldn't export item and use that. So we'll just create a type that looks a lot like it, except it will have the underscores. So here I'm going to put a curly brace and have an underscore ID, which is a string, and then have an underscore item, which is a string. And then we'll also have an underscore checked, which is a Boolean. And now we needed to provide that type, and this will also be inside of an array. And we'll set this equal to JSON.parse, and we're going to parse the stored list that we retrieved above. Now I'm looking at, why do I have this extra curly brace right here? Oh, it's from the load. I just want to put that down on an extra line. Let me go ahead and save so we get some formatting here. So we've got parsed list defined, and here we're providing the type, which is essentially like our item type, except they have the underscores. And after that, we're saying, hey, that's going to be an array of that type of object, and then we'll have JSON parse here to get the stored list, because that's what we should have retrieved from our local storage. So now let's use that parsed list. So we'll say parsed list, and then we'll call for each. And this will be for each item object in the array. And now we've got a few lines here. So I'll say const, and now we'll have new list item is going to equal new list item, and here is where we pass in everything that the list item receives when it's created. So we have our item object dot underscore ID, item object, once again, dot underscore item, and finally item object dot underscore checked. And I need to press Alt Z to get this code to wrap correctly. Okay, once we have created our new item, let's now use our full list dot instance. And notice I'm referring to it as full list because we used static up here when we created this. So I'm referring to our instance of the list. I'm going to say full list dot instance and then dot add item. So I'm calling the method and I'm passing in the new list item. And after that, our item should be added. So we've retrieved everything from local storage if it's there. Then we have created new items from that parsed list. And now it looks like I could add some formatting here. I knew something didn't look quite right. Save that again. And then we're going through that parsed list and we're creating a new list item for each one that was stringified and saved into local storage, and we're populating our list again. So that is what the load method is. Okay, congratulations. We have completed our model. We've created a list item class and a full list class that is a singleton, and we have populated them with data and methods as needed. Now we're ready to move on to our templates. So we'll only have one, but I'm going to create a directory, and I don't want it inside the model directory. I want it inside the source directory. So I'll create a directory here named templates. And inside the templates directory, we'll create one file, and this is going to be named list template.ts. We'll start our list template by importing our full list. So we'll say import full list, and it comes from the model full list. After that, let's create an interface, and this will be called DOM list. Inside this interface, we'll have a UL, and this will be an HTML uList element, as we see there, so an unordered list element. After that, this will have two methods. One will be clear, which will clear out the list. That will return void. And the other will be render. And render will receive our full list. And we'll just name that full list with camel case, but it will be the full list type. There we go. And it will also return void. So this is once again a good place for me to stop. You can go ahead and create a class named list template, make it the export default, make it implement the DOM list interface, make it a singleton, so we only need this one template for the entire app. We created a singleton with our full list class as well. And then remember, the clear method should just clear out all of the HTML inside of the unordered list, and the render method should render the full list. And if you want a guide for how to render that list, you can look at the HTML, and inside the HTML, remember, I commented out those list items, and this is what the render method actually needs to create, is a list item element for every item that is added to the list. So you could compare that. So I'm going to stop now and I'll come back and we can compare notes. Okay, I'm back. I hope you did well. Let's go ahead and create this template. We'll say export default class, and this is our list template, and it implements our DOM list interface that we created above. Now inside of this, we'll go ahead and have another constructor, and this will also be a private constructor. As I said, this is going to be a singleton too. And now inside this constructor, we'll go ahead and say this.ul equals document.getElementById, and the ID is list items that we should be able to see over in the DOM. And now we can go ahead and use an assertion here and say as HTML uList element. There we go. So after we have done that, let's go ahead and make sure we got the right ID for list items, because you would have had to have looked inside of the index.html to see what I named that unordered list, and it does have the ID of list items. Okay, back in our list template, you can see TypeScript doesn't like this. We did not pass this in as a parameter. We absolutely assigned it here inside of the constructor. So when I mouse over, it's going to say UL does not exist on type list template. So we also need to put that above since we did not pass this in as a parameter. And we can say UL is going to be a type U list element. There we go. After we've done that, we need to create our methods. Now, I think I'll scroll for a little room. The clear method should be fairly short, but the other method, render, will be fairly long. So we'll have our clear method, and it returns void. Inside this, we'll say this.ul.innerHTML, and just set it to an empty string, and that will clear everything out. So that clears out the list on the DOM. We do not need to save that to local storage. It's not data, it's just the display. So that's what this template is about. Now for our render method. It's going to receive the full list, which is the full list type from our class. We can use that as a type. So now we'll have returns void, and we need to handle everything inside of here. So the first thing we're going to do before we render the list is clear what we already have so we don't duplicate the list. After that, we'll say full list dot list, which I know is a little strange, but it does have that list data inside of our full list instance. And then we'll say dot for each, and this would be for each item. Now we need to go through each item in our full list and create a list element and everything else about that list element. So let's look back here inside of our HTML where we had commented this out, and you can see we have the list item, or list item element, I should say, and it has a class of item. And then inside of it, it has an input type, which is a checkbox. And it gets assigned an ID and a tab index. There's also a label for, it's linked, of course, with the for to the checkbox, which has an ID of 1. So for says 1 here. It has the description inside of the label as well. So we need to create all of that for each one of these. So let's scroll this up so we have some more room to work with. And we'll start out in our for each loop by creating the list item itself as the parent element. So I'll say const li is going to equal document.create element, and we're going to create an li element. And then we can use an assertion as HTML li element. After that, we'll say li.className. This is going to equal item. So there we're complete with the list item element itself, the parent, but now we need to take care of everything that was inside of it. So let's do the checkbox first. We'll say const check equals document.create element, and this will be an input element. And then we'll say as HTML input element. There we go. And after that, I'll press return, and now we can assign some of the attributes to it. So we'll have check.type equals checkbox. We'll have check.id equals the item ID. So each check ID is unique. After that, we'll have check.tab index. This will all be the same for each one. We'll have check.checked equal to item.checked. Remember, that's a Boolean. And then we'll have li.append, and we pass in the check. So we are appending our checkbox to the list item. Now you might be wondering here, as I referred to item.id and item.checked, why I didn't refer to the underscore. That's because I'm using the getters and setters here. When I refer to item ID, I'm using the getter to get that item ID. Same with item.checked. Now, while we've appended the checkbox to the list item, we didn't put an event listener on there yet, so we also need to do that. So we'll say check.add event listener, and we're going to listen for the change event. After that, we'll have our anonymous function, and when this is changed, we'll say item.checked is going to equal the opposite of item.checked. list.checked. And then we'll say full list, and we'll call the save method so we update our list, including what is saved into our local storage. Okay, I'll scroll for some more room, and now we need to create the label, which holds the description for each item. So we'll say const label. This will be equal to document.create element, and then we'll create a label, and we'll say as HTML label element. After that, let's go ahead and use that label. So we'll say label.html4, and this will be equal to the item.id, and then we'll have label.textContent, and we'll set this equal to item.item. If you remember, item is what holds the description. And then we'll say li.append the label. So we'll now attach the label to the list item as well. Now, if I remember correctly, let me look back in the HTML. I actually didn't have the button in here. I have the checkbox and the label. I didn't put the button in the sample here for the deletion. So if we wanted to delete an item, but we do have a delete button now in the demo. So let's go ahead and create that as well. No points off for you if you left it out because I didn't show it in the example there inside of the HTML. So let's create this button now though. So we'll say const button would equal document.create element, and this will be a button element, and we'll say as HTML button element. And I'm going to press Alt-Z so this can wrap down as well. After we've created that, let's say button dot class name, and we'll set this equal to button, as there is a button class in the CSS. Say button dot text content. We can spell content is going to equal a capital X, and then we'll just append this to the list as well. I typed the li there. This needs to be button. There we go. After we do that, this button also needs an add event listener. So we'll say button.add event listener. We're listening now for a click event. There we go. And this anonymous function will handle several things. So we'll say full list is going to remove item. We'll call that method. Pass in the item.id. We'll also say full list.save after we do that. But if I remember right, the remove item does that, doesn't it? So let's go back and look at our full list method for remove item. After we remove the item, it calls save right there. So we actually don't need that here. So we can remove that. So we remove the item. It will be saved with the remove item method as well. And then we'll call this.render, and we'll pass in the full list. So yes, we're in the render method, and we'll actually call the render method with this. It doesn't create this endless loop though, because this is an add event listener. It doesn't happen until that button is clicked. And then we remove the item from the data, and then we render the list without the item. So that's all there is to it. So we're almost finished. We've created all of this, including that list item, and we need to scroll back up and we see the full list here. This is full list.list.for each item. And as we go through, we create the list item, but it also needs to be added to the unordered list, which is the parent of the entire list. So now we'll say this.ul.append, and we'll pass in that li parent that we created. And now we've created our template. We are finished, and this should also be a singleton. So there should only be this one instance of this, and I don't believe we set that above as well. So let's do that. We put private on the constructor, but we need to say static instance, then we'll say list template, which is the type. We'll set this equal to a new list template right here. So now we have made this a singleton by the instance. And when we refer to these singletons, it would be like list template.instance. That would be the instance of the list template. With all of our classes complete, we're now ready to pull our app together inside of the main.ts file. So besides importing the CSS, we need to import everything we've just created. So we'll say import full list, and that comes from model full list. After that, let's import list item, and that comes from model list item. And then let's import our list template, which comes from templates, and then list template. Now let's create an init app function. So const init app, and this is just going to be a function that is void as well. And inside of this function is where we will add event listeners and do everything else that we need to fire up our app. However, to start this, we need to put this underneath our definition, and we say document.add event listener. So we're adding a listener to the document itself, and we're listening for the DOM content loaded event. And when that happens, we'll call init app. Now, I know we can defer inside of the script tag of JavaScript as well. I've just been in the habit of doing this for a long time, and this essentially says we're not going to run our JavaScript until this DOM content is loaded. We make sure those elements exist before we try to interact with them. And now inside our init app function, let's start by getting the instances that we have created for the full list and the list template. So we'll say const full list equals our full list dot instance, and that is our singleton. And we'll also say const template, and this is going to equal our list template dot instance as well. After that, let's go ahead and get our form, because we need to listen for the submit event. So we'll say const, and I'm going to say this is the item entry form. This is going to be equal to document.get element by ID, and I also named the ID item entry form. And now we'll say as HTML form, not controls collection. I just need HTML form element. There we go. And I'll press enter. I'm going to press Alt Z, so that wraps down as well. And after that, we need to go ahead and add an event listener to this form. So I'm going to say item entry form dot add event listener. I'm going to listen for the submit event. This will receive an event, and we can define here, you could use inference, of course, but we can just spell it out that it is a submit event, which you would think you could tell from that as well, but we might as well do it. After that, we'll just say void, and inside of this function is where we'll do several things when a new item is submitted to the form. The first one we'll do, so we might as well put here, is prevent default, so the form doesn't reload the page, because that would be the default behavior. I'm not going to do the rest for this listener right now, so we'll come back to that. Now let's go ahead and add a listener to that clear items button that we also have. So I'll say const clear items equals document.get element by ID. And this is our clear items button, I believe is what I named, and we could look back in the index.html for that as well. So here's the clear, it is the clear items button. Just to confirm, okay, back inside of our main.ts, it's the clear items button, and then we'll say as HTML button element. I'm going to scroll for some more room, and now we'll have our event listener, clear items dot add event listener, and now we're listening for a click on that button. Then we'll call this function that is void, and inside of this function we'll have the full list dot clear list method called. So we'll clear that out when the clear button is pressed. Then we'll also, that's the data we've cleared out, we'll also clear the display, which is our template. So we'll call clear there as well. Now remember, these are both listeners, the submit and the clear items buttons, so they do not happen right away. But what does happen right away is loading the list. So we need to call full list.load in this init app function, and then we also need to call template.render, and we pass in the full list. And this is where we can see TypeScript is helping us out. For example, if we don't pass in the full list here and we mouse over, it says we have a problem because an argument for full list was not provided. So after we have defined those properly in our classes, they guide us through the rest of our app. So now to complete our app, we just need to create this item entry form submit event here and the handler. I guess we need to create the handler actually that will submit that new event. So what we're going to do now is get that new item. So let's confirm our input name. And that was up here above where we have the new item entry. And inside of here, we have the input. So it was a new item entry input, but the ID is just new item right there. So that's what we're going to grab. So inside of our event handler, I'm going to say const input, set this equal to document.getElementById. Press the wrong key again. There we go. Get element by ID. And this would be the new item. And after that, we can say as HTML input element. And after we have grabbed the input element, we'll say const new entry text. This is going to be a string. We're going to set it equal to the input dot value and then call trim on that so we can trim away any white space that may be there. And then we'll also say if there is no new entry text after that white space is trimmed, let's go ahead and check the length here. If there is no new entry text, we're just going to return. So we're not adding empty items to our list. Now we also need to calculate the item ID. So to do that, we can't just choose the length because what if we deleted an item in the middle and then our list gets shorter, but the numbers are still higher? What we need to do is grab the last item in the list, which should have the highest number, and calculate whatever is one more than that. So we're going to say const item ID, which is a number. This will be equal to the full list dot list, once again, dot length. And now let's go ahead and use a ternary statement to finish this out. So if we have a number there, if it does exist, essentially we're going to parse int, get the full list dot list. Now we're getting the length, essentially the last item. So I'm going to say full list dot length -1. And notice how I'm using the brackets, so I'm accessing that element of the array. And then I'm going to say .id to get that specific value from that item object. And now I also need to say +1. But if it doesn't exist, we're just going to make it item number 1. So that's how we'll calculate that. After we have the item ID, we'll say const new item. This is going to be equal to a new list item that is created. So we need to pass in the item ID, then say toString, call the toString method, because they should be strings, and we did have a number before when we were calculating that. And we'll also have the new entry text. And remember, there was a checked value, but it's not required. We had default values there inside of the constructor back here in the list item. So we don't have to pass in that checked value. We do need an ID and a string because we'd prefer not to, or an ID and an item because we'd prefer not to have those empty strings that we provided there. Okay, so we pass in the ID and that item description. After that, we need to add the item to the list. So we'll say full list dot add item, and we'll pass in our new item that was created. And then we need to render the list after we add that item. So we'll say template.render. We'll pass in that full list once again. And now we should be complete. So just to review, we start with our init app function, and we get the instance of the full list and the list template. We put a listener on our item form when a new item is added. That's the submit event. And that's what we just completed there. We also have the clear items button, and we have a listener for that when it's clicked. And of course, also inside of our init app function, we need to load the list and render the list at the beginning when the app is first launched. So that is completed now. Congratulations, we've worked all the way through it. Let's cross our fingers and see if it all works. And if you remember in the package.json, we have dev here, which we can run. So let's just do npm run dev. We'll control and backtick. And let's see if it's going to work. It looks like it's on localhost 5173. I will control click, and we've launched our application. Let's go ahead and add something like buy milk, and it adds to our list. Let's add something else. So I'll just say, hey, and we've got something else added to the list. Can we check it? Yes, it applies those correctly. Can we delete something from the list? Yes, we can. Let's add something else. One more hey, maybe. Now let's clear the entire list. That also works. Does our button work as well if we say hey and we click over here to add? It also works because it also submits the form up above. So everything is working as expected. And I should add one more list item, and that is congratulations on completing the full TypeScript project. You've already completed the basics of TypeScript and applied them to a project. Now in the remaining chapters of this course, you'll learn how to apply TypeScript in React and complete another project with the skills you learn. And as you might guess, a prerequisite for this part of the course is to already know the fundamentals of React. But no worries if you don't. I have a React course for beginners that I will link to in the course resources. You will definitely want to know the basics of React before going forward here. With that said, let's keep moving with Chapter 12. I've got Visual Studio Code open, and you can see I'm in my TypeScript series folder with all of the lessons over here to the left. I'm going to open up a terminal with control and the backtick. Then I'm going to type npm create Vite at latest. And we're going to create a React and TypeScript project. I'm going to go ahead and extend the terminal window up to the full size. I'm going to call this lesson 11 just to fit in with my other lessons. You can call it whatever you want. I mean lesson 12. I already had lesson 11. There we go. Lesson 12. Going to arrow down and choose React, and then choose TypeScript, and Vite quickly creates this project. Now we need to go ahead and get into the lesson 12 directory. So I'm going to cd lesson 12, then I'm going to type npm I just to install everything. And we can type npm run dev if we want to as soon as this installs. However, I'm going to change folders first. So I'll get out of this TypeScript series folder and directly into the folder for lesson 12. So now I'm just going to open this back up, go into my TypeScript series, choose the lesson 12 folder, and open that up so there's no confusion and we only see what this project has over here to the left. So now let's go ahead and control backtick once again, and we can type npm run dev and go ahead and launch that project. It will give us our local host at port 5173. Control click should open that up, and here it is. It's running over here in Chrome to the right, and now we can just change that code as we want to. So I'll come back to Visual Studio Code for now, close the terminal, it will keep running, and we can start in on our project. So let's look at the source directory, and we can see a few things here and probably some things we won't need. So let's go ahead and open up the app TSX. Notice all of the files that we'll be using have this TSX extension instead of a JS or JSX extension. So we can just remove everything that we're essentially seeing here. So we'll remove the imports in the app. Let's remove this use state, and I'm going to remove everything it returns essentially here as well. And instead, we could just return anything we want to, say an H1, say hello for now, just so it has something there. Besides that, we don't need the rest. We can delete the app.css file, but there's not as much cleanup here with Vite as there would be with Create React App, so it's not too bad. We've got the main TSX, and we can just leave this the way it is. The index.css is something I'm just going to select all and paste in some very basic CSS. You can pretty much see it all here. We've got the reset at the top. I added just a little padding to all elements, and then just a few things here. You can get this from all of the source code that is linked to in the description for the course resources. I'll just save this, and of course this isn't necessary to apply what we're going to today. And so React is all about components. So let's just look at the easiest way to define a function component. And I'm going to create a new directory over here called components, so we can put all of the components that we create inside of this directory today. And with the new file, I'm just going to create heading.tsx. Now inside of this file, I'm using React ES7 snippets as an extension, so I can type RAFCE, press tab, and quickly get a functional component definition. But we're going to make some changes here. So first of all, let's talk about the types of props that we would pass in. And for a cleaner look, although you can inline everything, and we'll look at that too, it might be easier to just define a type above, and we'll call this heading props. Now I'll set this equal to a title that we would pass in, and this would be a string. So now we've defined our heading props, so as you might guess, our heading will receive a title, and as normal, we would destructure that from the props. After that, we could just put the heading props right here. Now as we look at this, this is fairly clean. If you didn't do that, you would take this and you would just inline it. So if we put it here, this looks a little repetitive, doesn't it? At the same time, this is what you're doing with heading props. So I'm going to undo that because I like the look of defining a type first and then bringing it down here. And then let's just change the return here instead of this div with a heading, and we're just going to return an element, an H1, and it's going to have the title inside. Now this is a good time to bring up the return of a functional component. Usually it's a JSX element, and that's what we would expect. As I mouse over heading right now, you can see IntelliSense tells us it is a JSX dot element, has the JSX namespace, and that is typical. However, if you're just returning an element like this, you can be a little more specific. So here we could say this is a React element, and let's see if I can just pick that out of the menu, and it automatically imports at the top of the file. So I'm being a little more specific because I'm only returning an element right here. But it is normal to just let React infer, or let TypeScript infer, that it is a JSX element from React. And we can see this back in the app.tsx. As I mouse over app, you can see it infers that it is a JSX.element. You don't have to put that here explicitly. That is typical. That's what everybody expects. So only if you're changing something like I did to a React element would you switch that. So let's go to our app.tsx file and let's import our heading now. So we'll import heading, and that comes from components heading. And then let's use it here in our return instead of the hello. So just beneath this, I'll go ahead and put parentheses, as we'll put some more components in later, but we'll put in the heading that we just imported. And see, TypeScript doesn't like that because it knows that a title is required. So we need to pass in some type of title that should be a string. So we'll say title, and now inside of title, we can just say hello. Oops, I need a curly brace. There we go. And when we save, now TypeScript's okay with that. So let's go ahead and take a look at our page and see if Vite has updated it. And yes, we've got a big hello on our page now from our heading that we created here. I'll hide the file tree so we can see more of that. Also Alt-Z to wrap the code. Now we can see everything. And we've got our basic component. It is imported into the app.tsx, and we've got hello showing on the page, or whatever we would pass in as a string to the title prop. I'm going to drag this back to full screen for now, and I'll show the file tree again with Control B, but I'm going to create another component, and I'm going to name this section.tsx. Now there have been a lot of changes as we move to React 18, and some things that were previously done with TypeScript are no longer the case or not advised at this point. And I want to show some of that just because you'll see some other older tutorials or older legacy code, and maybe even inherit a legacy code base somewhere at work or wherever that uses some of these older things. And you need to know, of course, that you can move them to the newer way of doing things. So first, let's define this section the old way. So I'll have import React from React. And after that import, I'm going to say const section. And then this is something you would see in the past, React-functional component, or the alias, which is more likely because it's shorter, just FC here. So React, let me see, .fc, there it is. And then we would have our arrow, and then inside of this, we'd have our type, like title string, just like that. And of course, the closing arrow after the curly brace. And then we'd say that equals, And here we could provide, inside of curly braces, again, because we're destructuring, we could provide children and the title. Now that's something else to note that we'll get to in a second. But then inside the function itself, let's say we'll return, we'll have a parentheses, we'll have our section element. Inside the section element, let me give an H2, put the title inside of that. And then underneath that, let's use the children as well. Now we'll talk more about children here in a second, but we'll put children in here. This is something you would see kind of the old way of doing things. Now I don't have an export here either, so I could either say export right here, or I could have my export default at the bottom. Either way, but I'll save that for now. And this is what we would see, Alt-Z again to wrap that down. And notice TypeScript has a problem with some of this already, but we wouldn't be using this React.fc or React function component here the way things are recommended to be now. So I will change this and show you the way things should be now. And likewise, the children issue here is something else that I want to cover just after that. So like we previously did with the heading, where we defined a type here at the top, let's do that with our section to clean things up just a little bit. So I'm going to have type, and I'll say section props. I'll set this equal to an object, and I'll have a title here, and I'm going to make this optional with the question mark as well, and we'll come back to that. And then we also have the children, and notice how I'm defining what type the children should be right now, and I'm going to say React node, and that comes from React, so it imports at the top as well. Now in the past, you could do what we saw below without this explicit definition of the type. And that was an implicit definition of children. You could do that before React 18. You can't do that now. So you need to switch that. And children is different than props. If you're not familiar with the exact difference, children would be something we would put in between, like we would type in between the H2 or the paragraph. And I'll show you how that works as we pass it down. Okay, I'm just going to delete the React.fc and the type there. That's not the way to do things anymore. So we'll remove that. Now we'll have section equals, and we've got children and title being destructured here, and that's fine. Now we need to use our section props type right here. So section props. And now that we've provided that, we're pretty much good to go. Now we did make this optional, so we can provide a default value for the title, and I'll just say my subheading here. Now that is different than default props. So in the past, if you've worked with React and say you've had this section component, and then you would say section.default props and set that equal to something, you could do that, but that is being deprecated as we speak. We're on React 18.2 right now, if I believe. Let me look at the package JSON. Yes, React 18.2. I believe in 18.3 it is deprecated, the one that's coming right up. So we don't want to do the default props anymore. You just want to provide any default value right here, just like you would be passing it in after you destructure. So that's my default value for title if title is not provided. And we need to do that because I made title optional up above. So now we've changed everything to the current modern way of doing things. I can just remove the React from the import at the top. We just need the React node for the children, which that's what the children should be, is React node. And if I mouse over that and we look at the type, that's pretty wide open. The children can be lots of things: string, number, Boolean, a React element, a React fragment, React portal, null, undefined, I'm sorry. So lots of options there for React node. And that's good for the React children because you're not sure exactly what would be put in there. So let's save this and let's go back to our app.tsx and let's import this. So we'll say import section, and that comes from our component section. After that, we can use it in the body, so I'll put it underneath the heading. I'm going to have a section here. And now let's put something in for the children. Right now, you can see TypeScript still doesn't like this. And if I mouse over, it's expecting some things that we do not currently have. So, oh, and it says we need a parent element as well. So I should put in at least a React fragment here. So I'll wrap that. And I'll save, and now we get the error just for the section. Let's see what it says. Property children is missing. The title was optional, so we didn't have to have that, but we do have to have children. Children are something we don't pass as a prop, like we'll have title equals something inside of this section, but the children go between the opening and closing tags. So here we could just put in a string or something else like that. So we can just put, this is my section. Fair enough. I don't know what else to put. And now this should work. Let's drag this over. And we've got my subheading, and this is my section. Now, where does my subheading come from? That comes from the default value we have for title, since we didn't pass a prop down. But we can pass a prop. So if we come back and we give a title here for the section, and here I'll just say different title, save. Here you can see we now have a different title because we're passing it in, and it uses that instead of the default that we provided here in the section. I'm going to drag VS Code back to the full screen, and now let's look at the file tree one more time and make another component. I'll just call this one counter, as we'll make a simple counter to start out, and then we'll make some changes. So this will just import, and then we'll use state. So we'll look at how the use state hook works. And then inside of the component, here I can just do an RAFCE once again for counter. And then we'll use the state here at the very top. So we'll say const, and we'll have a count and a set count. And now let's look at how we can use this with TypeScript. So we'll say use state, and then I'm going to use a number. So I'll provide the number here inside of the arrows, and then I'll just provide a 1. Now this can vary. So say you're using some state that doesn't have a value at first. You have a null value. Then you would need a union here. So you could put this or null, or if you needed undefined or whatever else you might put. So say you were starting with null here, for example. But normally, if we just put the 1 here, we wouldn't even really need to put the number if we didn't want to, because this could be inferred as well. So you could easily see it without. If I mouse over count now, you'll see count is a number up here. It's already inferred by TypeScript. But if we want to be explicit, we can put the number in here. Now I'll quickly create the rest of this counter component, as it's a basic component, and then we'll modify it. So first we'll start out with an H1, and inside of this I'm just going to put count is, and we'll put the count. After that, we need a couple of buttons just to increment and decrement the count. So I'll say button, and now we'll have a button with an onClick. And this onClick is going to have an anonymous function. And then it is going to set the count, and we'll use the previous. We'll say previous plus 1. And so this is the increment function. Let's put a plus right there. And I'm just going to Shift Alt and the down arrow to copy this down, and I'll put a negative sign here, a minus sign, and do the same inside of our set count. So that is our decrement. So we can increase the count or decrease it. And this is our basic component right here. Yeah, nothing new really. We just learned about use state, but we will make some changes just as an example so you can see how it would work with some changes. But first, let's just import this now and make sure it's working as expected here. So we'll say import, and then we'll have counter, and it comes from components counter. And now let's put the counter below. So we'll just say counter, and there were no props. So let's save, and it should work as we expect it to. I'll drag this over. We have our count. The increment button works. The decrement button works. So not a lot new there, just the use state hook. However, let's go back and make some changes. First, let's pull this state into the parent, into our app.tsx. And this is just an example, so it's nothing I would probably really do. I'm just looking for a simple example to show passing down some of the state that we would use, including the set count function. So I want to go back here into the app.tsx, and I'm going to import use state. That comes from React. After that, I'm going to use the state here inside of the app.tsx. And now our counter is going to be different. So instead of just having the counter here with no props, we're going to pass down the set count function. So set count will equal set count. And after that, we can say count is, and provide the count right here. Now, since this is between the opening and closing, this is the children area right here. That's how that will be defined. And you can see right now, TypeScript doesn't like what we have because we haven't modified all of our counter component yet. So let's go ahead and save this and go back to the counter component. Inside the counter component, I'm going to define a type first. So I'll say type, and I'll say simple. Let me just say counter instead of simple counter. I'll say simple counter props. And I'll set this equal to an object, and it will have set count, and we don't know what type that is yet, do we? So let's go back to the app.tsx, and if we mouse over, we can see some IntelliSense here. It gives us a really long type, but this is the React type that we need, so we can just highlight and copy that, go back into our counter. That is the set count function type. After that, we'll say children, and then we'll say that is a React node. Then we need to import the React node if it didn't automatically happen for me at least. So I'll say import React node. That will come from React. So now we can use that. And now we need to receive those props here inside of the component. So we'll have set count, and we'll also have the children that we need to explicitly define now. Remember, we can no longer have implicitly defined children after React 18. So here we'll provide the type, and we've already created it above, so it is counter props. But we still need to change something in our component. Notice we have a line here. We're not passing down the count, we're passing down the children. And so we already provided that statement above or in the parent component. So now we'll just say children right here. And I'll save that. And so if we refresh our memory here, we go back and we look at our counter, and the children were right here. Count is, and it provides the count, and we're passing down set count. So when we look at this, we've got set count and the children as props. Here's their type that we defined above, and all should still be working. So let's drag this over to the left, and let's take a look. Our counter is still working. So I just wanted to give this example, although I wouldn't do this with a counter. This is something that shows you how set state, any type of set state function that you would use with useState, could be passed down, and how you can use the children as well instead of possibly passing down the actual state. Okay, one more example today, and let's look at generics. And something we often do in React is render a list of items. So let's create a component that is very generic that we can pass in any items to, and it will render that list of items. So let's start out by saying import, and we'll be using React node once again. So this will come from React. And then once we've done that, let's create an interface. And we can use generics with an interface. So let's call this list props. And now I'll have my placeholder here, my generic, and I'll just indicate that with a T. You could create whatever you wanted, or use list item, or you could say item, or whatever you wanted as that placeholder, but T is kind of the standard. Then I'm just going to have items, and this will be an array of items. So I'll have my T there, and then the array to indicate that. And then we're going to have a render function. This will render that list of items. So this anonymous function will receive an item, and of course that's going to be type T. And then inside of here, we'll just have that React node that I imported. And so we don't know exactly what that is, but remember, as I mouse over, React node has a lot of possibilities. So that's a good one to choose there. String number Boolean, React element, and so on. And now I'll just come below this, and I'm going to use that RAFCE shortcut once again and quickly create that list component. But we need to make some changes here, of course. One thing is it's going to have that generic. So I'll put a T here, and it put a closing T right away because it's not sure what we're trying to do. And this is something that's a little strange, and I'll come back to fix that here in just a moment. I want to put the rest in first. So we're going to have the list items, and we'll have the render method as well. And that switched to something I didn't want. I want items. So we've got items and the render method being passed in, and we're going to have that list props here that we created above. And then it is going to receive that generic as well, which once again it didn't recognize, and I'll explain why here in just a moment. Get that back in there, and put that back to delete it one more time. There we go. So now we've got that, and we've got our function here. Let's go ahead and create the body of the function, and I'll come back to why that generic is not being recognized. So inside this body of the function, we're going to have an unordered list. In the unordered list, we're going to map over the items that we receive. Why it keeps changing that as well, I don't know. So items, please, and then map. And then inside of this, we'll have an item and an index. I'll just indicate that with the I. Put a parentheses, and now we're ready for our list item, and it's going to have a key, so I will need to add that, and that will be the index. So now we're mapping over each one, and we use that index as the key that React needs. And then here inside of the list item, we can just call our render function and render each item. Okay, so right now we do have some issues with TypeScript. It doesn't like anything we're doing. So when we provide a generic here and we're using a const like this and then an anonymous function, it has a hard time recognizing this generic. And there's a couple of solutions. One, you can put extends and put an empty object here. Notice all the problems went away. This just helps TypeScript recognize that this is a generic. But an easier way to do this is to just put a comma after that. And then, once again, all the problems went away. Everything looks just fine. And I just noticed that we imported render up here, which was not intentional. That happened automatically, and we don't need that. So now with our generic component in place, let's go ahead and use it inside of the app.tsx. So we'll start out by importing it here. Import list from our components directory. And after we have that, underneath our counter, we'll just start out with list. I need a capital L there. And then we need to set the items. So the items are going to equal, and I'm going to paste in an array here, and we can just look. It's very simple. I just have an item there. I need items. There we go. And it has coffee, tacos, and code, some of my favorite things. After that, let's go ahead and create that render function that we're passing down. So render, and this will equal, once again, with our curly braces. Then we can have our anonymous function, and it will receive an item, which is going to be of type string. And then from there, we'll put our arrow. And here we can render whatever we want to. If we wanted a paragraph, if we wanted a div, if we wanted a heading, whatever we want to display these list items. So I'm going to use something very generic along with our generic component, and that is a span element. Well, I guess I need to go ahead and type it all out, and then I'll put a class name, and we can change the appearance, of course, if we change classes. And I'll set this class name equal to gold to start off with, and then we'll just put the item inside of that. And so now we can save this, and we'll see how everything renders. Oh, and I'm missing the closing part of our list. And now everything should be good, and let's take a look at how it renders on the page. We have gold words here, coffee, tacos, and code, and we have rendered our list. Now, if I just come back and let me go into the CSS, we can see I have a bold class and a gold class. So let's switch that in our app.tsx, and I'll bring this back over so we can see it better. Let's switch gold to bold and see if that appearance changes. Yes, now we have bold words instead of gold words. So that's a great way to create a generic component. And of course, you might see that accomplished with the function word as well. I'll come back here to the list. So you might see function list, and you might see this accomplished differently. This is how I typically write out my functional components, though, is with this anonymous function. And I thought it was important to show you how to get around that problem that seems to come up when TypeScript doesn't recognize the generic there as well. So for the next tutorial, I'd really like to go over more of the React hooks as well as you continue diving into React and TypeScript. I've already started up a new React and TypeScript project with Vite, and for this tutorial, I'm assuming you're already familiar with some common React hooks that I'll be covering, but should also be a bit of a review. And if you need more info on any of the React hooks, I'm going to include links to the tutorials I have for each hook in the description below. Okay, let's start out here in our app component, and let's bring in useState, which may be the most frequently used hook of all. So we'll have useState. And that comes from, if I could spell from, I'm already issuing some typos here. Comes from React. After that, let's go ahead and apply useState. So let's just do our typical count at first. So we'll have count and set count, and we'll set this equal to useState, and we'll just start with a 0. We don't see any complaints from TypeScript at all, do we? That's because you can just leave it this way. It uses inference. Instantly, it knows that count is going to be a number, and we can see that through the IntelliSense. However, we can be explicit if we want to. So when we're providing a number or a Boolean or a primitive like a string, we could just put it here inside of our arrows and say that, yes, it is definitely going to be a number. Or what if we were waiting on some data and it might be null as well? And if that was the case, we might put in a union type and say this was null, and then we were waiting to get that data here like this. So we would have our beginning state as null, and then we could provide this union type. Or let me declare an interface here at the top. I'll create one, and I'm just going to paste this in quickly. It's an interface for a user, and it has an ID of number, and it has a username that is a string. So we could say this is going to be a user or null. Or what if this was going to be an array of users? So we might have an array of users here. Once again, this might be null before we would get that array, or maybe we would decide to just start out with an array and not have our null here. But you can see it pretty much works all the same way as you would expect. And it can infer a lot of this as well. But if we have an interface like this, it would be good to provide that. And of course, my example here is not matching up with count and set count. And I put in a user. But just to continue this example quickly, I want to show one other thing you may see that I don't necessarily recommend, but I want to show it because you may see it. And you may see an assertion. So it would have an object like this, because that user is an object as well, and then you could have as user. Now, you're essentially lying to the compiler when you do this, saying that, hey, we're going to have a user here, so view this as a user. You would only do this if you knew you were going to fill this state very quickly, or it could cause some errors. But I did want to show this assertion possibility because you may see that in some code. So for now, let's switch this back to a number as our example, just a basic one, and then here we'll have a 0 in here for the beginning state. And then I'm just going to copy this down for state and create that second state, which is user. I'm going to highlight count, press Control D to select the next count, and I'm going to type users. So I now have users and set users. And I've got a short on my channel that shows what extension I'm using that goes ahead and keeps that case preserved with the lowercase and the uppercase, if you want to check that out. But over here, then I'm going to switch this back to using the interface of user, and it's going to be an array of users. And then I'll put or null, and I'll start out with some null data. So it gives you examples of both. And now we can pull this into our example for the second hook I want to cover, which is useEffect. So let's bring that in at the top as well. Let's bring in our basic useEffect setup here. So we'll start with useEffect, and it has a function inside. After that, it's going to have a dependency array right here at the end. And now with our dependency array, we have a basic setup for useEffect. Now, useEffect is dealing with side effects, so it doesn't really return a value. And so when it comes to TypeScript, there's really nothing to do unless you're returning a value. And this also applies to the hook that is seldom used, useLayoutEffect, because they both have the same structure. So there's no real TypeScript application here, but let's go ahead and review the hook just a little bit, because this is going to run when the component mounts. So we could have console.log, and we could say mounting. And now with React 18, there's a change that some are not aware of yet, and that is when you use strict mode, which only applies to when you're in development mode. So when you're using strict mode, it mounts the component, and then it unmounts it, and then it remounts it again. So you're going to see this mounting behavior twice here. This console log should log twice because it's going to mount, unmount, and remount. Now, useEffect does return a cleanup function. And here in this return, we can just have an anonymous function that says console.log, and we could put unmounting, and you would see that once because it would mount, unmount, and then remount once again. So what is useEffect for? Again, side effects. And if you're not familiar with that concept, it's when something changes, you could have a side effect. Something else could happen. It's not necessarily going to return a value, but maybe you want to change something else. So for example, if our user state changed, we could then log something else to the console, which a console log is always a side effect. So we could put users in here in our dependency array, and then if the user state changed, then it would call this useEffect into action once again. This is going to, of course, run once when the component mounts, but after that, it would not happen again unless the user state changed. So here after that, we could just console.log, and we could say users, and then after that, let's just put a comma and log the user state, for example. So a very simple example. Again, really no TypeScript to apply because you're not returning a value. It's a side effect. Now let's look at the hook useCallback. So we'll bring this in at the top as well. Now that we've imported useCallback, let's talk about what it's used for before we apply it. useCallback will memoize a function, so it's not always recreated. And let's look at the JSX here inside of our app component. I'm just going to put an H1, and then let's put the count state that we have inside of that. But what if we had a button element as well? So let me go ahead and create a button here, and it might have an onClick. And this onClick could have a function in it. And sometimes, of course, I'll just put anything I want to here. Let's just put add for now. But sometimes the onClick is just created with an anonymous function. So we might have this and the arrow, and then we could say set count, and we'd set it equal to the previous, and then put our arrow here in previous +1. And that's fine, but this function is recreated every time. And while this isn't a big function and it's not a big deal, of course it would be passed down if we had button as a separate component. It would be passed down into that component. What we can do is take this function and name it up here and wrap it in useCallback, and then it will be memoized. And that can be handy. Some people do that all the time. Some say maybe not all the time, but do it some of the time. So let's go ahead and create one, and you can use it as you want to. I'm going to call this function add2. So we'll just add 2 to our count. And from there, we'll say useCallback. And it's just a normal function, so we'll have our anonymous function here. And then inside of our useCallback, we'll go ahead and say set count, and we'll put in our previous and have that be previous +1. And that's all fine. But useCallback also has a dependency array, like useEffect. And that means anything that the function would depend on, we would pass in. So if it had something else other than our count here, for example, we would go ahead and pass that in. But we're not going to need to do that because we're using the set count here, and React recognizes that. So we'll just leave this empty, and it will never have to recreate it after it creates it. The first time it will be memoized and saved into add2. And then instead of our anonymous function down here, we can just put our add2 function. And that's typically how you would use useCallback. Now, when it comes to TypeScript, let's look at add2 and see what IntelliSense tells us. It has a function signature. It is void, essentially, and it doesn't really have anything being passed in as a parameter or anything else either. So a very simple function signature. And you can use the inference for that and leave it like it is because, once again, you don't see a complaint from TypeScript. Or you can go ahead and put some of that here. So we could put void right here. And then we could also, let me leave a space here. We could also provide the event if we need it. Now notice, I don't need it inside of this function. But if I did, say I would put in E here, but now TypeScript gives us a warning. Now before React 18, this wouldn't happen. But now it's going to say E is declared, but its value is never read. And it also says parameter E implicitly as an any type. And that's the part I want to highlight. Before React 18, it wouldn't have said that. It would have just given it the any type. But now it's giving you that warning. So you could replace it with any here. However, we can be more specific as well. So again, I'm pointing out my simple function here doesn't really use the event, but let's get more specific just in case we were using that event. And here I can say, instead of any, let me say this is a mouse event, and that comes from React, so we can pick that right out of our IntelliSense menu, and it should have imported up here. And yes, we now have it at the top. But not just that, we can specifically say this is a mouse event for an HTML button element. There we go. And now we've provided a specific event. But of course, we know a button also could be pressed by the enter key. So let's go ahead and make this a union here. And now let's say this is also possibly a keyboard event that should also come from React here, and we should be able to get that in our IntelliSense menu. And I'm going to press Alt-Z so this wraps down to the next line. And once again, this comes from an HTML button element. There we go. So now we've specifically provided the event that could be a mouse event or a keyboard event. By the way, keyboard event should have also imported up here at the top, and it did. And it's based on this HTML button element, and we do have our button down here. But again, in my quick example, I'm not really using that event here. I just wanted to show you the possibility and also highlight the fact that if you do provide the event, you're going to get that warning in React 18 and above that says it implicitly has any applied, unless you tell it exactly what type of events you're looking for. Now, while useCallback memoizes a function, so it's not recreated, useMemo memoizes a value. So let me go ahead and bring useMemo in up here at the top as well. So I'll say, whoops, I need lowercase, useMemo. And after we bring that in from React, we can use it below, but it memoizes a value, and we would use that for an expensive calculation, something that takes a while to calculate and might hold up everything in our component until it had that value. So just for an example, a typical example at least, is the Fibonacci sequence function. So let's go ahead and first create a type for our function. I'll call this fibfunc here. And after that, let's give it a function signature. So it's going to have in, which will be a number, and then it's going to return a number. So this would be the type for our fib function. Then I'll just say const fib, and it is a fibfunc type. And then we'll say it receives that in parameter, which is the number. And then, oh, I need an equals there instead of the dash. There we go. Now inside the function, and you may have written one of these before, it's if in is less than 2, for example, we'll just return in. Otherwise, we're going to return, and we're going to call this again. So it says fib, and then in minus 1. And then we'll also call it over here, and we'll have fib, and we'll have in minus the dash, now minus 2. So this is an example of recursion where the function is calling itself. Let's go ahead and save that, but it's also an expensive calculation, so this is something we would use memo on. And I'm going to define one more thing, and that's just the number that we'll pass into the function. I'll just call it mynum here, and it's a number, and I'll set it equal to 37. So it takes it a little bit to calculate, but not too long, and we could change that if we want to see the difference. Or when you download the source code from the GitHub link inside of the description for this video, you could change this number and see how long it takes to calculate. I will warn you, if you go too high, it takes a while to calculate, or it may crash your browser. So now let's scroll down here and apply useMemo inside of the component. Just underneath our add to function that we have right here, I'll apply useMemo. So let's just a couple of returns underneath, and I'll say const, and I'll just say result is going to equal useMemo. And now inside of useMemo, we'll have an anonymous function, and then we'll call fib, and we'll pass in mynum. Now, since this depends on mynum, and we have the dependency array, we'll say if mynum changes, then we want to recalculate this function, and that's when it would recreate the result. Otherwise, the result value is memoized. Now, we can also mouse over and see what IntelliSense tells us. When I mouse over result, it knows it's going to be a number, so TypeScript knows that. And if we look at the signature here for useMemo, notice it says useMemo number, and then it has everything about useMemo. So if we wanted to be explicit here, we could actually put number right here beside useMemo, and that's how it would look for TypeScript. Now, just so you can see that change, let me go ahead and put an H2 here in the source code, and we'll just display the result underneath, which should be a number. And again, if you change this 37, I don't recommend going much higher. You might want to go a little lower. You'll see the difference in time it takes to calculate. It could be just a few milliseconds, or the larger the number, it could be a little bit longer, or again, possibly crash your browser. But that is the point of useMemo. If you have an expensive calculation, it takes time to calculate it the first time, but after that, it's already memoized the result. So it takes no time at all to get the result every other time that the component re-renders. And that really speeds up the process if this is an expensive calculation. And finally today, let's look at useRef. So we'll bring that hook in at the top as well. I'll type useRef up here. After I've imported it, let's define a ref inside of our component. So I like to put those after the state. Let's go ahead and put it right here, and I'll just call this input ref. I'm going to set this equal to useRef, and then I'm going to say, well, before we do that, let's just put it like we would normally see it. Say we set it to null to begin with. But I'm going to say specifically, I'm going to use this ref on an HTML input element. So we can be very specific about what we're using the ref on. Now you might be saying, whoa, why isn't this a union type here? Because we've specified HTML input element, but we've started out with a null value. Well, there's a couple of things we can do here. We definitely want to say it's an HTML input element because that's what we're going to reference. But we could use a non-null assertion here. And remember, we do that with the exclamation mark. But there's something else we can do, and that would be just a type guard when we check. And that could be a couple of different ways. One, you could have if, and then you could say not input ref dot current is where you get the value. So that would be one way to check. But another one would be what I'm going to do. And that's just log to the console first so we can see this eventually. And I'm going to put input ref, and then I'm going to use optional chaining here and just say, if current exists, then we're going to log it. I'm also going to say console.log, and I'll put input ref, optional chaining once again for current. And then if it has a value like our text input will, then we'll optional chain that as well. And you'll see how these work. And if we remove them, we can see what happens also. So let's look down in the JSX and let's put an input that we're actually referencing now. So I'm going to say input, and this input type is text. That's fine. Let's also give it a ref, and here we'll reference our input ref. I'll save that change. Now let's go back up here and look at what TypeScript does if I remove the optional chaining. It doesn't really complain, but that doesn't mean that this couldn't be null at this point. It certainly could. So you'd want to apply that there, and let's see if it's the same with our dot value here. Now TypeScript complains. So when I mouse over, it says object is possibly null at this point. So we definitely want to have optional chaining there, and then there's no problem. Now, if you are familiar with the useRef hook and creating references, you'll know that changing the value that's stored in current, so our text value from our text input will be stored in input_ref.current.value. Changing that value will not make a re-render of our component. But when the component does re-render, say we click on our button down here that adds 2 to our count, for example, that will cause a re-render. When state changes, we do re-render the component. And at that point, we will log to the console what we have here. Current will actually be our element itself, the input element, and current.value will be the value of that input element. So let's open up the terminal menu, and we'll go ahead and launch our project with npm run dev, and then we should see Vite start everything. We're at localhost port 5173. I will control and click to launch the application. Here you can see it's not much for an application, but we have our current count. We have our add button that will add numbers. And I just realized I named the function add2 and I added 1 out of habit, so we can go back and change that as well. Let me just drag this to the right. We'll get back into VS Code here. We can close the terminal and it will continue to run. But yes, my add2 function is just adding 1. So let's go ahead and update that with a 2. Save again, and we should see those changes when I drag this to the left. And now let me add 2 each time. So that's fine. We've got our recursion here with the Fibonacci number, and that is memoized. So when we reload the app, it will calculate it once, but then every time we update the state and re-render the component, the number is automatically there. It doesn't take any longer to calculate because it is memoized. And then we have our input here with the ref. Now this will not re-render anytime I type into the input. I can say, hey, but let me go ahead and pull this to the full screen and then open DevTools with Control Shift and the letter I. And we can see it has been logging the ref, which is the input, and then the value that is in the ref, of course, was nothing essentially because we hadn't typed hey in there yet, and then it didn't re-render when I did type hey. So let me go ahead and update the state one more time, and now we see hey because that is the current dot value. So we had ref.current.value to get the hey logged to the console there. When it first starts out, it should be actually null for the element, undefined for the value, and that's what we see. We also see from our use effect, we had the mounting, and then we logged the users, which were set to null for their state, and we didn't do anything with that. But then we had that cleanup function from use effect, and that says unmounting, and then it remounted the component. So we had mounting once again, and it reran the use effect when it remounted. And so that's what we all set up inside of our code. Let me go ahead and close this and pull this back over. And so just to recap, we covered several hooks today. We had useState, useEffect, useCallback, useMemo, and useRef, all commonly used, and we showed how to use them with TypeScript. Now, there's a couple of other hooks that I know we'll probably get some comments on saying, when am I going to cover those? And that would be useReducer and also useContext. And I plan on covering those in the next tutorial. They're often used together, and I think that is a great way to group them. I've already started up a new React and TypeScript project with Vite, and for this tutorial, I'm assuming you have some familiarity with the useReducer React hook. And if you need more info on useReducer, I'm going to include a link to my previous React useReducer hook tutorial in the description. We're starting with a basic counter component that uses the useState hook, and we're going to refactor it by applying the useReducer hook instead. And remember, this starter code is available in the course resources at the link in the description. Let's review the starter code. So here I've got the counter component, and you can see I'm importing a React node, which we've covered in the previous tutorial, also useState. And so first I define the children type. And here we have children, and it's a function that takes in a number and returns a React node. So you can see here for the counter component then, it receives the children, which we're destructuring right here, and we provide that children type, which is a little bit cleaner than putting this function signature right here. After that, we've got the inside of our component. So now we just have useState, and of course we're explicitly saying it's a number starting with the number 1. We've got count and set count. Then we just have some basic functions here, increment and decrement. And of course, it increments the count by 1 or it subtracts 1. And that's pretty much it. And of course, we deliver those functions in the onClicks down here in the buttons. After that, we could quickly look at the app. And here in this app component, we just import the counter, and then we pass in that function that it expects as a child here. So here's our number function that I guess it receives the number, and then it displays the current count. You can see I'm using a fragment here. You might want to put a div or a span if you're going to style it. But remember, back in the counter, we've already got the H1 here where the count is displayed. Now, if I pull this over quickly, we can look at the app here, and the counter does work. Here's the plus, here's the minus, so increment, decrement. And I've changed some of the basic styles from the Vite setup, but not much. And so you see the 2 buttons. So now let's go back to VS Code and start to refactor using the useReducer hook. Let's import the useReducer hook at the top. We won't remove useState yet, but we will eventually. Now, as I mouse over, let's look at what we get from IntelliSense right here. And I've got a definition. It says an alternative to useState. useReducer is usually preferable to useState when you have complex state logic that involves multiple sub-values. So that's really useReducer in a nutshell. We often just quickly use useState because it's simple and easy to use. However, useReducer is good to know, and it's also kind of a gateway into understanding reducer functions and how to work with some global state that you might do that in Redux or some other state management library. So useReducer, a very good thing to know. Let's start out by defining some initial state that we'll use for useReducer. Now, TypeScript will infer when we define the initial state, and that's okay to start off with, but currently we'll just set this equal to an object that has a count, and let's start with 0 instead of 1. So this is our initial state, or I called it init state. And now I'm going to define something that's a little controversial because some people do not like enums. I am going to make it a const enum. However, if you don't want an enum at all, you could make a literal string that essentially has the property value or the property name and the property value equal to each other, essentially. So the same word, if you will. Here, I'm going to type this as a const. So reducer action type, and then we won't have an equals because it's an enum there. So then I'm just going to say increment and also have a decrement. So when I said you could set this property name equal to the value, so there you would have, say, a property named increment, and then you would have a value named increment. If you just made an object like that that had literal values, and prefer not to use an enum. Again, it's controversial. You could Google that. I don't want to get too far off the course of useReducer here, but you will find articles where some say you should never use enums, others disagree and like to use enums. So I'll let you make that choice, do your own research there. So we've got our const enum reducer action type, and then I'm going to define a type now. So here I'm going to say type, and it's just going to be reducer action. And now this would have an equals because it's a type. Here I'm going to say type, and I'm going to specify that reducer action type. Now you would go, why didn't I just do this and provide those values? Well, I want to add more to this reducer action later. So you'll see why I've taken this extra step. And this kind of has this reducer action type above the enum has kind of a dual duty that I'm going to use it for as well. And you'll see that also. So now that we've defined these, we still need to define a reducer function. And notice we're doing this all above our component here, and that's okay. So we'll say const, and let's just call this reducer. It's our reducer function. And this is going to equal a function that has state. And now our state type is going to be that initial state. So let's say type of init state, and that will work. And then we can say action, and here this would be the reducer action type that we defined. And I should have put the reducer underneath that reducer action. I can see where I messed that up. So let me just put it underneath. And now it will know what it is, and the reducer action is defined. I'm going to scroll for some more room here, and after that, we can also say that the reducer is going to return that same type of init state. So we'll say type of, and let's have init state right here. After that, we can put our arrow and start in on the function. I'm also going to press Alt-Z since that extended beyond the screen there. Okay, now a reducer function contains basically a large switch statement. So we'll say switch, and then this gets the action.type, so depending on the type of action received, and then we will have cases for that. I'm going to start with the default, and we'll put the others above that. So if we get to the default, we want to just throw a new error, and we could specify an error message there if we wanted to. I'll just leave it like that. After that, let's say case. Now here we'll use that reducer action type, that enum that we defined above. So I'll say reducer action type, and now I can use dot notation, and you can see I get hints here. So I want increment, and if we get this case, I'm going to return. I want lowercase here now. So return, and this is going to be an object. Now the first thing we want to do is spread in the existing state, and then we're going to overwrite the piece of state that we want to change. So here would be the count state. This would be state.count plus 1 to increment. So that's what we would want to do if we receive that increment action value. Now we don't have any other state besides count right now, but we could later. Imagine this as a state object that has more state in it. So now I'm just going to highlight these two lines and do Shift Alt and the down arrow. And now I have the other one that I can just modify here. So instead of increment, this is going to be decrement. And then we will do a state count -1 for that action. So this is a very simple reducer here. Receives two different action types, or it throws an error. Now let me see if I can do any cleanup really quick before we move on. And yeah, the children types up here, I would rather have that children type after all the reducer stuff. So I'm just going to move it down here underneath, paste it right there. So we see that right before the component. And now we're ready to pull useReducer into our component instead of useState. So I'll just comment out the useState, and we'll start bringing in that useReducer. So here it's going to be const, lowercase again, const, and now we're going to get state, but we're also going to get a dispatch function, and that will dispatch our actions. So we'll set this equal to useReducer. useReducer starts out with the reducer function that we pass in, that we defined above, and then it also receives our initial state. So we pass in the initial state that we defined as well. So now let's scroll up so we can see a little bit more of our counter function component, and we're going to change the set count to a dispatch. So I'll just select both of those and change that to dispatch. And now inside of the dispatch, of course, we need to dispatch something different. So we'll put this as an object, and then we're going to dispatch and say type, and then we can once again refer to our reducer action type, and we could just say increment. We get those hints. And now we'll do something, of course, very similar for decrement. So I'll just copy this and highlight what we want to change, paste that in, switch this to the decrement type. And there we've changed our functions. So we're dispatching these action types now. Notice we have a problem down here with count, because before we were using the useState hook and we just had count and set count. But now when we refer to count, this needs to be state.count. And that's because we have the state from our useReducer hook. So I think we're pretty much finished with this initial version. I'll give just a space there after as well. It made it wrap down to the next line for us. I can clean up by removing the useState reference there, and I'll scroll back up to see if there's any other cleanup that we want. And yeah, I can just remove the useState import as well. Let's go ahead and save this. I'll move it over and let's see if our counter is still working. So here we go, +1, 2, 3, 4, 5, 6, and decrement as well. There we go. Oh, we just went back to 1 each time. Let's see. So it looks like we need to fix the decrement. If we get up to 6 and we hit decrement, we go back to 1. So let's see what change needs to be made there. Oh, I can see what it is. We just set state count equal to 1 instead of state count -1. So that's what we want to do there. Let's save and come back and once again test that out. Increment, decrement, everything works as expected now. So there's the basic example for the counter. But now if we go to add a payload, in other words, we receive some other data into our reducer, we could run into some problems with this if you don't know how to change the reducer with TypeScript, because there's a lot of inference going on right now. For example, if I mouse over this init state, count is a number and it's specified that way. However, what if I put in something else like some text input? Let's see what happens. We'll start by modifying our initial state. So besides receiving our count of 0, let's put in some text and let's just make that an empty string. Now we're going to get some inference here, right? So now it is count, which is a number, and text is a string. So let's add another action, which would be new _ input. And now under the reducer action, we're going to need a payload because we want to receive some input from the user, and we're not sure what the user will input, but we know we want it to be text at least, right? So let's do this, and we'll make that payload optional because the increment and decrement shouldn't necessarily have a payload. Now, what do we expect that to be? Well, let's just say it's going to be string right now, and we'll leave it at that. Now, we're going to run into an error, and I want to show this on purpose because I think it's easy to run into, and then I'll show how to fix it. And now let's put in a case for our new possibility, which is new input. So I'm going to copy this down one more time, but we're going to have a little bit more to change. So Shift Alt and the down arrow, we've got our reaction or our reducer action type. And I can say dot once again, and we should see the new input option there now. So this is new input. We're once again going to spread the state, but now we're not going to set the count. We're going to set the text. And this is not going to be state.count or anything here. We're going to get an action.payload. And now you can see we have a problem. And so when I mouse over our text property here where we're setting the action payload, it's not just string. It says it's also possible that it could be undefined. Type undefined is not assignable to string. So that could be a problem. I'm not going to fix this yet. We'll come back to this because there could be another issue we have to deal with as well. Let's go ahead and define our handler function now down in the component. We have increment and decrement. So now let's add one more handler function here, and this is going to be const handle text input. And we'll set this equal to an anonymous function. It's going to receive an event. Now, if you remember just from the last lesson, there will be a problem here, right? We already see the squiggly line under the event. React 18 and up will flag this, says E is declared, but its value is never read. But here's what we really want to focus on. The parameter E implicitly has any type. That's not what we want. This is going to be a change event. So we can specify that. And this will get imported, or it should get imported above, and this is going to come from an HTML input element that we're going to provide. And now it says change event probably doesn't exist right now, so if it didn't automatically get imported, I just need to import this above. You could also import React and then say React.change event if you want to. But now that we've got the change event, it looks good down here. Let's put in the body of this function as well. So here we're going to dispatch once again. So dispatch, and inside of our dispatch we'll say type, and this would be our reducer action type. And we'll once again choose our new input. And after that, we also need to specify the payload. Let me go ahead and break this out on separate lines so we can see each part. So I'll have this, and one more line, and here we can put the payload. And this payload is going to be the e.target.value. So that would be the text typed into that text input. And we still need to add the input to our JSX. So we'll come down here, and just underneath our div that has the buttons, let's go ahead and add our input. And I'll just press tab. It's by default a type text, which is great. And then we need to put in the onChange here. And we'll set this equal to our handle text input. Now that looks good. So let's go back up and see what TypeScript does not like. And we're still at that text property inside of the reducer. So when I mouse over, let's see what it says now. It says type string undefined is not assignable yet. So we still have the same message. So that's good. I was afraid it might also say number or something like that, any other type of input. But we can go with that because we're inferring the string type up here as well. Here the payload's optional, so that's good. If we didn't make that optional, we'd have a problem with our increment and decrement as well. So what can we do about this? Well, we need to check essentially if it's undefined or not. And if it is, we just need to make it a string. It's easy to do this with the null coalescing operator. So we can just say, basically, if it's null, put in an empty string. And that gets rid of our problem. Let's scroll back into the JSX and we can display that text as well. So here we're returning the H1, here's the buttons, here's our text input. Let's just put an H2 here, and inside, remember, we need state dot, and then we get our options, and it's the text that we have inside of our state. So I'll save that, just move this over, and now let me go ahead and type something, and it starts showing up on the page as well. So our reducer is working for the text input payload that we're sending also. So I thought about covering context in the same tutorial today, but this is a lot to take in, especially if you're not familiar with useReducer. So play around with it. Of course, add in some other possibilities to a reducer that you create and see if you can handle it and assign all of the types correctly as well. I think this will give you a pretty good map for how to do that. And then I'll go ahead and cover context and maybe creating a custom hook or two in the next tutorial. And the context is really where you typically see a reducer and the use of useReducer, because you wouldn't want all of this just inside of one component like this. So we would pull all of this out and put it inside of the context. Looking forward to covering that context for you in the next tutorial. We're starting today's lesson with the code from the last lesson in this series that introduced the useReducer hook. You can download that code, which was lesson 14, from the link to the course resources in the description. Today we'll extract the data and logic from this component and we'll set it up inside of a React context. This will unclutter our component and allow us to organize our state and logic by app feature. So we have our counter component here, and it has all of our useReducer logic in it. So that adds a lot to the component, and we don't really want that. So I'm going to create a folder over here inside of our source directory, and I'm going to name this context. Now you can have more than one context per application, and you can organize it by feature. So we're just going to create a context for our counter. So inside of this context directory, I'm going to name this counter context.tsx and press enter. After that, we can create several things inside of here. So I won't start this out like I would a normal component. I'm first just going to import create context. So I can press tab and that will bring that in. After that, we need to pull some things in from our counter component that we're going to remove from there. So it will, of course, make it look like it has an error to start out with, but it won't after a while. So we're going to have our initial state. We're going to bring in our reducer action type, our reducer action that we defined here as well. So this was an enum and this was a type. And then we applied all of that to the reducer, which we're also going to bring into our context. So I'm going to start here on line 2 and then just scroll down, and I'll hold the shift key down on line 28. So I've selected all of that. I will control X to cut it out of the component. And of course, our component won't like that for now. But I'll come over here into our counter context. I'm going to control V to just paste all of that in. So we're going to need all of these things here. Now I do want to define an initial state type. Previously, and I can press Alt Z so this code wraps, but previously we used the type of init state in our reducer, but we're going to need it in a couple of other places. So let's go ahead and define a type for that. So I'll just put that above. And I'm going to say type, and I'll just call this state type since we're only working with this one today. And then inside of state type, what do we want to put? Well, if I mouse over the initial state, we should get some IntelliSense that helps us out here. There we go. We've got count is a number and text is a string. So I can just select that, and then I can put it right inside of my state type. Now that we've defined the state type, we can use it instead of the type of down here. So let's select both of these, Control D to select the second one, and I'll just switch this to state type, and it works the same way. So if we mouse over state type now, we see that exact same thing that we defined above. And notice we're not using our initial state yet, so it's a different color there inside of VS Code, but we can say that it is the state type, so we've applied it there as well. Now we can save these changes, but our next step will be to pull even more out of our counter component. So let's look at it once again. And we have some other information inside of the component now where we defined counter that we can pull out and we can put it inside of our context. So here we have the useReducer. Of course, we're defining the reducer now in the context as well as the initial state. We have the increment function, we have the decrement function, and we have the handle text input function. We can pull all of that out of here and bring it over to our counter context where we're handling the state and logic for our counter. And of course, this context will then allow us to use it in more than one component if we want to, and we'll eventually get to that. But first, let's go back to the context, and I want to create a custom hook inside of the context that is going to hold all of this state and logic as we use it. So I'm going to say const use counter context, and then inside of that we'll start out with our init state, and that's once again the state type that we defined. And then inside of the function is where we'll put all of this logic. So now we're ready to go over to our counter component and grab all of this. So I'll start here on line 8, and then I will come down to line, it looks like 17. So I'll press shift and click. Now Control X to select all of that, and we're just left with our component with the return, which is great for now. That's all we'll need until later on. Let's go back to our counter context, and inside of this hook, I'm going to paste all of this logic. Now let me break it out a little bit. It looked crowded before, so we can see each one. So we've got our useReducer here that we need to import above. So let's do that. After our create context, we'll bring in useReducer. And now that we have it, scroll back down here and we can see it's no longer underlined. So now we have our state and dispatch. We're bringing in initial state, and it will be the state type that we defined above. We have our increment function that uses dispatch. We have our decrement function that uses dispatch. And we have our handle text input. It's using the change event, so we also need to bring that in. I'll just double click to highlight and copy, and we'll import that above. You could also say React.change event, and you might see it that way in some places, but then you'd have to import React up above as well. So either way works. So after we have that change event, let me find that once again here. It's inside of the function we're creating. There we go. It's good, and I don't see any other problems here, and we're using our reducer action type that we already brought in. So that's good, but we're not quite finished with the hook because it doesn't return anything yet. So we need to put a return statement after our last function here, the handle text input. We'll say return. It's going to return the state. It's also going to return the increment function, the decrement function, and the handle text input function. And after we save that, we've completed our hook. And this hook will come in handy. Notice I didn't say export const. We're not going to export it. We're going to use it inside of our counter context. Now notice, even though I imported our create context, we haven't used it yet. And we really haven't used the initial state yet. Even though we have created a hook that will bring it in, we haven't used it yet. So we'll use both of those here in just a moment. We have a couple of things to define as we create this context. And the first will be a type. So let's say type, we'll say use counter context, and I'll just put type at the end. After that, the easy way to get this type is to say return type. We remember our utilities from earlier in the series. And now we'll say type of use counter context. And now we've defined our type. So if we mouse over this type, let's see what we get. We've got state, which is state type. Then we have an increment, a decrement, and a handle text input function. And they all return void. And all of this is defined for us. So that's very convenient. Instead of typing all of that out, we can just use that return type utility. And now we're ready to create our context, which we will export. So we'll say export const, and let's call this counter context. We're going to set this equal to create context. And now we can apply the type, which is use counter context type. And then here we need to pass in our initial context state, which we have not defined yet. So between the type that we have here with the return type, we need to define that initial context state before we go ahead and finish creating our counter context. Now, not to be confused with the context type, the initial context state is actually going to have values here where we use that initial state we define. So I'll say const, then init context state. And now this type is the use counter context type. And I see why I've got red lines under each one of those. This needs to be a capital U, even though the function, the hook, actually starts with a lowercase u. I want to name this separately as a type, so I'll start it with a capital. So now that we have the type, and that type is correctly applied in each of these spots, let's go ahead and define what this is. And here we'll say state, and this is going to be the init state. Once again, now notice this is a value, it is not a type. We're setting initial values. So for these functions, we just need to initialize them. So I'll say increment, and this would be an anonymous function, and it's just going to have an empty object here. I can put a comma, and I'm going to Shift Alt and the down arrow, and I'll just change increment to decrement on this next line. And then on the final line, We almost have the same thing, but we'll also identify that event that comes in. So we'll have handle text input. We can have it return this empty object. And I believe when I save, it's going to add an extra space here if you see it, just the way my auto formatting works. But here we need to have our event, which is the change event. And then it is the HTML input element. There we go. Now I can save that. Yeah, and I added those extra spaces there with the auto save. But we can see that that is the correct type. And when I mouse over the counter context type here, you see that same, which I could have just copied this out of here. You see the change event there. Here, increment and decrement is an anonymous function that has a void return, and that's fine for these initial values. Once again, these are values. This is not a type, and here's that initial state value that we defined way up above here, right here as well. So it's actually that value. Those are the initial values for our context. So now we have defined our initial context state, and we can pass that in as we create the context. And then I'm going to save that. Now, every context needs a provider where it can provide the data and the logic that it contains to the rest of the application, or at least the part of the application that you want to receive it. So we need to create a provider here as well. I'm going to scroll for just a little more room. There we go, about right there. And now underneath, I'm going to say export, because we will need to export this, const, and I'll call this counter provider. You might see a generic example of context somewhere that calls this a data provider. You can name it whatever you want, but the convention is to end it with provider, because that's what it does. Now, we'll start this with parentheses, and then, of course, inside of here, we'll have what gets received. Now, we'll get the children, because if you remember, children are kind of what's in between the opening and closing tags of the component, and we will wrap the provider around the components that we want to receive the information from the context. So we'll say children, then we're also going to spread in our initial state right here. After that, we've got both of those, and notice we've got an underline under the children here. I'm not finished with that, but we will need to provide the state type. And I am skipping something here for React 18, and I want to do this on purpose to show you why, and then I'll come back and fix it. So here I would normally say React node, which is something else I'll probably need to fix. And then go ahead and have our function with the return, and then inside of here I'll have parentheses. And we could set up a little bit more. So I'll say counter context dot provider, and then guess I need to go ahead and start this out with the less than symbol here. So I start that, and now I'm going to have a value, and I'll set this equal to empty curly braces for now, and we'll come back to that. And then inside of this is where we would have the children represented. So there's a couple of things to discuss here, and I will need to set this value. But let's first talk about the children. Before React 18, you could implicitly say this, but right now you can't. You have to define the children as well. So we need a children type. And typically we would like React Node here, but now we didn't import React Node, so we could do that up above. But React is going to complain about this as well. So we don't want React Node, we want React element here. So we know the provider is going to wrap around React elements. So let's define this type above and get rid of a lot of these complaints that we're getting from TypeScript. So I'll say type, and I'll set children type. And I'm going to set this equal to a type that has children, and I'll make those children optional because there doesn't necessarily have to be children. So we'll make it optional. Say it can be a React element, or it could also be undefined, and that should cover it. Now we do need to import React element at the top. So let's do that. And we can just put that after our change event here. Now that we've brought in React element, we'll scroll back down, and I think we still had a complaint from children because we had not used our children type. Now, this is using the rest parameters here. So it has to be last and children has to be first. So I'm going to put the children type first as well. Not there. Here we go. Before the state type. Then I can use the ampersand, and I'm just combining these types here, and that works. Notice everything seems good now. So now we have a value that we're passing in. This is where we can use the hook that we created above. So if I scroll back up and we look at our useContext, it has everything we want to provide, essentially. It has the state that we're going to provide, increment, decrement, and handle text input. So let's scroll back down and put that in there. Find it here once again. Oops, I didn't go ahead and copy that. Let me scroll back up here and copy this, use useContext, and notice it receives that initial state again. So we'll also want to put that in. Once we get down here, we've got the hook, and we'll go ahead and call it, and we'll pass in that init state. So now it's going to return instantly that state and those functions that we need. Now, before we're finished with this, one thing I didn't do as we created this hook above that I should have done earlier, I definitely want to do now. These functions are not going to change, increment, decrement, handle text input, but they would be recreated. So what we want to do is wrap those in use callback, and so it always delivers the same functions and doesn't necessarily cause a component re-render in that regard. So I'll scroll back up here and let's go ahead and import use callback as well. And now that we have use callback, we can just wrap it around these functions inside of our useContext. So here's where it would go for the first one, use callback, start with our parentheses there, and then we'll have a comma here. It will have an empty dependency array. As I said, it won't change, and then we can close it out. Let's go ahead and do the same for the other two functions. So I'll say use callback once again. We will wrap that around there, and then we'll put a comma here, empty dependency array, and close it. And the final one, use callback, parentheses to wrap it, and it finishes up down here. So we'll have our, I guess it comes down to another line. So we have our curly braces, then a comma, then we'll have our dependency array, and close out the function with that final parentheses. So that should be correct. And the only other change I want to make is I'm going to export this initial state as well. So I'm going to put an export in front of that. And now we're ready to go to our app component and import what we need there to provide that context. So I'll press Alt-Z to wrap that down so we can see the full code. And at the top here, we're also going to import the counter provider that we have. And after we import that, we're also going to import our init state that we exported. And now we can use those in here. So imagine we had other components as well, but we only wanted to provide this counter context to the counter or maybe the counter in another component. We would just wrap it around those. So here I'm going to use that counter provider now. So I'll say counter provider. And TypeScript is going to flag it for something I'm not adding to it, but I'll go ahead and do that after I wrap it around the component that needs to receive this information. Now let's go ahead and specify what we're going to send in with the provider. So here we have count, because we had that in our initial state. And we also had text. And we can provide both of those. Remember, we spread those in before. So now we've imported our initial state. So we can say init state.count, and we can do the same for the text. So init state.text. And that is the initial state values that we are passing in here to the provider. So we've created our context, we're providing it to the part of the application we want to provide it to, but our component over here is still not happy. The counter component, we took everything out, we cleaned it up, but it's not receiving what it really needs to receive. It doesn't even know what these are at this point, and we're not really passing anything into the counter as a prop here either. So what we need to do, and we could create a separate custom hooks directory or just a hooks directory, or we could just create a couple of hooks inside of our counter context file that are exported that deliver these features. And that's what I'm going to do today. But just so you know, you could create these in separate files inside of a hooks directory, and that's common as well. So now that we're back in the counter context, I'm going to scroll all the way down here underneath our provider that we created. Here's our counter provider. And I'm going to create a type first before I create the hook. And this type is going to be use counter hook type. I'm going to set this equal to this object that has count, which is a number. And then it's also going to have the increment function. And if you remember right, that's just void. And it's going to have the decrement function that is also void. Okay, there is our type. So let's go ahead and create our use counter hook now. So I'll say export const use counter. Set this equal to a function, and it is going to return the use counter hook type. After that, we'll define the function. And here we'll say const. We're going to destructure and get the state, and we just want the count from the state. We don't want the text. After that, we also want the increment and the decrement, and then that all comes from our useContext hook, which I need to import above, and that would get it from the counter context that we've defined. So let's go ahead and bring in the useContext hook. Pull up here and put it after our use callback. And now it should recognize that here below as we bring that in. And we don't have a return yet, so we still have a warning here from TypeScript. But this is fine for now, because after that we can return everything we just got out. So we'll say count and increment and decrement. So notice we're only returning what really applies to the counter part. We're not doing anything with the text at all. So that's our first hook. Now let's create one more for that text type. So here underneath, I'll say type. I'm going to say use counter text hook type. I know that's kind of unusual. We just had a text example for the useReducer in the last lesson, so we've got some text in with our counter context. So we could have a payload, an example of that. So let's go ahead and define this type. This would be equal to text, and that is a string. And after that, we also need our handle input, or it's handle text input. There we go, handle text input. And that is the function, and it has that event. It uses the change event. That is from the HTML input element. And then after that, we need to go ahead and say it's going to be void at the end. Now we've defined our type. Let's define this custom hook as well. So now we'll say export const, because we'll export this also. We'll call this use counter text. Once again, a little strange, but just an example. So this would be the use counter text hook type. And now we can define our function following that. So once again, we'll destructure. We'll say const and state, but here we only want the text out of that. And then we're going to want the handle text input function as well. And this comes from the useContext hook, and that gets the counter context that is defined above. And then we're going to return the text and the handle text input function. Now that we have saved those, we can use both of these hooks that we're exporting inside of our counter component. So let's go back to the counter component. We can scroll up here to the top. Notice we're not using the useReducer or the change event now, so we can eliminate those from the imports, but we do have a couple of imports to add. We're going to import useCounter, and we're also going to import useCounterText. Now that we have both of those, we can use them inside of the component. So here we'll say const, and we're going to get the count as we destructure the increment and the decrement, and we'll set this equal to useCounter. Looks good. So now let's say const, and we'll get the text and the handle text input, and we'll once again assign those or receive those from, I should say, use counter text. So we've used both hooks and we have those values. Now we just need to change a couple of things in our component. So we've defined this as count. We no longer need the state dot here, and I'm going to press Control D because we don't need it in front of the text either. So I'll just backspace to get rid of those. We already have the increment and the decrement. We have our handle text input. Here's the text value. Here's the count that we brought in that we're displaying with the children function that it receives. And everything looks good. So I can save this. We can control and backtick to open up a terminal window. We can say npm run dev to start Vite up. We should soon receive, yes, here's the address, so we can control click here and launch that. And we have our application that displays the count, and we can type text in here. So let's try to increment. Works just fine. Decrement works fine too. Now the great part here is we've cleaned up our component. We've put all of that logic and the state inside of that counter context for that feature. And then any component that needs to receive it, we can just wrap it in that provider that we created for the counter. Let's check out the text. Does it work as well? It sure does. And that's working also. So everything's working as it should be. And I hope that helps explain how to use useContext with TypeScript. Let's start today by looking at the completed project so you have an idea of what we're building. We just have a simple product display here with 3 items, and I've applied some simple CSS. And then you can just add any of these items to the cart. Now notice in the header we have total items and total price. We have the same in the footer, and we'll see those update as we add items to our cart. You can also see that it now indicates the item is in the cart. We can also toggle to the cart view and look at the products in the cart, and you can see we can update the quantity of those items here if we decide to do that. So maybe I want 10 of the widgets, and now we've updated the total price, and we get that update in the header as well. Now the footer looks a little different because we're displaying that information up here with the cart. We can go back to view products, and likewise we could add more items here, but we don't see the quantity here, but we do see the total items increase in the header and footer. Now we won't do anything with actually placing the order today. This is just about building the cart, because placing the order could go in many different directions and it involves the full stack back end. So we're just working with React and TypeScript. So when we place the order, we'll essentially just empty the cart, and I'll leave that area for you to complete if you want to integrate with a server. So that's the full project. Let's now open VS Code and start from scratch so we can review everything as we go. I have the project folder for my TypeScript series open. You can see I have lessons 1 through 15 here. 15 was the last lesson. So today is lesson 16. We've been using Vite in this TypeScript series, and we'll continue to do so today to start a new project. So I'm just going to type npm create Vite at latest. Now, if you haven't used Vite before, I do have video in this series about how to get started with Vite, and it makes everything very simple as you create TypeScript projects, and you'll see that right here. So I'll press enter, and it's going to give us some choices. First, we need to name this. I'm going to name it lesson 16. You might want to name it TypeScript cart or something like that. And after I do that, I can choose React from this list. And then I can choose JavaScript or TypeScript. There's even a couple of new options with the latest Vite, but for today, we're just going to stick with TypeScript here. And now it has completed that install. We can cd into that new lesson 16 folder it created, that is change directory. So now I'm going to do that. I can type npm I, and it will install all the dependencies needed. After that, I'm not going to start the server with npm run dev right now. I'm going to switch into that lesson 16 server so we don't have all of these other directories over here in the file tree. So now that that is complete, go ahead and close that. I'm going to open that lesson 16 server with open folder. I've got my TypeScript series, lesson 16, open that up, and here we are with our new project. Vite doesn't create that many extra files to clean up, so we don't have a whole lot of cleanup to do. I am going to delete the app.css file, And then I'm also going to add some CSS to the index.css instead of what's here, just some basic CSS today. You could easily change that and make this cart a project of your own design as well. I'll just paste in this CSS that we'll use today, save that, and you can see it's fairly short file here. After that, we can go into the app and let's just clean everything out that we're not going to use. So for now, I'll just delete all of the imports and basically everything that's inside of this app component as well. So I'll just leave that div with the class name app for now as the return and empty all of that out. So we've emptied the app component, and then the main.tsx instead of an index.tsx. And really, we can leave this the way it is for now as well. I'll press Alt-Z so you can see that line wrap down. I am going to add one new directory, not in the source directory, just a new directory in the file tree. I'm going to call this data. And then inside of the data directory, I'm going to create a file called products. I could spell products, there we go, .json. And this will just have our product data. And we only have 3 products today, so 3 different widgets here. And you can say the JSON here has the products array, and there's the information, SKU, name, and price for each. So let's just save that, and we'll come back to that and refer to that a couple of times in the project. So that's our basic setup. So we're going to create a couple of contexts today, one for each view. Here is the product display view, and after that we can also go to the cart view and anything in the cart. So we'll have a cart context and a products context. Also, we'll have a header and a footer, and then we will have an area for this products display, and of course an area for the cart display as well. It also has a header and a footer. So that's thinking about the components in this project. So let's go back to VS Code and get started with all of that. I'll drag this back over to a full screen. Now inside the source directory, let's create a directory called components, and let's create another directory inside the source directory, and let's call this context. And I almost forgot one more directory because we need some images. And so I'm going to create this and just name it images. And we're going to learn how to pull in dynamic images into our code using Vite, TypeScript, and React. And so inside of this images directory, I need to go ahead and just paste in the 3 product images for now. And if you were creating a large project, instead of having these images actually with your project, you might be pulling them in from an AWS bucket or somewhere else on the web. However, I think it's important to have images in this project and show you how to dynamically pull those images in when you're using Vite as well as React and TypeScript. So before we ever create an additional component or add anything to the existing components, the app or the main, let's go ahead and create a product context and start thinking about that data we're going to use and how we'll provide it to those components. So here we'll create the new file, and I'll call this productsprovider.tsx. Now let's start by creating our product type. So I'll use an export here because we might need to export it later. I'll say type, and we'll name this product type. And let's set this equal to something that mirrors those products we saw over here in products.json. So we'll have a SKU, and that is a string. We'll have a name, and that is a string. And we'll have a price, and that is a number. And we can verify that if we just quickly look at this products.json. We have the SKU. It is a string, and it has a pattern. It says item and 0001. And you might often find that when SKUs are named, that there is some type of pattern. We might extract that number later. We have the name, and then we have the price that is an actual number. So now let's go back and we'll look at this products provider, and we can use this product type when we define the initial state. So here we'll say const init state, and it is the product type. There we go, 2 T's in a row. That gets me. But it will be an array of these product types. Now, we could set this equal to this empty array, but for now, we have this data here. So without setting up any type of fetch, let's just go ahead and select this, and let's start out, at least as we begin here, by just setting that initial state to that JSON array right here. And I didn't put it inside of the array. Actually, I've got the products on the outside here with the object. So we just need to get rid of that part and just keep the part that is the array as we set that initial state. And now the part that you just saw me delete from this data and just keep the array. So if we look back at the JSON where it's actually an object here that has products and then the array is the value of products, we need to create that type as well because we're going to need that with the context. So just underneath this initial state, let's say export type, and we'll call this use products context type. And we'll set this equal to an object that has products, and then it will be the product type array. There we go. And now we've created our use products context type, and it does represent the products. Then it has that array right there. Now this is not the same as the initial state, of course, and we needed to define that product type above that as well. So we'll need all of this as we go. Now let's define our initial context state. So we can say const, and I'll call this init context state, and this is going to be the use products context type. And then we'll set this equal to something that looks just like what we have above. But now this is a value, so it's products. And then the initial state here for the context can just be that empty array. Now, finally, we need to create our context. So underneath this, let's say const products context, and we'll set this equal to create context, and if I tab, it should import that at the top. Let's take a look to make sure. And yes, we've got the create context import at the top now. After that, we'll say this is a use products context type, and then we'll pass in our init context state. And it looks like I need to press Alt-Z to wrap that code down. But now we have created the products context. And we've used all of the types we've created, but you will notice we have not used the initial state yet, but that is coming as well. We'll use that in the provider. So after we create this context, we now need to create a children type. And if you remember from the useContext lesson, you now need to provide that children type as you create a provider in React 18 and above. It used to be okay to have that implicit in older versions, but not now. So let's quickly create that children type to use as well. So I'll say children type, and I'm going to set this equal to children that will be optional. So we'll use the question mark and then a colon, and then I'll say it can be a React element, and I'll press tab and it should import that at the top as well. Or we need to put React element and then have that in an array. So it could be more than one if that was the case. So now let's check that import at the top again. And we do have React element now imported as well. Okay, now that we have that type, we can start creating the provider. I'm going to scroll for some more room, but let's keep that children type in view. And I'll say export const products provider. And we'll set this equal to a function, and we can destructure the children in there. And remember, the children are what's in between the opening and the closing JSX tags. It's not the same as a prop that's being passed down and used. It's something that you put in a component between those tags. Although it is a prop, it's just not really provided in the same way. Okay, so now that we have that, we need to specify the children type. And then we need to say this will return a React element. And we can use our arrow function. Notice I'm now using ligatures in my code, and I have a short on how to enable those if you want to. So I'm using a new font that is a Code font. Looks a lot like what I was using, but it enables these ligatures, and that YouTube short can show you how to do that. Now, inside this products provider, I'm actually going to use state. I don't have a need for a large reducer inside of this context. So I'm just going to say const. I'm going to have products, also going to have set products. Then I'm going to set that equal to use state, and the type would be a product type that is an array. And then inside of that, we will pass that init state from above. So we're pulling that in from the lexical scope. We don't need to pass it in as a parameter. That would just be a little too much boilerplate, and it's really unnecessary since they're in the same file. And I want to draw your attention to that because I did that in the useContext lesson, and somebody asked me about it, and I said, you know what, you're right. I didn't really need to do that. Sometimes with TypeScript, I get too far into defining everything and being explicit, and really didn't need to do that. So we can just pull that init state from above using the lexical scope here inside the same file. Okay, after we have used useState now, which it doesn't look like it imported that. Maybe I needed to hit tab and I forgot to, so let's import useState at the top. Now I'm going to return the product context.provider. So I'm going to use parentheses here and break this into separate lines. I'll have products context.provider, and then we'll have a value, and this will equal 2 curly braces, and inside of the curly braces I'll have products, and then we'll have the closing tag. And in here, as I mentioned above, or maybe didn't explain well enough, but I will try to now, is the children. So we wrap this around the children. Notice they're not passed in like we would a prop like the products, for example. It's actually what's between the opening and closing tags. So the only thing we need now at the bottom here is our export default, and we'll have products context. And we've officially completed our products provider, which is our products context here. But what I did was set the initial state and just put it in here kind of statically inside of our file. We're not fetching that. So quickly, if you want to do that and actually use this products.json file, we can do that with JSON server in a dev environment. Now, if you were to deploy this project as an example, I would go back to just keeping it in this file, which would be the easiest. So you may want to skip this step, but I do want to go over it because it deals with a promise and a fetch, and I think that's another good recap for this course. So let's quickly bring in useEffect at the top. And I know it's been popular lately to say you don't need useEffect, and that's fine, but I do not want to bring in another dependency like React Query or something into this small project. We're focused on React and TypeScript. So we can use useEffect, and there's nothing wrong with it. There just may be better options when you're creating a full project and looking at all the different options. However, we can use useEffect to bring in this data. So right now, I will comment this out. And I could leave it in here in case you wanted to use that instead. And like I said, if you were to deploy, that's probably what you would want to use. But now let's just define the init state, and it will be the product type once again. And it would be an array of those product types. And we'll start out as just an empty array. But now let's go down into our provider, where we have our products and set products. And notice set products wasn't being used at this point. So what we're going to do is use that along with useEffect now. So we'll have our useEffect call and our arrow here. And we're going to give this an empty dependency array because really we only need to load the products once, and that is when that component loads or when this provider loads. And so inside of this now, let's go ahead and say const fetch products, set this equal to an async function, and after this we need to give this the type, and so this is a promise. And now what we expect in return is the product type once again and an array of those products. After that we'll have our arrow, and now inside this fetch products function we can say const data. We'll set this equal to await fetch, and now we're just going to run this local JSON server to serve those products. So I'm going to say HTTP, and we'll put it on port 3500. So just on our local host port 3500, and it will be products. After that, let's chain a .then. We'll get our response, which I'll just type as res. Have an arrow here. And then we could return the response.json. So we have received our data, and then we're going to return that data. And then let's go ahead and chain a catch here. And that's if we get an error. Inside our catch, if you remember from a previous lesson when we showed a promise fetch like this, I think it was in the utilities lesson, we have if error is an instance of error. At this point, we could just console.log, and we could log the error message to see what that is. Of course, you could do more with an error if you wanted to as well, but we'll just put in that simple example right there. Now at the very end, we're still not returning the data yet, are we? So we've defined the data here, and this is how we get that data. And of course, we want it to be JSON when we eventually get it. So after that, we need to return the data. So that's the full function. It's not the full use effect that we're going to have though, because then we need to call this function. So we call fetch products, and then after we call it, we'll chain a then on here, and then we'll have our products. I'll just use an arrow, and as a one-liner, I'll say set products, and we'll pass in the products that we have received. So we define the function inside of the use effect, and it's only called really when this loads. And then we go ahead and call that function, we get the products, and we set the products. And we'll get all of that from the JSON server that we start up. So once again, even if you're against using useEffect to query data like this, I wanted to give an example of it, and it goes over something we covered, the promises inside of the TypeScript series. So we've got all of that. Now we could go ahead and launch this products.json server as far as our dev environment goes. So let's go ahead and do a control backtick here. And after that, you can do it with npx. So I'm just going to type npx json-server and -w for watch. And we'll say watch the data folder / products.json, and -p for the port. We said 3500, and that should be all it takes. We can go ahead and get that running. And yep, it's running now. I'll go ahead and expand this so you can see everything. And this is what you get from JSON server when you do that. So it's running and it looks good. Now, if we want to open another terminal window to run our project when we're ready, we can just do that here, and I'll get a second bash instance there. So here is the JSON server. Here's the one where we will run our project when we're ready to do so. And we can close this and it will keep running. With the products provider now set up, let's go ahead and create the cart provider as well. And then we'll just have to pull all of our components together and use the data as we need it. So let's create another file here, and we'll call this cartprovider.tsx. And inside of the cart provider, I'm going to create a cart item type to start. So I'll say export type cart item type, and we'll set this equal to a similar item as we saw with the product type. It will have a SKU, which is a string. We'll have a name, which is a string, have a price, which is a number, and it will also have a quantity, which is a number, and that's a new one. Other than that, just about the same, but we'll use it differently in this context. We're also going to have a type that is the cart state type, and let's set this equal to an object that has the cart, and then it has the cart item type, and it will be an array of those cart item types. And now we can follow that up with an initial state, so I'll call this init cart state, and this will be the cart state type that we just created. And now this will be a value, of course, not a type, so we'll now have a cart with an empty array here. And now I want to create a reducer action type because our cart will need a reducer. And so here I'm going to do this differently than I did in the context lesson as well, where I used an enum, which is fine. I know some don't like it, but it can be useful. That's an opinion, and I won't go either way. I just used it that way in the lesson. Here, I'm going to use strings specifically. So I'll just create an object for a reducer action type. So I'll say reducer underscore action underscore type. And inside of this, the properties will match the string. So add is add, remove is remove, quantity is quantity. Might have been easier if I had abbreviated that, but being explicit is okay. And now we've got submit, and those will be our actions for our cart. I'm going to scroll for some room. We'll keep that reducer action type in view. And underneath, I'm going to set export for these types when we need them. And I'll call this reducer action type, but it doesn't have the underscores and it's not all caps. So it's not quite the same. And this will be type of reducer underscore action type. After this, I'll also say export type, and this will be a reducer action. And here I'm going to say type is string, and this is where we would specify a payload if it existed, so it needs to be optional with the question mark, and this would be a cart item type that would come in as the payload. And now let's start our reducer function. So I'll say const reducer. This is going to be equal a function that gets state, which would be the cart state type, and then the action, which is the reducer action that we just defined above that has a type and a payload. After that, it's going to return the cart state type, and I need to press Alt-Z to wrap this code down. We'll get our arrow, and now we'll have the inside of the function. Now, reducer typically has a switch statement for the action.type, and now we'll specify our cases. So our first case would be case reducer, and here we can just arrow through and get action type, and then we can use dot notation to complete, and we'll have add, and that would be our first case. Now I'm going to scroll, and we'll fill out these cases after we define them. So the next case would be lowercase case reducer underscore action type, and this would be remove. And I can just copy this down to make it go a little faster. Shift Alt and the down arrow twice, because we'll have two more of those. So we're also going to have a quantity here. If I just backspace and delete, we'll get the completion. There's quantity. So again, backspace, complete, and a submit. And then we can't forget there should be a default if things don't go as planned. So we'll have our default, and this would be throw new error, and we could give a specific message here. We could say unidentified reducer action type if we wanted to. We'd know exactly where that error is coming from. Okay, so the easiest one to complete is the submit, because we're not really submitting to a server. We're just going to empty out the cart when we essentially click that place a new order button. So here I'll just return, and you could put in other logic if you needed to link this to a server or submit somewhere. So then we'll just set the cart equal to that empty array, and that completes our submit action for the reducer. Now, if we don't put in some type of guard, we'll essentially get a message from TypeScript saying that the action payload could be undefined or null or something like that. Basically, if it's missing, even though we know it probably won't be, we should go ahead and put in something to catch just in case. And so here we'll say if there is no action.payload, now we could throw a new error. So here I'll say throw new error. And inside of here, we'll say action.payload missing in add action. Definitely a message we would expect to get and hopefully catch in development before anything went into production where the action payload was missing. However, we can just copy this now and put it in the next two as well. So I'll put it here, and then we'll just need to change what we have here for the add. Instead of add, it would be the remove, and instead of add here, it would be quantity. And looks like I put, no, there it is, just quantities and wants. I almost thought I typed it twice or duplicated it. Now we're just fine, and let's come back up to the top. So our add action type is going to need some information from that action payload. So we can just destructure what we need, destructure. And once again, I need lowercase, and this would be the SKU, the name, and the price that we would get from the action.payload. And now we just want to filter the cart, so we have all the other items that are not the item that we're updating. So let's say const filtered cart, and this is going to be a cart item type array that we would get back. We can set this equal to state.cart.filter, and now each item that we go through, we will compare, and we'll just say the item.SKU should be not equal to the SKU that we just destructured above. So now we've got our filtered cart with all the items that we're not updating, and now let's make sure the item that we are updating exists. So we can say const item exists. This would be cart item type because it's a single item, but if it doesn't exist, it would be undefined. So now we've defined exactly what item exists could be as far as types go. Now we'll say state.cart.find. We have the item, and then we can compare the item.skew and make sure it equals the skew. And now we used the find method on that array for our cart, and this will help us determine the quantity that we want to set for the item. So let's define the quantity value, and it will be a number, and we're going to look at the item exists. And if it does indeed exist, it would be the item exists.quantity because we found the item. And then we would need to add 1 to that item. Otherwise, it will be just the number 1 because it wouldn't have been in the cart, so it didn't exist, and we just need to add 1 at that point. And now we're going to return. I have an object here where we spread the state, and then we'll have the cart, and really our state only has the cart, but this is in case you had other things. It's still a good idea to continue to spread that state in there, and that just leaves it flexible for the future if you wanted to add more. Here we'll have our filtered cart, which has all the other items that we're not updating, and then we'll go ahead and put in the item we are updating. So we'll have the skew, the name, the price, and the quantity. So everything we destructured above, and then we arrived at that new quantity that will be set for the item. I'm going to save those changes, and it might help, or it might be easier to read if we put a line between each one of these that we were defining. As you see it wrap down, it starts to get just a little confusing there. So there's the extra line. Now you can see everything we did on separate lines here. Now I'm going to copy these 2 lines here where we destructured and we defined the filtered cart, and I'm going to move down to the reducer action type remove, and underneath this I'll paste these lines in, and there won't be much to change for them. But all we really need here is the skew. We do not need the name and the price, so we'll only destructure the skew. And after we do that, it's really easy to set up the return because we've filtered the cart and we're removing the skew. So now we just say return, and we have an object here, and we'll once again spread in the state, and we'll have our cart, and this array will just have the filtered cart items spread in, and that's pretty much all there is to it. So we're just excluding that skew. Okay, before we move on to the quantity payload, or the quantity reducer action type, I should say, and the payload that is associated with it, I'm going to scroll back up once again to the add reducer action type, and I'm once again going to copy not only the destructured line, the filtered cart, but also the item exists line. We'll use those in a little bit different order down here logically, but we will use all of those, so I won't have to modify them too much to use them. So just paste them in for now. And as far as the destructuring goes, we're just going to need the skew and the quantity this time. So Q2Y at that point, or QTY at that point. We will need the filtered cart, but it's going to come later. So I'm going to cut it out, and we'll check the item exists first. Now, after the item exists, if it doesn't exist, we can't really update the quantity for that item. So let's go ahead and put in another guard here. And I'm just going to say if item exists, and what we're saying with the exclamation mark is if it doesn't exist, now we're going to throw a new error. And this error can be item must exist in order to update quantity. And you could handle that in a different way if you want to, but that's what I'm going to do here. And it's essentially a type guard saying we're not going to go any further. We're going to throw an error if we're trying to update the quantity of an item that doesn't exist. Now, after that, let's go ahead and define the updated item, because we should be able to do that once we've confirmed that item does exist. So updated item is going to be a cart item type. Let's set this equal to spreading in the item exists properties and adding the new quantity. Now after that, we've got the filtered cart once again, and that is defined in the same way. And now that we have that, we can return what we need to for updating the quantity. So we'll once again spread in the state as we should. We have the cart, and it's a new array, and it gets the spread of the filtered cart items. And then we're going to have our updated item in that array as well. Now that completes the different action types, and that's quite a bit there really, and just a little different order of logic. And maybe you find a different way to do it, but that has worked for me. And so we'll go from there and have the reducer with add, remove, quantity, and submit action types. Now going back to the useContext lesson we had in lesson 15, we're going to create a useCartContext here. So we'll say useCartContext, but we'll only call this function in this file when we create the provider. It's going to have the init cart state, and that would be the cart state type that we defined above. After that, we're going to use state inside of here. Actually, not state, I'm sorry, we're going to use the reducer that we just created, and I'm just going to define this as state, and then we'll have our dispatch right here. Now, after that, we can say useReducer. We pass in that reducer function, and this is where we'll use our init cart state as well for the useReducer hook. And it looks like I need to import that at the top. I should have hit tab, and I did not. So we'll say import useReducer from React. Now with the useReducer imported, I'll scroll back down, and we're underneath our reducer action function there, and we have our useCartContext hook that we are creating. And now we're going to define reducer actions that looks a lot like our reducer action type, but I'll just call it reducer actions because what we need here is use memo to memoize the value of this object. And so we're just going to wrap it around that object, and we're going to pull that in from the lexical scope above. So we have reducer action type that we're just returning here, and this will be an empty array. And so what we have done is memoize that reducer action type so it always has the same referential equality when we pass it into a component. And that will help us memoize the component in the future without worrying about reducer actions causing a re-render. So now let's define the total items that we're going to display. So we'll say const total items. And let's set this equal to state.cart. So we're getting the cart there, and we'll use the reduce method, and we'll get the previous value. And then we'll also have the cart item. And then after that, we'll have our arrow with the function, and we're going to return the previous value plus the cart item dot quantity. And now, of course, the reducer needs to start with an initial value, and that will be 0. And I've got some squiggly red lines because I typed reducer instead of reduce. Once I remove that, everything looks good, and we've defined our total items. Now let's mouse over total items and see what we get here. We can see that is a number. Often when I'm defining something, I like to specify what type that is, so another developer could quickly look and go, hey, I'm defining a number here. That's what I'm creating as I create the total items. But that could be overly explicit for you, and at that point you wouldn't have to do that because TypeScript is going to infer that as well. So if we delete that and we mouse over, we get the IntelliSense, and you can tell that it's a number as well. So I'll leave it without, and I'll leave that choice up to you. Now I'll have total price, and this is going to be equal to a new international dot number format. And this will help us format the currency that we want to display. Now you could look this up on MDN to see all the different ways to set it. I'm going to set it to US, and then I need a capital S there. And then I need an object here that has a style, and we say currency. And after that, we say currency is going to be the US dollar that will display in this application. Now you could set that differently for yours if you want to. And then we're going to format it. And now this is where we're once again going to use reduce on the cart. So I'll say state.cart.reduce. We'll have the previous value and the cart item once again. And after that, have our function, and it's going to return the previous value plus the cart item dot quantity times the cart item dot price, and that is not what I wanted at all. I need the cart item dot price, and then we need our curly brace after that. And oh, I guess we don't, we have it down below, but then what we do need is the comma, and then we start off with a 0 because that starts out the reduce with the initial value. However, I can see I left a parentheses out here at the beginning. So once we add that second parentheses that's wrapped around the previous value and the cart item, everything formats like it should. And this is creating our total price. Now notice when we look at the IntelliSense, total price is a string, because now that we've formatted this, we're not even going to have to display the $sign and concat it together with the number value. This is going to create all of that for the display for us. And finally, we want to sort our cart in order. So let's create a cart, and let's go ahead and have this be the state.cart.sort. So we're using the sort method here, and we'll compare A and B. And now inside this function, we need to define item A first. So we'll say item, let's use a lowercase here, item A is going to be equal, and we need to wrap it in a number. We'll have a.skew and now .slice. So we're really extracting those last 4 digits of the item number, which was a number. If we look back here at our data in the products JSON, you can see we have item, then 0001. So we're going to extract these 4 numbers, and we can do that as we see here with slice. After this, I'll just copy this down with Shift Alt and the down arrow, and we'll have item B, and this is going to be b.skew.slice -4. And after that, we can actually return the comparison. So item A minus item B. And this will put the cart in order, essentially. So item 1 would always be above item 2 in the display when we look at our cart. Okay, finally, to finish this hook, we just need to return everything we've defined. So we're going to return, we'll have dispatch here. And now dispatch is nice because it keeps its referential equality. It will not cause a new render when we pass it down. Now we have memoized reducer actions, and so that won't cause a re-render either. These others possibly could, but we'll of course create custom hooks to pass some of these in as well. So we might not pass those down as props from a parent. So we'll have total items, total price, and the cart. Now, of course, I just said we'd create custom hooks. That doesn't mean they won't cause a re-render. It's just another way to approach it. And memoization only helps like when we would use React.memo, pardon me. That would only help if we were passing things down as props. So we'll see how we organize all of that when we get to the components. Okay, we have now completed our use cart context hook that we will be using. So underneath this, it is time to think about creating a context. So let's take the steps necessary here. We'll export type use cart context type. And let's set this equal to return type. And now we'll just say type of use cart context that we defined above. So that's a nice shortcut which gives us the return value from this hook. And as we look here, or with the return type, and we can see it's defined well where we get the dispatch. And now we can see the type of the dispatch. We have our reducer actions, total type, or total items, total price, and the cart, which is the cart item type array. Now I'm going to scroll up, but let's set up some initial state here for the cart context. So I'll say cart or const init cart context state. And here this would be the use cart context type. And I'll set this equal to, and now we'll have our object with dispatch. And again, this is just an initializer function here. So I'll put in the operators, have our arrow, and an empty object. We'll have the reducer underscore actions, and this is the reducer underscore action type. And we know that because that's essentially what we memoized and made sure that it would be that type. Okay, for total items, we'll just start out at 0. Total price, remember, is a string, so we'll just make that an empty string, and the cart can be an empty array. So this is just our initial state that will pass into the context. So now we're ready to create that context. So we'll say export const cart context equal to create context. This would be the use cart context type. So we need that at the end as well. And now here we'll use the init cart context state. And I believe I probably didn't hit tab when I typed create context. I need to get in the habit of doing that. So we need to import the create context at the top. We put that in and save, and we shouldn't have a problem now as we look back and create that context before. Oh, here we do, because I believe I did hit tab. Notice the difference. I used the underscore here, or not the underscore, the lowercase. And now I need a capital U for use cart context type to match that. Now that I have the right type defined there, everything looks good. We're almost finished with this context, so let's go ahead and define the children type again. And this will be essentially equal to that same children type that I defined in the products context. So you could keep this in another file and import it to use in both if you wanted to, export it from that file, of course. But here we'll just redefine it with children, and oh, it should be optional. And then we should have React element. I'm going to hit tab so it imports it, or React element and an array of those elements essentially would be the type. Now we're ready to create that provider. So we'll say export const. Let me scroll for a little more room, and we'll call this cart provider. Set this equal to a function that brings in the children, and that would be the children type. And now we need to say it returns a React element, follow that with the arrow, and inside of our function we just need to return the cart context provider. So I'm going to say return, I'll use parentheses, this would be the cart context dot provider, and now we'll pass in the value, and we'll just get this once again from the lexical scope. In other words, we're not passing it in as a parameter here, but we're going to pull in the use cart context hook that we created above. So that's in the lexical scope up here. As I scroll up, here it is. And then we're also going to pull in the state that it needs to receive, and that is the init cart state. And now that we have done that, let me go ahead and get rid of that extra parentheses there. We're pulling this in from the lexical scope as well. Now that we've done that, we just need to close out that provider with the caret, and we get the closed cart context.provider, and in between, once again, we need to put the children right there. And now we're essentially finished except for the export default cart context. Now I'll save this file, quickly scan back to the top to make sure we don't have any other errors. I don't see anything in Visual Code. We usually see a red mark in the scroll bar if it exists, and we have all of the imports we need here as well. So now we've created our products provider and our cart provider, and that is a large part of actually creating this whole project. And now this is already turned in kind of a long tutorial, so I'm going to break it into a couple of parts, and in the next one, we're going to pull all this together with all the components and finish this TypeScript and React project that creates a product display and a shopping cart. And now I've got my lesson 17 folder open. Now this is the completed code from lesson 16, and I just created a new folder. You may want to continue to work in the same folder you were already in from the previous lesson. Now we did the heavy lifting in part 1, where we set up a context for both the products and the cart. So we have our products provider.tsx and we have our cart provider.tsx. Today we'll create all of the app components we need to complete the project. We already have the component directory right here. So now that I've highlighted that, let me go ahead and create a few components. We're going to have a header.tsx. We're also going to have a footer.tsx. We will have a product list.tsx, and let's go ahead and create a cart.tsx. Now these aren't all of the components we'll need, but it will give us a good start, and that's everything we're going to need to import into the app, which will be the parent component. So I'll just go into the header first, and I'll type RAFCE because we have the ES7 React snippets installed, or at least I do. If you don't, I recommend those. And now that I have this header, I'll just save this, and I'll move on and do the same for the footer, and save. And then we can do the same for the product list And then we can do the same for the cart. Now that we have those, we can move over to the app.tsx. I'm going to quickly import all of these. So we have header, and then we'll have the footer. That's not exactly where I needed the return. We'll have the footer after that. So import footer, and it comes from the components. After that, we will import the cart. And after that, let's also import the product list. And now we can use these in the component, but I do want to import the useState hook as well, because we are going to use that to toggle between the views. So now with the imports complete, let's go ahead and apply the useState hook here. So I'll say const. I'm going to call this viewCart with camel case, and then I'll say set viewCart. And we're just going to set this equal to useState. Now we could say a type right here, or if we just put in the Boolean, it's going to, of course, infer what type it is as well. I'll mouse back over and see if we get that inference. Yep, there we have viewCart Boolean, but you could provide that here with the arrows just like that. Now I'm going to define some page content, and that's exactly what I'll call this, and this is what we will render, but this is going to be based on what the viewCart value is. So I'm going to use a ternary here. So if viewCart is true, we're going to render the cart component. And if it's not true, we're going to render the product list component. And now we have our page content. So after that, let's create some content to go along with it, where we wrap the page content in the header and the footer. So now I'll say const content, set this equal to, and I'll use parentheses so we can use multiple lines here. I'll start out with a fragment. Now inside the fragment, I'm going to use the header component, but I need a capital H. There we go. We're going to pass down props. So I'll have the viewCart, set that equal to viewCart. And then we're also going to have set viewCart. I'll set that equal to set viewCart. And now that we have that, let's close that out. And now let's put the page content that we created above. So we're determining which we're going to render here, which would essentially be the main element of the page. That's either going to be the cart or the product list. And then we can wrap this in the footer, and the footer just needs to receive the viewCart value because it's going to do something a little bit different. It will not need to toggle like the header does, where we actually have that button. Okay, let's scroll just so we can see the rest of this. And really here, instead of the return with the parentheses, now we can just return the content. And we have a red squiggly here for viewCart. Let's see what it says. viewCart Boolean is not assignable to type intrinsic attributes. Well, no worries, because that is recognizing something from the header and the footer, and we will fix that as we go. But this is the code that we need here inside of the app component. So I'm just going to save that for now. We'll come back and check on this after we go ahead and complete the header and the footer. Let's move on to the header now. Okay, the header is receiving props. So let's define a props type at the top. So I'll say type, and I'll just call this props type. And I will set this equal to an object there that has viewCart, and that is a Boolean. And after that, we'll also be receiving set viewCart. Now, what is set viewCart? It's a setter, essentially, from the useState hook. So let's go back and let's get the type from the app component where we have it. And if we mouse over, we can see it is React.dispatch and then React.setStateAction and a Boolean. So we can just highlight all of that and copy with Control-C. Now let's go back to the header, and we can put that right in here. And now we can destructure our props. So we're going to get the viewCart and the set viewCart. And after that, we can say what type it is. So it will be our props type. And now that looks okay. And I think if we go back and check, let's confirm. No, we still have a problem with the footer. That's why app was still red over here, or it's red up here at the top. But look, the header no longer has that red squiggly line because we've set up the props correctly. So we'll do the same with the footer when it comes time. Now let's go ahead and define some content for our header. So I'll say const content, and I'll set this equal to a couple of parentheses again so we can use multiple lines. And I'm going to put in a header element. And there we go. Now that we've got the header element, I want to add a class here. So class name, equals, and this is just going to be header. Now this relates to the CSS that I'm providing for this tutorial. If you want to use your own, that's fine too. You can change it in the index.css file. Okay, inside of the header, we want a div, and let's give this a class name, and I'll just use the Emmet shortcut here with the dot and 2 underscores, and I'll say title-bar. Press tab. Now we've got the class name on there. And now inside of this div, I'm going to use an H1. I'm going to put Acme Co. for the header. That's just the company name. And then after that, I want one more div, and I'm going to give this a class name of header 2 underscores and price-box. Press tab, and we're good. Now I want 2 paragraphs inside of this. So here's my first paragraph, and I'm going to say total items and give a colon. Now we're not going to pull that in yet, but we will in just a little bit. Second paragraph, I'm going to say total price and put a colon here. Now if I save, let me drag this back over so you can see what I'm working on. Here's our company name, Acme Co. Here's what I put, total items and total price. Now clearly we're going to pull in some information here from our context. And then we have a button here for the view cart toggle, but that is in a separate component. And we're going to create a nav component and import it in here. So let's create that nav component. It's just nav.tsx. Now RAFCE, and press tab, and we have our basic nav component. And nav is going to receive the same props. We're just passing those down from the app component to the header component, right on down to the nav component. And because of that, we can just copy this props type. We could actually define the props type somewhere else and just import it if we want to, but it's not that big. It's easy to copy, and I also like having it in the component so it's a quick and easy reference when you're looking at props type as well. So you can do it whichever way you prefer. I'm just going to paste in the props type here also, and I really could go back to that header because we're passing in the same props too. So just copy this line, go back to the nav, and put it right here inside of the parentheses. Now, easily a store nav could have many more things inside of it. We're just going to put in our button that toggles between the two views. So I'm going to define the button, say const button, set that equal to view cart with a ternary here. So what we're doing is checking the value of view cart, and then we'll say if it's true, we're going to put a button or return a button, and it'll have this on click, and we'll put in an anonymous function, and then we'll say set view cart, and it will be false. And then after that, let's close this out, and we can say view products. So that's if it's true. I'm going to press Alt-Z so it wraps down as well. But if it is false, then we'll have the colon here. So we're just completing the ternary. We'll have a button once again with the on click, set that equal to an anonymous function with set view cart, which would be true. And so now we'll say view cart. And that really completes what we need for our button. So we're just defining the button based on the view cart value. After that, let's create some content once again. So I'll say const content equals with parentheses, and I'll use a nav element. Press tab, and after I've got the nav element, I meant to put a class on that. Say class name equals nav. And then inside of the nav element, we're just going to have our button to render. So now we can just return the content we created here and save our nav component. I'm going to put in a couple of blank lines just to make it a little cleaner. And after that save, let's go back to the header and let's import the nav at the top. So now we're going to import nav. And after we have the nav imported, we can use it inside of the header, and we're going to put it below the div we created here that has the company name and the total items and price. So just below this div, we'll say nav, and then we'll pass in everything that we were passing along. So the view cart equals view cart, and set view cart equals set view cart. After that, we can just close out the component right there, and we've completed the header. Well, I may have said that too soon because we didn't return that content yet that we created above. Now we have completed the header. Let me add that extra space for some formatting, but it is now good to go. Well, I am jumping the gun just a bit when I say it is completed. And by jumping the gun, that's an expression that says I'm a little bit ahead of myself, because what we didn't do was pull in that context information that we need from the cart context. And we can't do that yet because we need to create a custom hook to do that. And so I'm going to highlight this source directory, and I'm going to create a new directory inside of it called hooks. And now that I've done that, I'll go ahead and create a file here called usecart.tsx. Now, this is a very simple hook. We'll just import the useContext, and that comes from React. After that, we can go ahead and import our cart context that we created inside of our cart provider.tsx. And then we're going to import the useCart context type that we also defined inside of that cart provider file. Now that we have those three imports, we'll just say const useCart, set this equal to a function, and this function is going to return the useCart context type that we've already previously defined. Now inside of this, all we need to do is say return useContext, and we pass in the cart context that we created. Now here at the bottom, you could say export as you define that, or you could put a default, and I'm just going to put a default here. So I'll say export default use cart. And now this custom hook is ready to go. The nice thing about this is now we'll just need to import useCart, and we can begin to use it rather than importing a couple of things that you would need to do with the useContext hook here. So it just kind of simplifies that for us. So now let's go back to the header, and we'll go ahead and use our useCart custom hook that provides the context. So inside of the header now, at the top, we want to import useCart. And then just inside of the component, I'll put it right at the top, I'm going to say const, and we're going to get the total items. We don't have to bring in everything, just what we want from the context, and the total price. And this is going to equal useCart. Now, we've already created those inside of the context, so we can mouse over and we can see that total items is a number. Total price is that formatted string that already has the $sign. So now we can just use these inside of our component. We did all of the hard work inside of the context itself in the previous lesson. So now we'll just go total, whoops, we need the curly brace, total price, and save. And now the header is actually complete with the data we needed from the cart context as well, so it can display the correct information. Now the footer is actually easier than the header, so let's go ahead and complete that. We've already got everything we need, so we'll just say import useCart. And after that, inside of the footer, we need to define that props type again, so we're going to say type props type, but it doesn't have as much in it. It just has the view cart, really. So we can just say view cart, and that's a Boolean. And after that, we can say we're going to receive the structure, essentially the view cart right here. And this is going to be the props type. And then just inside of the component, let's once again use cart, and we'll say const, and we'll get our total items and total price once again. And that will both be set equal to useCart. After we have that, let's define the year, because we want to display a copyright in our footer. And yes, this is going to be a number type, and we'll just set this equal to a new date, and we'll get full year. And that way you don't have to update the website every year. It's going to automatically figure out what the year is for you. Now let's define page content. This will be the biggest part of the footer, really. So we'll say const page content. Let's set this equal to a ternary once again that looks at that view cart value. And here, if this is true, we're going to display a line that says shopping cart, and then the copyright symbol, that's an HTML entity there. And then we can put in that year value we defined above. But if it is false, then we're going to provide a parentheses here so we can use multiple lines. I'll use a fragment, and inside of the fragment, I'm going to put in 3 different paragraphs. So I'm going to have total items, and here we'll put in the total items value. And after that, let me just copy this down with Shift Alt and the down arrow twice. So after total items, we're also going to have total. Let me undo that. And what I should have done is highlight items and then press Control D, and I got the next items, and I can just type price once. There we go. And then finally, we'll have shopping cart here at the bottom, and this should also have the year and everything that was basically up here. So I could just copy this, because remember, this won't show, it's a ternary. So if view cart's true, it's just going to see this line. Otherwise it sees this line. So essentially we're providing this information either way. And save, and now it's almost finished, but in the return, well, let's go ahead and create a content and not just put it in the return. So I'll say const content, set this equal to, once again, parentheses, a footer element that has a class name of footer, and then inside of this, we'll put the page content. And now that we have that, we'll just return that content once again. So highlight that and change it to content. Now the footer is complete, and we have brought in the data that we need from the cart context as well. With that complete, let's go ahead and open up a terminal window with Control and the backtick, and I'm going to type npm run dev to launch the project, and we can see what it looks like so far. I'm going to press Control and click on that local host. Let's do that, and it launched it. And here we go. We have got our header with the product list. It just says product list inside of a div right now. And we have our footer. And if we press the view cart button, it should toggle over and it shows the cart. And we can see our footer change to just show the shopping cart. And we see some information here at the top too. Now, total price doesn't have anything in it right now. Total items is 0. That's okay. And it shows the cart. When we come back, the same thing here at the top. So we're getting the expected results, but we have a little bit more to go yet. So let's close the terminal. And now let's move on to the product list. And speaking of products, we're not really pulling in those products. I didn't start up the JSON server like we used in the previous tutorial. And remember, I said if you wanted to deploy this after developing with JSON server, it might be easier just to go ahead and put these items in here with hard code. So that's what I'm going to do. I'm going to comment out the initial state inside of the products provider. I'm going to highlight all of this as far as the initial state and uncomment it. And then we won't really need the area that has the use effect. I did want to show how to do that because it contained the promise that we worked with, and that reviewed part of what we learned in the TypeScript series. But overall, we're not going to need to use that when we hard code those items in. So I'll just highlight the use effect, and I will comment that out and save as well. So no need for that unless you want to use the JSON server right now. Otherwise, you can just use these hard-coded items here in your context, and that would be easier to deploy this example project with. Okay, now going back to the products list, we need to import that useCart hook at the top, and I just typed over something. There we go. Not to type over the product list, but we need to import the useCart hook. And then I'll just press tab and we import that, but we also need a use products hook. So let's go back to our hooks directory and we'll create this use products.tsx. And now we have this empty file. I'm going to go to use cart actually, Control A to highlight it all, Control C to copy. Now just go into the use products file and paste it. And we can just change the few things that we need to change when we create this hook. Basically, everywhere it says cart, we need to change to products. So I've highlighted cart, and now I can see all of these on the screen, but just to make sure, I'll Control D as I select to make sure I'm selecting the right things. And there I've selected all instances with Control D one at a time. Now I'll type products, and it changes all of those over to products. And we've basically created our custom hook for use products because we need use context. We need the use products context type. We need the products context itself. And that is what we're returning then, is the products context. So after I save that, it's ready to go. And we can go back to the products list. Now at the top, we will import use products from that same hooks directory. And we're also going to need to import the use products context type. It looks like I could press Alt-Z just to wrap that, and then I'll tab to the end of the line, and we're ready to start bringing that information into the component. So here I'm going to have const, and I'm going to bring in dispatch, also the reducer underscore actions, and cart from our use cart. So different things than I brought in to the header or the footer, but they're all available from that use cart context. Then I'm going to bring in products, and that's really all you can get from the use products custom hook that is the use or the products context itself. So now that we have the information, let's go ahead and create some page content here as well. And I'm going to say let page content. And of course, if you ever reassign, you need to use let instead of const. And this is going to be a React element. And I want to press tab so it goes ahead and brings that import in up here at the top as well. Now that we know this is a React element, we're going to use the or symbol and say, or it might be an array of React elements. And then we can set this equal to, and for now, let's set it equal to a paragraph that says loading. And that just means we're, loading our products. So really, when you have those hard-coded in, this won't be an issue. But if you were fetching those from somewhere, such as we showed with the useEffect hook, or if you used React Query, of course, you might have a hook that would provide the loading state. But we're just providing this loading information here. And now if we have products, so I want to say if, and then I'll check the products and check the length property. And notice I used optional chaining there to say if there is a length, essentially. Now we can reassign that page content value. Let me scroll for just a little more room because this is going to take a little bit of space, and I'll separate it from the return as well. Okay, here I'll say page content. I'm going to set this equal to the products, and we're going to map over the products. So at this point, we'll say for each product inside of the map, and then we need to define something. We're going to define in cart to see if it is in the cart. If you remember, when we added a product to the cart, it instantly showed up on the product display that it was in the cart and it had a check mark. So here we're going to say if in cart, and this is a Boolean. And now we'll set this equal to our cart, which remember is our sorted cart items from the context, and that's what we're getting from useCart. Now we can use the sum method, and so we'll look at an item or each item one at a time. We'll say if the item.skew is strict equals, which is 3 equal sign, notice I'm using font ligatures so they're linked together there, is equal to the product skew. Then we have our in cart as true, which is a Boolean, because sum will check if any one of these actually is true. We'll say, yes, it is in the cart. And now we still need a return for our map method here. So now we'll provide the return, and I'll use parentheses, and we're going to use the product component, but we haven't created a product component yet. So this would be each product as we map over. Let's go ahead and create that now. And we'll just say product.tsx. And here we can just say RAFCE for now. Create a simple component for the product. Now back in the products list, we'll go ahead and create the full product and what we're going to pass in. And then we'll, of course, fix those props as we go. The product itself is going to receive a key as we map over. You need to do that in React. And this would be equal to the product.skew. After that, we'll go ahead and provide the product object itself. So we'll have product, and then we'll have dispatch that we received from that context. Now, dispatch does not have to worry about the referential equality because it already is. So we don't need to memoize it. It's already going to be equal to that. And then if you remember, as we set up the reducer actions inside of our cart context, we did memoize those. So we don't have to worry about these causing another render either. Now this product object is something we will have to deal with if we're talking about optimizations. And then in cart is a Boolean here, and we'll just pass down the in cart value as well. Okay, after that, we still need to close the product component. We've done that. And now this is what is being returned for each product as we map through the products here and create the page content. Now we do have the squiggly line, of course, because once again, these props aren't really matching up, and it looks like we didn't import product yet at the top. So let's do that as well. So we'll say import product. And now that we have that, we're still, yes, we're going to get something here because the props aren't matching up yet, but we'll go ahead and fix that inside of the product component. Now, after we've created this content, if we have products, we reassign content, we still want to create a content variable below. So I'll say const content, and I'll set this equal to, once again, using parentheses, and I'm going to have a main element with a class name. So I'll just say main, and then the class would be main. It's also going to have a second class, which is main, 2 dashes, and products. Press tab, and yes, we've got both of those classes assigned now. And then inside of this main element will be that page content we created, and then our return will just have content. Okay, we've created the product list component, and it maps over each of the products and displays those, but we are not finished yet with the product component itself. We have quite a ways to go there, actually. So let's go ahead and do that. At the very top, we have a few imports. We're going to need to import product type that comes from our products provider we have previously created. We also need to import a reducer action type that we had previously created, and we also need reducer action here. I'm going to press Alt-Z to get that to wrap down as well, and both of those come from the cart provider. Now, product is receiving quite a few props, so let's define our props type here for product. And here we'll start out with our product, and it's going to be the product type that was previously defined. Then we have dispatch. Now we're going to have to get dispatch's type. So let's go back to the other components that had dispatch where we're passing that down. And it looks like we bring it in here. Yes, if we mouse over dispatch, we can see it is React. Oh, I missed it. It is React.dispatch, and then it's the reducer action there. So we can copy that, go back to the product itself, paste that type right there. And after that, we need our reducer underscore actions, and this is the reducer action type that we had previously defined. And then we have in cart, which is a Boolean. And I know from one tutorial to the next, it may be hard to remember, but again, we did that heavy lifting in the first part of this project, the first tutorial, where we define these types. So you could go back and reference these in the appropriate context, whether it's the cart, where dispatch and reducer actions is coming from, or the product type, where it's coming from the products provider. And now we still need to destructure all of these that are being passed into the component. So we'll have product and dispatch and reducer underscore actions and in cart. Now we need to assign the type here, and it is going to be the props type that we just defined above. But let's go ahead and provide a return type as well. So here, this is going to be a React element that is return. And if I do that and press tab, yes, it imports the React element at the top as well. Okay, here's a discussion that is specific to using Vite with our project. And we've been using Vite throughout this tutorial series. So when we do this, we might have to work with dynamic images differently. And it's in a good way because this way also works with Create React App. But you might have been used to an old way that won't work with Vite, even though it did work with Create React App. So in the past, you might have said something like const image, and we'll say this is a string. And then we would set it equal to require, which is something we would usually see with Node. And then we would specify the images. So here I would say 2 dots to go up out of this directory, the components directory, and a slash, and then into the images directory. And if we look over here, I've provided images already in a directory inside of the source directory. We have the images directory, and we have our different product images. And we want to dynamically create this. So from there, we would go ahead and provide the next slash that's needed, and I had the wrong direction for the slash. Let me just fix that real quick. Slash images, there we go. And from there, we would say slash, and I would say product.skew, so we would get the actual item number that we needed, and then have .jpeg. Now, this would probably work for the old way of doing things. And here we have require, and of course, TypeScript doesn't like that. We would need some type definition that would come from Node as well. This is the old way of doing this, and it won't work with Vite. It just simply won't. So let's go ahead and figure out a better way of doing this that will work with both Create React App and Vite. And what we're going to do is define a new URL object. And here we're going to pass in, I'll start with the backtick again and use a template literal and go images. And after images, we're going to have the slash $, I'll say product.skew once again, and then we'll have .jpg. So we've created a URL from that, but we're not quite finished. And you could MD in the new URL or the URL object to see what this is, but you might also want to look at import.meta, and there's an MDN page on that also. And then I'm going to say .url. So we're getting that specific data, but we're not finished yet. We don't really want the object. Notice image here is supposed to be a string that we're dynamically creating from this data. So what I need to get that string is just the href value from that object. So now that will return a string that we can refer to the image, and yet when we build our project with Vite, it is still going to point to the correct image that we are dynamically referring to. So this might help you out if you were not aware of that. And really, to compare, we could put in a console log, and I'll just leave this in here, image, and you'll see it in dev mode, and it will have one address. And then, of course, after you build your project into production, then you could see this console log value again in the console, and you will see that it has a completely different address, but Vite recognizes that, and this will work as far as I know with Create React App as well. Okay, after that, let's go ahead and define our onAddToCart function. So I'm going to say const onAddToCart, because we're going to need that for these products, or for each product, because we're in the product component. So we have onAddToCart. Now that we have our arrows here, actually, instead of the curly braces that I would normally do here, I'm just going to make this a one-liner. So really the curly braces would break it down to another line. I'm just going to start right here and just go with dispatch, parentheses. Now I can say the type and say reducer actions. And then I can use dot notation to get that autocomplete, and I want the add type. And after that, I can specify the payload. And here I'm going to spread in the product, and then I'm going to provide a quantity of 1, because we really need to provide all of the different properties of the product. Now, when we add this and we look back at the reducer, we're not going to be looking at this add to cart quantity because it's always going to be 1. But if we don't provide this here, we would get an error. And I didn't want to make the quantity optional or any of those different properties optional. So you could look at different ways of doing that, but that's how I'm putting it together. Let's also define the item in cart. So I'll say item in cart, and this will determine what we display, whether it is in the cart already or not. So we'll look at that in cart value. And now I'll use a ternary here once again, and I'm going to put some single quotes, and I'm going to copy this in because I've got a special character or two. So I've got an arrow and a check mark that I got as an emoji. But this is what I want to display if it is in the cart. And you could copy that out of my source code, or you could use your own emojis or arrows or whatever you want to. If it's not in the cart, we'll just make it null and we won't display anything. Now let's scroll for some more room, and let's define some content that we will be able to return. So I'll say const content, and I'm going to set this equal to, and I could once again provide parentheses here, but I don't think I really need to because it's going to be wrapped in a parent component. So let me go ahead and just Control Z to undo those parentheses. And I'll just break this down to the next line and say this is an article element. And I'm going to give this a class of product. Now inside of the article element, we're going to have an H3. And then inside of that for its content will be the product.name value. And then after the H3, we'll go ahead and use our image. And so we'll need an image element, and this is going to have a class of product, 2 underscores, and img. And then we need to provide a source value. Well, we've already kind of defined that above, so all we have to do is say it is the image. And then for the alt, this could once again be the product name. So I'll just copy this and put it right here. And then the class name is product image. That all looks good. Underneath this, let's put a paragraph. Now inside this paragraph, here we're going to do something just a little different. And this is going to give us our format for what we're going to display here. So I'm going to say new international, which is INTL with a capital I, dot number format. Here I'm going to say that this number format is English US. Of course, you could change this if you prefer something different there. And I'll say the style is going to be currency, and then a comma, and then currency as a property, and I'll say USD for US dollar. Now, once we get to the end of that, here at the end of the parentheses, I'm going to say dot format, and then inside of this, we're going to pass in the product dot price. So we're formatting the product price, much like we did the total price that we were passing from the cart context. But here, this is just for each individual product. So we just kind of need to format this as we go, and we're doing that here. And then after that, we need to go ahead and provide something else. So we're closing that out, but I want to show the item in cart. So we get that check mark beside the price if it is in the cart. Okay, after that, we need one more thing, and that is the button. And then we need to put an on click on this button so we can add it to the cart. So this is going to get the on add to cart function for the on click. And we'll say add, let's go lowercase there, add to cart. And that defines the content all inside of this article element. And then for the return, should just be the content itself. Okay, I'd like to check our progress in the browser, but before we do that, we need to remember to wrap our app with the providers we have created, and that's something that's easy to forget. So let's go ahead and do that now. We'll actually need to import those first, so I'll say import cart provider, and I am in the main.tsx file, which in Vite is similar to the index.js if you use create React app. So this is main.tsx. So we've imported the cart provider, and now let's import the products provider as well. You'll see it down here in the list. Now that we have both of those, we're just going to wrap the app component in both of them. So I'll start with the products provider and press tab. And now I'm just going to put the app inside of both of these when we finish. So now I'm going to say cart provider, press tab again. Now that I have both of those, I'll just go ahead and highlight the app, Control X to cut it out, paste it in so it is wrapped inside of both of those. Now with providers, like context providers, as these are, you don't have to wrap the entire app in those. Maybe you're creating a context that just a single part of your app needs, maybe the user info or user settings, something like that. And you would have a provider for that, and you would just wrap those components specifically with that provider. For this example, just wrapping the entire app in both the products provider and the cart provider. Okay, now that we have completed that, we could go back to the product list that we completed, or the product. Here's where we were there. But what we need to do really is go ahead and take a look at our browser and see how it's going over here. So I'll drag this to the left, and it looks like, yep, it's compared to our previous example that I was showing at the beginning of the video. Now this is the one we're working on, and we're showing all the products as well. It looks just like it. We have the zeros over here expected for the total price, the total items. Everything's good there. We just don't have anything for the cart yet. We still just have the word cart here. So we need to complete that. With the product display working, let's now move on to the cart itself. So we'll go to cart.tsx. At the top of the cart, we have a few imports to take care of. So we'll start off by importing the cart context. So we'll say import useCart and press tab. Once we're at the end of that, we can also import the useState hook that we're going to use just to confirm we've placed an order here. And after that, we need a cart line item component, and we don't have that yet. So let's go ahead and create that component. It's cart line item, all camel case, starting with a capital C, .tsx. Now I'll just use RAFCE with my ES7 React snippets to go ahead and create that simple component for now. And of course, we'll come back and add more details. But we need to import it here. So let's go ahead and import cart line item as well. Now we have all of our imports. Now let's go ahead and set up the use state here at the top. So I'll say const, this will be confirm and set confirm. And we'll set this equal to use state. Once again, you could go ahead and specifically say this is Boolean, or you could let TypeScript just infer. We'll go ahead and put the Boolean here as well. And now after the use state for confirm, we need to use that use cart hook to bring in the context, and we need everything for our cart. So I'll say const, we'll have our dispatch, then we'll have our reducer underscore actions. Let's have the total items. Let's also have the total price, and let's get the sorted cart itself. I'll press Alt-Z to wrap this down to the next line. We'll set all of this equal to use cart. Now we've got all of the data we need. Let's create a simple function here called on submit order, so we can go ahead and at least have that submit button submit and clear out the cart. And inside of our on submit order, we're going to use the dispatch. And anytime we need to use the dispatch, of course, then we have to provide the type, and this is going to be reducer underscore actions, and then we can use that autocomplete with the dot notation, and we get submit. After that, I also want to do the set confirm that we just defined above with use state, and I'm going to set that to true. Now we have some page content to define, and it's going to take up some space. So I'll say const page content, and I'll set this equal to, and I'm going to look at that confirm we have as a Boolean, and I'll use a ternary. And so I'll just indent in. I'm going to scroll up since I said it was going to take up some space. We'll start off with an H2. And really, then if confirm is true, in other words, we've placed the order, we'll just give a thank you for your order statement here. But if it's false, this would be the other part of the ternary. We'll start out with a fragment, and then we can put everything inside of this opening and closing fragment. So I'll have an H2, and let's give it a class of off screen, which, as the name indicates, this makes it shift off the screen, but it's still good to have this. So we're just having the subheading there for the cart, but you will not see that on the screen. Then I'm going to have an unordered list, give it a class name of cart, and then inside of this unordered list, we're going to map over the cart. So we'll say cart that we get from our context dot map, and now we'll have cart items. So for each item, and remember, we need to return inside of this map. So here I'm going to say return, use parentheses so we can use multiple lines. We're going to use our cart line item component, but we don't want to close it out here. We have props to pass down just like we did for the product. So the key is going to equal the item.skew, and then the next thing would be the item object itself that we'll pass down. And then we also want dispatch, which remember, it already has referential equality, so it will not cause a re-render. We will have to handle that item object. And then the reducer underscore actions, which again, we did memoize already inside of the context, so it will not cause a re-render either. Okay, after that, we'll have our closing slash and greater than sign, and we've closed out our cart line item component. We'll have the underscore here on the item for now, but we will fix that when we get to the cart line item component itself. So we mapped over everything, and we've created this list of cart items essentially. But we're not quite finished because we also want to provide some totals here after the unordered list. So let's provide a div. I want lowercase. Let's give this div a class name of cart 2 underscores totals. And then inside of the div, we're going to have some paragraphs. So the first paragraph is going to have total items. And here we will use the total items value from context. And now I'll just copy this down with Shift Alt and the down arrow instead of items. And I'll highlight the first one, Control D to get the second one, type price. So now we have total items and total price. Then we're going to have a button, and this button is going to have a class that is cart 2 underscores submit. And on the button, we're going to say place order, but we also need to apply a couple of other things to this button. So we're going to have disabled set equal to the opposite. So use the bang operator there, the exclamation mark, of total items, which means essentially if there are no items, the disabled will be set to true, and so you won't be able to click the place order button if there's no items in the cart. Then we'll also have an on click, and we'll set this equal to that on submit order function that we created above. Now, after all of that, let's come down here to the closing part of the fragment. I'll give it just a little bit of room. I'll tab in. I'm going to create content. Looks like I tabbed too far, but that should adjust here after I go ahead and finish this. I'm going to return a main element, and it's going to have a class name of main and also of main, 2 dashes, and cart. And then inside of this main element is where we're going to return the page content. When I save, yes, that shifted back to where it should be. Now we have our return statement, which once again should just be the content itself. So now we've completed the cart. We haven't completed the cart line item yet, but everything looks good here. We're providing this extra information at the bottom of the cart after the cart line items. And now we, of course, need to fix our cart line item to get TypeScript to not give us this red squiggly mark under item here, but everything is as we expect it to be. So now let's go over to our cart line item component, and we once again have a few imports at the top as we begin. So I'll say import, we'll import our cart item type, and after we get the cart item type that was previously created, we'll also import the reducer action once again, and I need the one that comes from the context cart provider. And after that, we're also going to import, I need to have my fingers on the right keys and also be on the right line. There we go. Import reducer action type that will come from the cart provider. Okay, with those 3 imports, we're ready to start out, and we'll define our props type for this component. Now let's have an item, and this will be the cart item type that we already brought in. And after the item, we're going to have the dispatch. And remember how we got that before? We can do that again. We're also going to have the reducer underscore actions, and that would be the reducer action type right here. Okay, we can save this, but let's go get that dispatch again. So here, if we mouse over dispatch, here's the type. It is React.dispatch, and it has the reducer action. So we'll copy that. Go back to the cart line item and paste that right in. And now the component needs to receive those props, so let's destructure those here. We have item, dispatch, and reducer underscore actions. And after that, we can just set that to the props type that we just defined, Alt-Z to make all of this wrap down. And now we once again have the same image, dynamic image essentially that we did before. So we could just kind of go back to our product and look where we got that dynamic image defined here. And I can just copy this, and you could use the console log statement again if you want to. Again, I'm leaving that in there just so you could see how it works from dev mode to production and see how it changes. That works with Vite for sure. I'll paste that in. I'll go ahead and remove the console log here, as you probably don't want it in both places. But notice now we're not using product here. We're using item instead. So I need to copy that and replace product with item.skew. Okay, now we have just a few more calculations for our cart line items. So let's start off with the line total. And this is going to be a number. So I'll go ahead and spell that out. And this would be the item.quantity times the item.price. This is something we're not keeping in context. This is something we're just showing with the line item. So we're calculating it right here. It's not really an expensive function. It's not something I would go ahead and bring in, use memo to memo-wise, but it's just a quick calculation. The same thing here with how we create the options in the drop menu. So I'm going to call this highest quantity. And normally it would be 20. So this is a number, and I'll set it equal to 20, but if 20 is greater than the item.quantity, so it's starting out here with a conditional, and that means we're going to have a ternary. So if 20 is greater than the item.quantity, we'll make 20 the highest quantity that you can choose in the cart. Remember, there's that drop menu where you can change the quantity, and so it would go from 1 to 20 in that case. But otherwise, if the item quantity is higher, then of course we need that to go higher. So we'll just set it to the item quantity being the max there for the highest quantity. Now let's go ahead and create those option values for that select dropdown. So I'll say const option values, and this would be an array of numbers, Now here, I'll just create an array, and we will spread an array, and we'll pass in the highest quantity, and then we'll say dot keys. And now after this, we can use a little bit more dot notation. We'll just map over it, and then we'll say basically for each integer, I'll just use I for that, we'll say I plus 1, because otherwise it would start at 0, and we don't want that. So this would be like 1 to 20, for example, or if we had a higher quantity, it would be 1 to whatever that highest quantity is. And again, I don't consider any of these to be expensive calculations that I would need to memorize. Now finally, let's create the options. And this would be a React element. So let's go ahead and hit tab with that and make sure it has imported at the top, and there we have React element. But then we want this to be an array of React elements, actually. We'll set this equal to our option values. Remember, this is an array of numbers that we have up above. Let's map over that and say for each value. And then we can go ahead and have our curly braces. Now, since we did the curly braces, instead of making it a one-liner, we need the return. And this will be an option element. And then we'll have a key. Let's set this key equal to a template literal. And here we're going to say OPT, have a $, and pass in that value. So that is the key as we map over these. And then we'll have an actual value, which will be equal to the val. And then we can close that out. And then we want to display the value in the option dropdown as well. I know that's a little bit there as we create that select dropdown, but really it's not an expensive calculation, at least in my mind. And I don't really think it is. It's nothing that would slow your computer down. It happens very fast. So from there, we need an onChangeQuantity function. So we'll say onChangeQuantity, and this is going to equal a function that receives an event. Now this event is a change event. So I want to hit tab here so it imports that at the top as well. And it will be for an HTML select element. I can press tab there as well. Now I've got it. Now that I have that, let's go ahead and provide the arrow for the function. And inside the function, we're going to use dispatch. And I can put the curly braces here, and then we can just specify the type. And the type is going to need the reducer actions that we imported, and we need that auto completion with the dot notation. We get quantity. And on the next line, we can specify the payload, and the payload, we have an object here. We spread in the items, so we make sure we get all of the properties, and then we write over what we want to change, which is the quantity. We need to specify this as a number, an e.target.value. But we're not quite finished yet. We've defined these, we haven't used them yet, and we have one more function, and this is for the remove. So now we'll say const on remove from cart. We'll set this equal to a function, but no event needed there. And now we can make this a one-liner. So I'll just go ahead and start with dispatch right here, and I'll break the dispatch down onto separate lines again. So we have type reducer underscore actions, auto completion with the dot notation, and we can choose remove. And then we also have the payload, and here curly braces, spread in the item. And really, we don't even need to spread in the item. I need to stop and think about that. Or we don't really need the curly braces even. We could just say payload item. This is the item we're passing along that we want removed. And of course, we'll just grab the ID out of that item when we get to the reducer. If, for example, we try to just provide the ID here, you can see TypeScript won't like that. It expects all of the properties the way we set this up. And again, you could do that differently, but I wanted to require all of the properties in some areas. If you had a huge object, you probably wouldn't want to pass that object into everything where you only needed one of the property values. But here we've only got 3 or 4 properties. Okay, let's scroll for some more room, because as we create this content, it's going to be rather large here. And we'll say const content, set this equal to, we'll have our parentheses. Now let's start off with a list item, because that's what we have. We have this list that is being mapped over, and the class is going to be cart 2_ item. Press tab, and now inside of this cart item, we're going to use our image element. We have a class name here that is cart 2_ img, but it's also going to need a source, which just like before is going to be set equal to the img for the image. Go ahead and set the alt equal to the item.name, and that's all we need for the image. So after the image element, let's create a div, and this div is going to have, well, let's press tab here. This div is going to have an aria-label that we can set equal to item name, because it's not going to just give that in the cart as at the top of the column, I should say. So this would at least add some accessibility there to say, what is this about? And then we'll have item.name and the curly brace. Now I can copy this one down, Shift Alt and the down arrow. And now this is going to be a price per item column. And here we will have a format once again to get our new international number. So it will say new intl dot number format, and then after that we need a parentheses, and we will have our en-us. Remember, you could change this if you want to. The style once again is currency, and then we set the currency property here to USD. And then after that we still need to chain on our format, and inside of this we're going to pass the item.price. So we're formatting the item price to the currency that we want to format it to. Okay, after those we're going to have a label, and this is going to have a class of off screen, so we will not see this on the screen. And it has an HTML4, and this needs to be for item quantity. And that's what we're going to set here between. So we'll just say item quantity. Now, after we do that, we of course need to provide that select element that this is for. So select, and this has a class name of cart 2_ select. Press tab, and you can see it has several other things it knows we need. One is the name, which we could just use the same item quantity. We wouldn't even have to provide the name if we don't want to, but it's not a bad habit. Here, the ID needs to match the HTML4, so we have item quantity there, and the cart select, but we have a couple of other things we want to set. And so I'm just actually going to put these on separate lines, and it's easier to read this way too as we go down. So here are the 3 things we currently have, but we want a few more in here as well. So I'll move this over, scroll up. So we've got name, ID, class name. We want a value already set, and this needs to be the item.quantity. After that, we're going to put an aria label and set this equal to item quantity. And then let's put an onChange, and let's go ahead and call our onChange quantity function. Now, inside of the select here, and I could just move this back up as we close it out, we want to put in the options that we created above. Okay, 2 more columns to go for our cart line items, so I'm going to scroll for some more room again, and this is just going to be a div with a class of cart 2_ item dash subtotal. Press tab, and we've got that, but now as far as what goes inside of the div or the other attributes, let's go ahead and add the other attributes first. It would be an aria-label, and I'll set this equal to line item. Let me go ahead and change that to a capital line item subtotal. And then after that, inside of this, we're going to have another format with that new international formatting here. So I'm going to copy this because a lot of it will be the same. Come down here and put it here where the curly braces are. There we go. And now what we're formatting is the line total instead of the item price. So I'm just going to pass in the line total that we got above. We already defined that up here when we multiplied that, a simple little equation. And so now we have that formatted, and the final thing we need is a button just in case we want to remove from the cart. So this would have cart 2 underscores button, but it's going to have a few other attributes. I have been told I pronounced that incorrectly. One thing I want to do is just put a red X on there, and I've got the emoji for it. I believe I got it at emojipedia.com. You could find an emoji you want or put something else, but that really indicates you're going to delete the item. Okay, so after that, I'll break these out onto separate lines as well. So after class name, we're going to add an aria-label here, set this equal to remove item from cart. Then we'll have a title for the button, and we'll once again just say remove item from cart. This one should show up if you mouse over the button as well. And then finally, we'll have our on click. We'll set this equal to on remove from cart. And once we save that, we should pretty much be complete as far as the line items are concerned. And then we would return the content we defined right here. Let's scroll up to make sure all of that looks correct. We define the content, and yes, everything's looking good. So I think we've got it all. Now let's go ahead and drag this back over and see if we can add an item or two. This is the current one, so I'll add this item in cart. That's good. I'll add this one. A couple of items in the cart. Let's scroll down. Our footer looks good as well. Let's look at the cart. So now we have our widget and our premium widget both added, and we have just one of each for a total of 2 items and a total price here. Let's change this now to 10 items. And yes, now we have a total of 11 items, and we're not seeing some of the columns just because of how I've got the CSS. But once we have a wider screen, we'll see more of those columns. So now you can see our subtotal here just for this line item is 99.90. And now we see the images as well. Now when I drag this back over to a smaller screen, it eliminates some of that so it can go ahead and fit. So that's why we were missing some of those before. We can change those items here. We can go ahead and delete an item if we want to. We can go back and view products, add more to cart. We can continue to click this and notice the numbers go up here in the header and in the footer as I add more items. Now let's go back and view the cart. Now notice we've got a 28 here, where before this maxes out at 20, but we set that to equal the highest number, the highest quantity, and that's completely off the screen when it drops down, but it is 28 when we do that. So there you go. And of course we can place the order and it just clears out the cart. So everything's as it should be. That really completes the project unless you want to go ahead and add some optimization. So I want to go ahead and add some optimization with Memo from React, and we can do that to the cart line items. We can also do it to the product. So since we're on the cart line item, let's start there. Now at the top, we've already brought in the change event and React elements. So let's bring in Memo as well. Here it is. So we're going to import Memo, and now we'll use it below. So let's go ahead and scroll all the way down. Sometimes you see it as react.memo, but we don't need that if we just import Memo. So what I'm going to do, instead of this export default cart line item, I'm going to create a memoized cart line item. So I'll say const memoized cart line item. I'm going to set this equal to memo. And now here, this is going to be a type of cart line item. And now what we'll pass in is the cart line item component itself, but it also takes a function, and we're going to need that function to make this work correctly. We also want to have the default export now be the memoized component. So you really need a function here to see if the items are equal, because we're passing in an item object, and that object will never have referential equality. It would always be a new object as it's passed in. So we need to create the function that will compare. So let's do that above. I'll just say function, and I'm going to say R items equal. Now this is going to receive the item, and we'll say previous item is what we're going to rename it essentially. And then we're going to have props type. And if you remember, we already defined that props type above. So we have that, and then we're also going to have the item, and we're going to define next item, and this would also be the props type. Okay, after that, we'll have our function below. So what we're getting here is the previous item we're going to use and the next item, and that's what you would typically have in a function. We're getting both of those from the item object. Now this gives us a chance to use one more thing we went over in the TypeScript series as well as we compare these objects. So I'll start the comparison here. I'll say return, and it's going to be object.keys. I'll pass in the previous item, and now we'll say .every, because object.keys will give us an array of those keys. So for every key, now we have our function here, and we're going to return previous item. And now we'll have a problem here if we just say key. TypeScript won't like that, but we can say as key of part item type. And TypeScript's okay with that. So we did have a video on that in the series, and we're using an assertion here. And we're using this key as key of cart item type, so it identifies it for TypeScript. Then we can say if it is strict equals, that's 3 equal signs there. Once again, I'm using font ligature, so you see it all linked, but it's 3 equal signs. If it equals the next item, and once again, we have to say key as key of cart item type. And now that's good. So we're comparing every key, the previous and the next, essentially. So we're making sure that they're the same. And if all of the keys are the same, we're going to go ahead and be returning true for our items equal, because that's the one thing, the one prop we were essentially concerned with passing in. If we look all the way back up here, dispatch already has referential equality. Reducer actions we have already memoized in the context. So we're not worried about either one of those. But the item object, that was our problem. So we just need to compare and make sure all of those values in the object are equal. And if they are equal, then we're good. So we need to use this function, and memo accepts the function as the second parameter there, the second argument actually that we pass in. And now if I save, we should be good. And now you could use React Dev Tools to see if it re-renders, and it shouldn't re-render. It should only render the cart line item that you change. Of course, it will render all of the line items first when you display the cart. But after that, if you change the quantity of one of the cart line items, the others should not re-render. And you should be able to see that in React Dev Tools. Now, I should leave this for you to do as a challenge, but let's just go ahead and do it to the product component as well. So at the top, we already brought in React element. Let's also bring in memo there as well. Now we'll scroll down to the bottom, and we want a memoized product. So we'll say const, and then we'll say memoized product, going to equal memo. It's going to be a type of product. And then we're going to pass in the product, but we also need our is equal function essentially. But when we default, we need to remember that we're also going to default export or export default the memoized product and not the product itself. I spelled something wrong. There we go. Memoized product. That's another nice thing about TypeScript. It told me right away, hey, I did not recognize what you typed. So now memoized product is being exported. We've got this. We need to create our comparison function though, our is equals. And so what we want here is function. Let me scroll up once again. I'm going to say our products equal. And then this is going to have a product that is received, but we want the previous product. That's what I am naming this. And then in cart, and this is a previous in cart that we can compare to. So we're not just comparing the product object, we're also comparing the in cart value. We're making sure that all of those are the same. Then we can say that's from the props type here. And then after that, we can once again have product, and this is going to be the next product. And then we would also have in cart, and we're going to name this the next in cart. And once again, the type here is the props type. Okay, now we're ready to define the inside of the function. So we have our curly braces. We're going to return, and let me just use parentheses, and I will have object.keys, pass in the previous product object. Once again, for every key, have our arrow, and inside this function, we will return the previous product, and here we'll have key as key of product type. Now, if this is confusing, also don't just look at the assertions chapter in this series, look at the index signatures chapter as well. And that's where we went over a lot of the detail on this and why you need to do this. Then we'll have next product, and we'll say key as key of product type. So we're comparing, once again, all of those values in there. But remember, we also have the in cart. So after we've done all of this comparison, we need to go ahead and add. So I'm going to say, well, what I need here is after we've compared this, I need to put it right here and say, and with double ampersand, previous in cart equals next in cart. And if you remember, if we scroll up and look at that, the in cart is just a Boolean. So there's no real magic there. There's nothing we need to turn into an array and compare. We're just doing a straight up comparison. But that is our products equal function for our memoizing our product component. So we also need to pass it into memo as it accepts that there is the second argument. And now you could do the same thing when you go ahead and add to cart, and then you could see if it re-renders every product or if it just renders the single product. And it should only be the single product when you make a change like that. Okay, I'll drag this over and let's look at our project in the full screen, and everything is complete. We can add items to the cart like we talked about. We can look at all of those items in the cart here. We can go to add more quantities of things as well, and everything looks just fine. So I hope you enjoyed this project and this TypeScript series and learned more about TypeScript and React along the way. Remember to keep striving for progress over perfection, and a little progress every day will go a very long way. Please give this video a like if it's helped you, and thank you for watching and subscribing. You're helping my channel grow. Have a great day, and let's write more code together very soon.